Welcome to Learning Linux Security. We're going to be spending quite a bit of time together over the next several lessons, and I hope that we can give you a little bit of insight into what Linux security is and how you go about securing a Linux system. First of all, Linux is an operating system. Primarily, what we're talking about is hardening that operating system against attack or compromise. We'll be looking at some tools and we'll be looking at a number of different methods that you can use to actually harden your operating system and the services that are running on it. What we're going to be doing is a lot of hands-on work. We're going to be doing a lot with command line. So you're going to get really familiar with doing command line. In my opinion, command line work is really the heart of systems administration and security administration on a Linux system. If you are really hardening your Linux system, you won't have a graphical user interface. You will be stuck with the command line. So really getting comfortable with the command line is helpful. We're going to be working with multiple distributions and again, continuing to get a lot of hands-on work. I hope that you really enjoy getting your hands dirty and playing around with Linux and learning Linux security. I'm sure you're probably wondering what we're going to be covering. First of all, we're going to be talking about distributions. What is a distribution? Different distributions that are available. CentOS, Red Hat Enterprise Linux, Ubuntu, Linux Mint, Fedora Core. There are lots of different distributions that are available. We're going to be working with a couple of them, primarily Red Hat Enterprise Linux by way of CentOS, and we'll be using Ubuntu as well as a specialized Linux distribution called Kali Linux, which is really useful if you're doing security testing work or things related to forensics. We're going to talk about the boot process, the different bootloaders, and how you can protect the boot process against attack and making sure that people aren't getting into your system when you don't want them to. So what are services? We're going to be talking about what services are, how to manage those services, and mostly we're going to be talking about hardening the different services. So the Apache web server, for example, a couple of different Java application servers. We're going to be talking about mail servers. So we're going to be going through the process of hardening your servers against attack. Logging is a critical component of a Linux system. We're going to be talking about logging using syslog, how to manage your logs, and how to send your logs off to remote systems so that you've got them somewhere else just in case something happens to the system that you're doing the logging on. We're going to be looking at some intrusion detection, both host-based and network-based, and also how to manage IDS and the alerts that you're going to get from your IDS products. Users and permissions, adding users, setting password policies. We're going to be talking about mandatory access controls by way of the use of AppArmor and SELinux, and we'll also talk about using pluggable authentication modules. A lot of utilities, networking, security related. We'll be talking about a couple of vulnerability scanners and looking at how those work. We'll deal with the Linux kernel, look at the kernel source, what are modules, kernel modules, how to make use of kernel modules, configuring the kernel, building the kernel. We'll also get into firewalls, iptables, Firewalld, and the uncomplicated firewall that Ubuntu has. So you can see we're going to cover a lot of ground. As I have said previously, it's really hands-on. So you're going to actually see how to do the work of hardening your operating system and actually see how the tools work when you're running them, what you can do with them, and how to make use of them. Before we really get underway, let's talk about what Linux is. Linux is actually really the core operating system of this thing that you're looking at here. When you start adding the user interface on top of the core operating system, what you end up with is really an operating environment. The operating system is actually the kernel. It's the thing that interfaces between the hardware, make sure that all of your programs get enough memory and get into and out of the CPU so that they actually run, and between that hardware and the programs that you actually use, so for example, this terminal window here, we need some software that's going to manage that hardware and make sure your programs are run, get memory, and are well taken care of. And just in case you've got, for example, disk drives, we need software that's going to interface with those disk drives. So we've got the operating system, or the kernel, which is actually what Linux is. When you start adding in all of the other components, like the user interface that we're looking at here, or the desktop environment that we're looking at, you actually get an operating environment, but you get a Linux distribution. So different Linux distributions are going to have different packages that are installed with them, meaning different software. It's going to potentially do things in slightly different ways, but at the bottom of it all is this kernel or operating system that we call Linux. So you'll see that this says GNU Image Manipulation Program. Some people actually like to refer to the complete package as GNU Linux. I think that's just as misleading as saying Linux when you're talking about the whole package, because GNU is not the only project that contributes software to the entire distribution. There are a variety of other projects, and we'll talk about some of them through the course of these lessons. And those different projects all contribute software. It's not just GNU that contributes software to Linux distributions in addition to the Linux kernel. But ultimately, what we're talking about is a collection of software that gives us an operating environment that is different from Windows, different from Mac OS X. It's really got the heritage of an operating system that's almost 50 years old now. It's really kind of based around Unix, the operating system, which was created in the late 1960s by AT&T Bell Labs. So Linux kind of takes a lot of the components and functionality and features and ways of working that Unix had, and does it in some slightly different ways with some newer technology, and of course, a different take on it, because it's got a completely different set of programmers implementing those features and that functionality. So when we're talking about Linux, Linux itself technically is really just the kernel or the operating system. The operating environment includes pieces of software from KDE, for example, and Apache, and of course GNU as well. So there are a lot of different groups that contribute software to these Linux distributions, and we'll talk about the different distributions that are available and how they are different from one another in an upcoming lesson. Now that we've talked about what Linux actually is, let's talk about the different flavors or distributions of Linux. One of the best places to go if you want to look at different distributions that are available is DistroWatch. DistroWatch keeps track of the latest releases for all of the different distributions. So let's talk about, before we get into some of the different distributions, what a distribution actually is. A distribution is a collection of software that is packaged together to make it easy for you to run Linux. So Linux, again, is the kernel or the operating system, and a distribution collects a user interface on top of the kernel, as well as a lot of other user programs, including those from the GNU project. So we've got a lot of software that you could potentially use, including some different office suites. You've got a number of different desktop environments like KDE or GNOME or XFCE, for example. Different distributions may use different desktop environments as their default, which doesn't mean you can't get the other desktop environments for that distribution. It just means the default may be GNOME, for example, or it may be KDE, or it may be XFCE. Now, different distributions also have different ways of installing software. That's done with package managers, and packages are ways that you would collect all of the executables and the libraries and configuration files for a particular piece of software, and you would put all of that together the package manager would make sure that everything got into the right place on your system. So currently, the top distribution is Linux Mint. Linux Mint is actually based on another very popular distribution called Ubuntu, and Ubuntu is actually based on another distribution called Debian. One of the primary differences between Linux Mint and Ubuntu is the user interface. Linux Mint packages a couple of different desktop environments, one of which is called Cinnamon and the other is called Mate. And those are based on GNOME, but they look different than most other GNOME-based desktop environments will look. So they've created a different look and feel for Linux Mint, even though the package management is going to be the same as Ubuntu and Debian, which you can see are numbers 2 and 3. Another very popular distribution is Fedora, and that is managed by RedHat. Although it's community developed, it's actually a distribution that feeds into the RedHat distribution, RedHat Enterprise Linux. So this is where a lot of the development effort for Fedora goes in. Now, where Debian and Ubuntu use the apt set of utilities for package management, Fedora and Red Hat Enterprise Linux use the Red Hat Package Manager, which is RPM. So again, you've got different ways of doing package management across the different distributions of Linux. So you can see there's actually a fairly large number of different distributions that are available. There's just 100 here. There's actually several hundred that are available, and you can certainly start digging really deep into the list and start playing around with a lot of the really smaller distributions just to see how they differ. But the top distributions are, again, the Debian-based ones, Mint, Ubuntu, and Debian. There's also Fedora. There are a couple of distributions where all of the software is built when you need to install it, and we'll talk about those types of distributions coming up. There's a couple of different ways to think about Linux distributions. One of them is comparing binary-based distributions to source-based distributions. Now, a source-based distribution is one where all of the packages are actually built from source when you are ready to install them. A binary-based distribution is one where somebody else does all of the compilation, puts them together, and then all you have to do is install them. Now, the advantage to a binary-based distribution, of course, is the ease of use. There are a number of binary-based distributions. Of course, Red Hat is one of them. Red Hat provides all of its packages in the Red Hat Package Manager format, RPM. And of course, we've got Debian, for example, which is another binary-based distribution. You've got all of the packages that are created, and all you've got to do is install them. You don't have to actually create anything or compile anything when you want to install something. Now, there's a disadvantage to this. The disadvantage to the binary-based distribution is that they determine what all of the dependencies that are going to be installed are. Many packages have the ability to either include or not include a number of other packages based on what you're looking for. So distributions like Red Hat, Debian, Ubuntu, various other binary-based distributions actually make those determinations for you. They determine that the majority of people are going to use a particular set of packages, and they are going to actually use those as dependencies. A distribution like Arch, for example, does give you the ability to build your own packages depending on the dependencies and the specific subsystems and packages you want to install. So Arch uses a system called Pacman, which will actually install packages for you. Now, Arch will do either build your own, or they do have some binary packages as well that you can install. Another Linux distribution that is source-based is Gentoo. Now, Gentoo is very much a Linux from scratch distribution. So you start off with a very, very basic subset of Linux when you get going. And that is what you use to layer all of the other packages and subsystems on top of so that when you're done, you've got exactly the distribution that you want based on different sets of dependencies, different packages that you want to install. You've got a lot more control doing it this way. Of course, the downside to doing a from scratch distribution like Gentoo here is that it's going to take a lot longer to install because you are compiling everything from source, and there may be a lot of underlying dependencies that need to actually be compiled before you get the one that you really want to install and make use of. So you get a lot more flexibility, control, and power with a Scratch-based Linux distribution like Gentoo or Arch. Or you can also give up some of the control and the customization possibilities by using a binary-based distribution like RedHat or Debian. Really is up to you to determine which direction you want to go in, where you're going to feel more comfortable. You're going to learn an awful lot more using a Scratch-based distribution like Gentoo or Arch. You're going to be able to hit the ground running a lot faster with something like Debian, Ubuntu, Red Hat, or one of the other binary-based distributions. Before we get started, we're going to be installing a number of packages, and we'll also be talking about keeping your system up to date over the course of these lessons. So we want to talk a little bit about how to manage package installations and updates on your Ubuntu system. Now, Ubuntu uses a package manager called apt. Commonly, you're going to use something called apt-get. And apt-get has a number of different purposes. So I could, for example, install a piece of software. So I could say sudo apt-get install, and then I'm just going to install Vim here. Now you can see it's going to download, and then it's going to do the installation. Now, apt-get is actually going to check for dependencies and then install the dependencies that are necessary as well. So another thing that you want to do is you want to keep your tree of packages up to date. We're going to say apt-get update, and that's going to download all of the latest versions that are available. Once I have done an update, I can say apt-get upgrade, and then that will tell me what software I need to actually update to the latest version. This keeps my system up to date with everything. So I can do an update, which is going to download all of the latest versions, and it's going to tell my system what the latest version is. And then if I run upgrade, what it will do is check to see whether I have the latest versions installed. So another piece of software that you can use is apt-cache. Apt-cache allows you to do things like search. And let's say we want to search for logwatch. So I've got a couple of different answers here. I've got logwatch, I've got check mkagent logwatch, and then I've got fw logwatch. I can do searches for pieces of software. If I don't remember the specific package name, what I can do is I can use apt-cache search, and then I can get the package name so that I can go do the install. So now once I know a name here, I can do apt-get install fw logwatch. So now that's going to install it. If I want to remove a piece of software, I can say apt-get remove fw logwatch. So now it's going to uninstall that piece of software. So apt-get is going to be what you're going to use pretty commonly. If you want to search for specific software packages, you can use apt-cache. So that's the apt system that you would use on a Debian-based Linux distribution. So that would include Ubuntu, that would include Linux Mint, it would include Debian, it would include any Ubuntu derivative. Those are all Debian-based. On a Red Hat system, we're going to use a different set of utilities in order to do package management, which is going to allow us to install packages and keep them up to date, as well as search for packages that we may want to install. What I'm going to do now is I'm going to search for a package here. So I'm going to run yum. Yum actually stands for Yellow Dog Updater Modified, and it relates to a Linux distribution called Yellow Dog that was related to Red Hat. Red Hat picked up this yum piece of software because what yum will do, which RPM will not do, is it will check for dependencies. Now, RPM is not only the package management format, it's also the utility that you would use to install an RPM package. So, going to do yum, and we're going to search for a piece of software called Vim. So every time you run yum, one thing that it does is it checks your mirrors to see whether everything is loaded and all of the latest versions are there. So these are the different packages that match Vim. Let's just say I wanted to install Vim-enhanced. So I'm going to say yum install Vim-enhanced. Now, the piece on the end, the .x86_64, is actually the architecture version. I don't need to include that. I do, however, need to be root, so I need to run sudo rather than just yum. I can, of course, do a search without being sudo because all I'm doing is looking for software. If I want to install something, I'm making changes to the system, and so I need to be root, so I have to do yum. So in this case, Vim is actually the latest version, and it's up to date, it's installed, so there's nothing actually to do there. Yum will check to make sure whether the piece of software you're trying to install is already installed. If it is not installed, it will install it. If it is installed, as you can see, it will tell you. So what I want to do now is I want to say sudo yum check update. And this is going to see if there are any updates that are available. So we're checking our mirror sites, and we're going to be downloading the latest set of packages that are available. And it looks like we actually have a number of packages that need to be updated. So now what I would do would be to say yum update. And now it's going to check and list all of the packages that need to be updated, including all of the dependencies. It should show me the list at this point and then ask me whether I want to install or not. And I mistakenly hit the enter key there, which was no, so let me just run that again. And it should come back up and say, do you want to do this or not? And then we'll take a quick look at what it's asking me for. So you can see by the capital N here that the default is going to be no. What I want to do is I want to say yes. And so it's going to go download the packages, and then it's going to install them. And you can see as it's going here, what it's downloading are RPM files. This is the Red Hat Package Manager package format. And it's going to install these RPM files, which are all updates in this particular case. With yum, I can search for packages, I can check for updates, I can do updates. Of course, I can also do removes. If I were to say yum remove and then a particular package name, it would remove the specified package. I can also say yum erase. It's the same thing as yum remove. And we've been talking about doing yum update, which is what's finishing right here, and that's going to update all of the packages if you just run yum update. I can run yum update against a particular package. So if I say yum update and then the package name, what it's going to do is it's going to just check for updates on that one particular package. We're going to talk about the boot process. Now, you can see that I've got a virtual machine here, and I've got Ubuntu Linux, and I'm ready to start it up. Since this is a virtual machine, it's going to go really quickly, and I want to talk a little bit about what's going to happen before it actually happens. When you start a computer up, the very first thing that happens is it runs a power on self-test or a post. Now, the power on self-test just makes sure that basically all of the internal hardware to the system is actually operating correctly. The other thing that it does is it transfers control to the firmware that is then going to look for a specific portion of the hard drive. Now, what it's looking for is the master boot record, or it may be looking for the GUID partition table. The master boot record is a much older data structure on the disk, and that data structure is going to be associated with basically a DOS system. And the master boot record includes, but not limited to, the partition table that tells it where all of the disks are, but it also includes about 440 bytes of boot code. So with the GUID partition table, we're doing things a little bit differently. It's still got a partition table that's associated with it, but there's also a much larger chunk of boot code. And that refers to another piece of the disk if you are using a GUID partition table that's actually got more of the boot code that's associated with it. Now, in the case of Ubuntu Linux, and actually you didn't really see much of anything other than it starting up, we are using the Grand Unified Bootloader, or GRUB. There are other bootloaders that you can use, including the Linux loader, which is LILO. You can use either of those bootloaders, but basically the point of the bootloader is to actually boot the operating system from the hard disk. And it does this by reading the first section of the hard drive. So with the master boot record, it is the first 512 bytes, which is the first sector of the hard drive, or the first block of the hard drive. And with the GUID partition table, we're talking about a much larger section. We've got larger partition identifiers and a lot more of them with the GUID partition table. But basically, we are looking at the very first blocks on the hard drive in order to not only look for the partitions or volumes that are associated with a particular operating system, but also where the boot code is located. Now, the boot code, of course, is different from the operating system. The boot code is really just there to locate the operating system and then read that into memory. So when we start a computer system up, what we are doing is we are doing a power on self-test, and I'm just going to restart this now. And we should be able to see very quickly what's happening. That was the power on self-test that ran by really quickly. And what is being hidden from us here is the bootloader. We don't actually get the menu because that's being hidden. That goes and reads the kernel or the operating system, and then the operating system runs through its initialization process, bringing up all of the services that are necessary, and eventually the graphical login that you see right here. There are some things that you can do to protect your computer in case somebody can get physical access to it. The thing is, if I can get physical access to your system, I don't need to know your passwords. I don't need to know much of anything about the system at all, because I could install a boot disk like a CD or a USB stick. I could boot to whatever operating system I have. So I've got some distribution of Linux on either a CD or a USB stick. I can boot from that Linux distribution and gain access to your system in that way. If I can get physical access to your system, I can get control of it. So how do we protect against that? Well, there are a handful of things you can do. One of the things you can do is you can turn on BIOS passwords. Your system has some configuration settings. Typically, this has been called the basic input-output system, and it is a way of doing a number of configuration settings or providing a number of configuration settings regarding your system. So here's an image of a pretty standard BIOS setup utility. Now, different computers have different BIOS firmware, and that firmware is going to present different menu settings. Basically, what you're doing is you're looking for the security setting so that you can set a password. You can see the supervisor password is set. There's a user password that's also set, and there are some other configuration parameters. So password on boot. When the system first boots up, it is going to prompt for a password. This is before any operating system actually executes. Before the operating system, bootloader, anything happens at all, we're going to ask for a password. If the password is correct, the system will boot up. Now, there are some other things that you can do as well. Of course, you can enable hard drive encryption. We'll talk about that later on. And that's going to protect you against somebody removing your hard drive and extracting the data from it. If I want to protect against somebody actually doing something to my system, like booting a different operating system temporarily to change passwords or extract data, of course, the encryption settings are going to help there. But other things that I can do are just simple physical access controls. If I've got a server, I may want to actually lock the server into a rack. So I may have a cage around the rack, for example. I probably want to put locks on the doors where the servers are actually located. If it's a desktop system, I can lock it to the desk using chains or cables, something along those lines. So there are a number of physical protections you can take as well. You can lock the system into place, making it much harder for somebody to remove the system or gain access to it in order to do some temporary boot thing. You can encrypt the hard disks. And of course, you can also set a BIOS password in order to prevent anybody from doing any booting at all unless they know the password that is necessary. At this point, probably the most common bootloader is the Grand Unified Bootloader, commonly called GRUB. GRUB is actually a piece of software that has a number of stages. So the first stage is the one that goes into the master boot record, or if you're using a GUID partition table, it's going to go into a different place on the disk. And the first stage is responsible for actually loading up additional stages before we get to the point where we are loading the kernel. So we've got GRUB, and it loads up to the place on the hard drive, and it's responsible for loading up the kernel eventually. Now, we can do a lot of different things with GRUB, and depending on the operating system or Linux distribution that you are using, you may configure it slightly differently. So on some Linux distributions, you're going to go to boot GRUB, and you're going to see a file that may be called menu.lst. In this case, we're using a slightly different system. So if I were to actually be using one of the older versions of GRUB, I would be looking at menu.lst. In this case, what we're going to do is we're going to go to etcgrub.d, and we're going to look at the different configuration settings. So 00_header, and we've got basically some scripts that tell us what to do about creating the actual configuration file. So we've got all of these scripts here. When we run the make config, first of all, I need to be the super user or root user. So I need to run grub-mk config. And make config is going to take all of the configuration files that we have created here, all of these scripts, and it's going to generate a single configuration file. That configuration file is actually in boot grub, which is where we started. And I can take a look at that with grub.cfg. Now, of course, it says do not edit this file. It's going to be generated automatically. And this is actually a script rather than something that used to be in place, which was just a simple configuration file that specified the different operating systems that you may be loading up. So in this case, we're going to be installing some modules, and we're going to be looking for a number of configuration settings. Now down here, we're actually going to be generating the menus. So this one right here, this is menu entry Debian GNU Linux with Linux 3.2.0-4. This is actually one of the kernels that I have installed on this system. So when I boot up, it's going to give me this menu option, and I could choose this one or down below where it says menu entry. This one is in recovery mode, and the settings are a little bit different. You can actually see here, the recovery mode is really just booting it up in single user mode. So this is different from the line up here. What this line here that says Linux specifies is that's where the actual kernel is located. That's where the operating system is. That's the file that the bootloader is ultimately going to load into memory. There are a number of parameters that can be configured for the kernel. So for example, we are passing the root disk image in with a UUID, and we're also going to initially load it up as read-only, and we're going to do a quiet load, which means we're not going to spit out a lot of messages while the operating system is loading up. So down below here, you can see we've again got Linux, and it's located in /boot, and the kernel name is actually the same. The difference here is that we're doing it in single user mode, and we've also removed the quiet option. So same kernel, different parameters is going to get us slightly different behavior. So we've got our GRUB configuration here. It's going to give us the ability to boot a particular operating system. And the other thing about GRUB is that when we actually boot it up, we have the ability to go into the menu and make some edits to each line of the menu entry. So GRUB is effectively a language as much as it is a bootloader. So when we boot up into the operating system, we get to the bootloader or GRUB menu, we can stop the boot process there, make some changes, and add, for example, single to any of the lines that show up and boot up into single user mode. Any change that we make there on the fly dynamically will not be stored to the configuration file. It's just for that one time that we actually boot up. So GRUB is the primary bootloader that is used with most distributions of Linux at the moment. It's a very powerful bootloader, gives us a lot of capabilities for doing a variety of things, including protecting itself, and we'll get into how it can protect itself coming up in subsequent lessons. In addition to using BIOS passwords, you can also set a password on the bootloader. Now, as we've mentioned before, the bootloader that you're probably going to be using is GRUB. And so let's talk about setting some passwords on GRUB. So the first thing I want to do, first of all, let me zoom in a little bit so you can see this a little bit better. Now, I'm going to go into etc grub.d, and that's where all of the different configuration files that get pulled together to create the final GRUB configuration that is used to load the Bootstrap program, and that's used to boot the operating system. I need to be a super user or a root user in order to give me temporary administrative privileges. So I'm going to edit, and I happen to like the VI editor. I've been using it for decades now, so it's fairly comfortable for me. Feel free to use Nano or gedit or whatever you feel like using. So I'm going to use VI here. And first thing I'm going to do is skip to the bottom of the file. And then I'm going to add a couple of lines. So I'm going to say set super users equals, and let's just say the username is me. And you can see this is actually a bash script that we are looking at. So this file here is used to create the final configuration, but this is really a script. And so what I'm doing here is I'm setting a variable that I'm going to use in a little bit. And this is actually an environment variable. And I'm going to say password me is, let's mixed case it and pretend it's something a little bit more than it is. Obviously not a great password. This is just for demonstration purposes. If you were to set a password, obviously you would be using a stronger password, and ideally you wouldn't be using a clear text password here. We'll fix the clear text in a subsequent lesson, but for now, we're just going to set a super user, and the super user is going to be allowed to edit the configuration menu when the system boots up. They're going to be allowed to boot any operating system that the bootloader specifies. And here we're going to actually export the environment variable super users that we had just created. So if I were to have other users, what I could do would be to set passwords. And here I could say password me1, password me2. And the reason I'm adding additional users here is I may want to authorize only specific users to be able to boot specific operating systems out of the boot menu. And the super users can, as I said, boot anything and also do editing of the GRUB menu while the system is booting. So I've got multiple users now, and in this case, I'm going to save this out. And then all I would need to do would be to run update grub, and that's going to read all of these configuration files, and then it's going to pull together a complete grub configuration. So I would edit the file that I want. And in this case, I'm going to edit the header file, which is where I'm going to set users up. And then once I have added the configuration lines for the users, all I have to do is run update grub. That's going to update the configuration for me automatically. One way to have network services on a Linux system is to make use of the Internet Super Server. Now, the Internet Super Server is actually a process called inetd, or more recently, it's a process called xinetd. And that is the more recent version of the Internet Super Server. Now, we've got a directory on here because I've got xinetd installed on this installation of Linux, and xinetd is controlled by a number of service configuration files. So we've got a character generator, which is cargen or chargen. We've got datetime, we've got discard echo time, and ftpd. So some versions of ftpd have actually been developed in order to run out of the Internet Super Server, or xinetd. So let's just take a look here at ftpd, the configuration file. For xinetd, we have a configuration file that says service and then gives the service name. What that does is it tells the Internet Super Server the actual port number that is going to be listening. And the way it knows that is actually from a file called etc services. So we can look at etc services, and if I go to FTP, it tells me that the port here is port 21 and the protocol is TCP. So now I know that I'm going to be listening on port 21. xinetd knows that that is a port that it is going to be listening on. It's going to be a stream socket, which means it's going to be TCP, otherwise it would be datagram. No wait, the user is going to be root, and then right here is the server, and that tells xinetd which process to actually launch. So we're going to use syslog as our log type, and we're going to put them into those facilities. And in case the program or the daemon program needs to have arguments, you can provide them here. In this case, we're going to pass in -l to in.ftpd. I can show you the configuration file. Now, what this does is it just gives some basics here. So I can set some defaults. For example, I might set a log type as my default. And then what it says is it includes all of the other configuration files in the directory that we were just in. Let's just take a look at the Echo server, for example. This is something that's sometimes called a simple TCP service. If you've got the port open, you're actually going to just get a response back that is exactly what you send. If you send something to an Echo service, you're going to get the same thing back. Again, we've got the service, so I can take a look at services and then look for Echo. And echo is going to be on port 7, both TCP and UDP in this case. So the services file is what is used to determine the actual service port that's going to be listened to with xinetd, and then the rest of the configuration just tells xinetd how to actually handle any connection that comes in on that particular port. So the reason it's called a super server is because it is one service that actually manages a number of applications that sit behind it. So we've got the Echo service, for example, we've got the FTP service. It is one program that actually manages all of the listening and communication and passes those communications off to the service program. In the case of FTP, for example, it would be this user sbin in.ftpd. In this lesson, we're going to be talking about run levels. Run levels are ways of grouping services together. You specify a particular way of booting so that you get specifically the services that you are looking for. So I'm going to take a look at the different run level startup directories. What we've got here is RC0 or run level 0 is going to be stopping the operating system or shutting the machine down. Run level 1 is going to be single user mode, and we start adding additional services as we go up in run levels until we get all the way up to run level 5, which is a full graphical user interface plus networking and everything that you could possibly hope to want. Now, RC6, you'll see there is actually reboot. So you'll notice here in these different run levels that we've got S and we've got K. These are actually links, so let me just pick a directory here, and I'll show you. Etsy rc3.d, for example. These are all links to startup scripts for services that are in the init.d directory, Etsy init.d. If it says S, that's a startup script. If you go all the way back here to run level 0, for example, you'll see that they are all K scripts, and that's because RC0 or run level 0 is when we're shutting the system down. We don't want to start any services. We want to stop them all. They run in ASCII order, meaning K01 is going to run before K09, and K09 is going to run before K10. The order that they run in is actually influenced by the name. So how do we determine what run level we are in? There's another file here that I want to show you, and actually let's use less here. Init tab is a tab file, and tab files are generally tabular files. What this really is a configuration file for the init system. Init is actually the very first program that is not the operating system itself that runs. Init controls everything. You can see we have set the default run level. Now, when init starts up, it determines what actually gets started by run level. So you'll see run level 3, it is going to start everything in Etsy init.d/rc.3. So it's going to start up everything there. Now, there are a number of other settings here for things to do. For example, when Control-Alt-Delete is pressed, init needs to know about that because it's paying attention to all of those things. And then there are terminal settings. Used to be physical terminals. Now it's all virtual terminals because I've got the console, of course, but in the case of a graphical interface, I've got a number of virtual terminals. So for example, right here, I'm running on a virtual terminal. And all of the physical terminals that the system likes to know about are all configured in this as well. But the one thing that we're really concerned about is the run level that the system is set to. So again, run level 0 is halt, run level 1 single user, 2 through 5 are multi-user with different variations of settings. So some of them have network, some of them don't have network, some of them have the graphical interface, like 5 is networking plus graphical user interface plus multi-user. Run level 2 is simply multi-user. So you've got the different run levels. And this file here on many Linux distributions controls what run level you are actually going to boot up into. So that's etc init tab. And again, all of the services that you are going to be looking at are all in here. These are the startup and kill scripts for all of the services that are installed on your Linux operating system. And if you look into RC asterisk here, it's going to show you all of the different directories and all of the scripts that are starting up in each individual run level. Red Hat 7 is one of the operating systems that is actually using a different way of starting the system up. And I'm actually in a CentOS system here, which is binary identical to Red Hat Enterprise Linux. I'm in a CentOS system. It's going to look exactly like a Red Hat Enterprise Linux system. I'm doing this to demonstrate one of the different ways of managing the system startup and services startup. With Red Hat Enterprise Linux, rather than the old init system, Red Hat is now using a different system called systemd. Systemd manages run levels differently, it manages services differently. Lots of things change under systemd as compared to init. The directory where all of the files are is in etc systemd, and if I were to go into system, you could see some more of the configuration settings here. What we've got rather than run levels 0, 1, 2, 3, 4, 5, 6, with systemd, we have targets instead. So you'll see, for example, graphical target, and you'll see multi-user target, and you'll see the NFS target. All of those targets, they are equivalent to different run levels. So the graphical target, for example, is equivalent to run level 5. The multi-user target is equivalent to run level 3. Rather than just setting the run level using init, what we're going to do is use the command systemctl. So I could run systemctl, and I could say get default. And this is going to tell me the default run level for this particular system. In this case, the default is the graphical target. Not surprising, I'm in the graphical user interface. I can change the target similar to what we did under init. I could do sudo systemctl isolate graphical.target. Now, this is going to switch me over to the graphical target where I already am, but that's how I would do that. And I'll show you switching over to the multi-user target in a second, but since it's going to boot me out of the graphical interface, let me just show you one other thing first. I can do systemctl set default, and then I could say multi-user.target. And that would actually set the default to be the multi-user target. So whenever I boot it up, so if I were to reboot, it would bring me into the multi-user. And if I were to type multi-user correctly, it would help. So multi-user target. And let me just show you what the multi-user target looks like. So we're going to switch over. It's going to boot me out here of the graphical user interface. And let me just show you what it looks like to change using systemctl isolate multi-user.target. So you're going to see the screen change here when this actually runs, and we are dropping back to just a plain console interface. So now I can log in as me. I haven't changed the default here, so I can still run systemctl and get default, and you will see that the default has remained the same graphical target. So I can switch back now, isolate graphical.target. So this is how I would change the run level. Rather than running init, I would run systemctl, and it's going to switch the run level just as running init3 did. I would be running isolate graphical.target for run level 5, multi-user target for run level 3. If I wanted to switch to single user mode, I could do the target for single user mode. You've got a different way of managing run levels under systemd as we did under init. And of course, the service management changes as well. The way of getting the list of services, we're going to use systemctl for that. So run levels are still run levels, but rather than calling them run levels, we call them targets under the systemd setup that manages the boot and service startup of a Linux system, specifically the Red Hat distributions like Red Hat Enterprise Linux and Fedora Core. Now, we've talked about setting passwords on GRUB, and let's just take a look again at what we did in the password setting. We've got a super user's user, and we've got a password set on that. Now, the problem there is that that password is in clear text, meaning that anybody can read it if they can get access to this file. That's not a good idea. You never know when somebody is actually going to get access to this that shouldn't have it. You've given away a password. That's really something that we should avoid at all costs. Let's take a look at this little utility here. We are going to run grub mk password -pbkdf2. And what this is going to do is it's going to ask me for a password, and I'm just going to put in a password here. And what it's going to do is it's going to generate a string here that we can use in our file. So I'm just going to copy this. If I right click there, I can copy the text. And then what I can do is I can go back into the file that we were just looking at where we had set the password, and I can go down to the bottom, and I'm going to delete this password here, and I'm going to insert the string that we've created. Now I have generated a hashed password. You can see the hashing algorithm that is used here is the secure hash algorithm, and that's going to be 512-bit. We've got a really large hash space that we are using for this hashed password. Now, if anybody gets a look at this, all they can see is the hash. It's going to be very, very difficult for anybody to try to reverse and get that hash. Of course, they can run brute force attacks on it. There are some other things they can do, but certainly this is going to protect against casual and even semi-dedicated attackers. So we've got a hash password now. Again, all I've got to do is run the update grub command, and I'm going to update the configuration file. It's going to have that encrypted password in there. Now, one thing to keep in mind here is it's helpful to have another user that you can actually get into the configuration with or get into the system with. So it would be nice to have a second super user that has maybe a non-hash password. The reason for that is until you've tested it and made sure that the password you used worked, it's entirely possible, it's not likely, but it's entirely possible you may have done a fat finger on the password twice or may not have typed it quite as you thought you did. It happens from time to time, so it's just safer to have a second super user that doesn't have the hashed password until you have tested the password that you have got here. Make sure that it works, and then of course you can go and fix all of the other users to have hashed passwords as well. We're going to talk about a different bootloader. Now, I've got the bootloader LILO installed here, and the first thing I need to do is run LILO config. LILO config is going to generate a basic LILO configuration file for me. And in order to get that configuration file active and install LILO as the bootloader into the master boot record, I would have to run LILO. But let's take a look at the LILO configuration file that we've got here. lilo.conf. LILO is a bit of an older boot manager, and it's a little bit less configurable than GRUB is, and it's certainly not as dynamic as GRUB is. One thing about LILO is if I change the configuration, I need to run LILO again, where GRUB, if I change the configuration, it gets picked up automatically, and I don't actually have to reinstall the bootloader in order to get the configuration updated and loading correctly. So this is a bit of an older bootloader, and so you'll see some settings here that we don't worry about so much anymore, but for a while definitely were a problem. So with larger drives, we've got the logical block addressing, or LBA, and we had to kind of force the use of logical block addressing. And you can see there's also a setting for large memory. With LILO, I specify a boot. This is actually the boot device. So this is the drive where all of the bits and pieces that we need are going to be located. So you can see here's another example. In this case, we are using a disk identifier rather than something like SDA, which would be the first SCSI device on the system. So lots of settings here, and you can see there are details around what all of the different settings are. In this case, we set the boot map, and then we are going to use a menu rather than text. So we could use a text menu, we can use a configurable menu with different background colors, and of course there's a graphical menu as well. In this case, we're going to use just a basic text menu that has text colors and some different color schemes that we can use. So here's where we set the color scheme. You can see menu scheme there. And then down below, we will eventually get to the point where we are configuring the boot that we actually want to do. So here's an example. We've got image equals /boot /vm linux -3.2.0-4-AMD64. The linux here, the Z right here, indicates that this is a compressed kernel. This means that it has to be decompressed before it runs. The very first thing that happens after the kernel has been loaded into memory is it has to get decompressed. So we've got the kernel image, and remember we specified the disk that this could be located on earlier. So we know the disk, we know that it's in the boot directory, and then after that is the file name. Underneath that, of course, we specify a label. This is what gets set in the menu. So this is what shows up there. We've got our root device, which is a UUID device. And then we've got the initial RAM disk, and it specifies the file name for the initial RAM disk. So this is what was generated by LILO config. It determined the correct boot image that we are going to be using. And of course, it also detected the correct device that we are going to be booting from, and then the initial RAM disk as well. So as I said earlier, if I want to actually install LILO and use LILO rather than GRUB, all I would have to do would be to run LILO. It would go read the configuration file and then install LILO in place of GRUB in the master boot record. I'm not going to do that here. I do generally prefer GRUB at this point. There was a time where LILO was a better bootloader, but GRUB is just more configurable. It's dynamic, so I can make changes. Everybody, of course, is going to have their preferences. GRUB is the default in most Linux instances, but LILO is certainly available if that's something that you felt like you wanted to do in place of GRUB. Let's take a look at services. First of all, let's talk about what a service actually is. A service is generally a program that is started up and then immediately goes to the background and just kind of runs there waiting for requests. This may be a web server, it may be an FTP server, it may be a service like dbus that manages inter-process communication. There are a number of services that are running on your system at any given point. So there's a directory that I want to look at first here. That's etc-init.d. And etc-init.d is where on most Linux systems you will find the scripts that actually manage the services on your particular system. Now, these are generally bash scripts, and they take a number of parameters depending on what you want to do. Let's get a status on dbus. And you can see dbus is running. Now, I can also stop and start services. So let's just stop and start one. And I'm not going to stop and start dbus. The reason for that is because if I were to try to restart it, it would actually kill my interface session here. The GUI would just stop working altogether. So let's do XM4, which is a mail server. And I can stop that. And then I can, let's just check the status before we start it back up again. So looks like not running. Now I want to start it back up again, and we have started the service. So that's one way of managing it. I can also use the service utility and then say xim4 status, and that's going to give me a status on the service. So basically what I just did was bypass the whole calling the script through etc init.d, and I just used the service utility, which is effectively the same thing. It's certainly fewer characters, and I could do something like a restart on it as well. So same idea. Rather than going directly to the script, I'm calling it through the service utility. There are other things that we can do with services. We can set up whether they are running or not and what run levels they are in. There are different utilities that you can use on different Linux distributions in order to manage that. But in terms of starting and stopping them, you can go to the etc init.d directory, start the script directly, or you could, of course, use the service command in order to manage whether your services are running or not and what the status actually is for them. Now, the Red Hat operating systems like Fedora and Red Hat Enterprise Linux use a different system to manage their services. So we're going to use the utility systemctl. And if I just run systemctl, of course, it's going to ask me for my password here. And you can see we've got a list of all of the services that are running on this particular system. So let's just skim through here and let's just pick a service that isn't going to cause too much damage if we play with it. So I'm going to take a look at the SSHD service. You'll see rather than just SSHD, it's sshd.service. That's to distinguish itself from a device, for example, as here, or a mount as in here. So servicectl manages all of those. And again, we're going to be playing around with sshd.service. So I can say systemctl restart sshd.service. Now it's been restarted. And we can just take a look at the status on it. And it's going to tell me that it's actually loaded, it's active, I've got a process ID, I've got the main PID, I've got a small amount of log output. So you can see this is much more detailed than I was previously getting with the older service scripts on different Linux distributions that used like the old init system for starting up the system and managing services. So I've got systemctl, I can do status. Now what I want to do is I want to see whether a service has actually been enabled to start up at boot. So I can do systemctl and I can say is enabled sshd service. You can see that it is enabled. And I could actually disable it if I wanted to, saying disable sshd.service. So it's removing the entry that's going to start the service up in order to turn it back on. I can enable it. And now we've created a symlink here to actually start it back up. So I can enable, I can stop, I can start. We can just take a look at stopping the service here. We did a restart. If I were to stop it at this point, and then I do a status, it should tell me that it's actually stopped. And sure enough, it says it's been loaded, but it's inactive. You can see here, it says it's inactive. I do get some log output as I did previously, and it does say stopping the server daemon, and then that it's actually stopped. So systemctl does all of the stuff that we were able to do previously with the init scripts, as well as quite a bit more, and it does take into account more than simply the services that are on the system. It also handles devices and the drivers associated with it, and it's a pretty powerful tool to be able to use. We can do a lot of querying of the services and manage them using the systemctl utility. I'm going to introduce a concept here, and then we'll get into the use of it in subsequent lessons. But I did want to talk about TCP Wrappers. TCP Wrappers is actually a program that is designed to wrap a service program. So you might use this for Telnet or FTP or one of the R services or some other maybe potentially fragile service that doesn't have its own ability to manage whether somebody is going to be allowed to get access to it or not. So we've got TCP wrappers that will actually protect that service by giving us the ability to do some configuration on who gets allowed to make use of that particular service. So for example, Telnet, I may specify a configuration line using TCP wrappers that says I'm only allowing Telnet to people on my local network. So we're going to make use of a couple of files that are going to give us that access control. And one of them is the hosts.allow file in the etc directory, and the other is in the hosts.deny file. With the hosts.allow file, we are using a whitelist. This is a list of access controls where we are allowing access to a particular service. The hosts.deny file is a blacklist where we are actually denying access. It's pretty straightforward. So we've got hosts.allow and hosts.deny. If something isn't in one of those two files, we will actually just grant access. So basically, it's a default allow configuration. So you have to allow some and then deny everything else unless you really just want everything to get access, in which case you may not want to be using TCP wrappers to begin with. So TCP wrappers give us the ability to protect potentially fragile services like Telnet or FTP that are plain text, and we may not want everybody in the world getting access to them. Now, TCP wrappers are used in conjunction with other programs like inetd or xinetd, and we will be talking about xinetd in a subsequent lesson. If a service is doing something with the network, it's going to have a port that's associated with it. A port is a local address that a program or application connects to. So when we are talking about network services, you have an IP address and a port. And the port is associated with the particular transport protocol, whether it's TCP or UDP or maybe something else. The port is associated with one of those protocols, and it differentiates the different programs that are running on a system. So, for example, let's take a look at the services file. This is a file that exists on most Unix-like operating systems like Linux. And actually, let's do this a little bit differently. Cat is just going to zip them all by. Less will allow us to look at them a little block at a time or a page at a time. So you can see these are the different services that Linux is aware of and the different port numbers that are associated with them. So for example, we've got Telnet here. Telnet typically operates on port 23, that's TCP. We've got some UDP services as well. So for example, the character generator application right here, that runs on port 19, and that's UDP. Of course, it also has a TCP component as well. So lots of services. These are all of the well-known services. There are other programs and applications that you may run that may not run on a well-known port. It may not be a well-known service, but we can get lists of the services that are listening on particular ports just by using the netstat command. So for example, I could say netstat listening, and let's actually pipe this into less. I'm using the pipe command to send it off to the less program so that we get a page at a time here. Now, what I've got is all of the ports that are listening. What I don't have is the service that is associated with them, but I do have This is my local port. This is running on the SSH port that happens to be port 22. And I've got a PostgreSQL server. I've got an SMTP server. You can see the different ports that are listening. In this case, we are listening to every remote address. We haven't nailed it down to a specific remote address or a set of remote addresses. This means that we are listening. You can actually see the state over here. It says listen. I don't have any programs that are communicating with remote systems based on this. If I did, I would see an entry here, and rather than listen, it would say something like established over in the state column. Now we've got all of the stream listeners there, and I'm not going to go into any detail there. These are the ones really that we are interested in. Now I can also do netstat so that I get the program that is listening. And this is actually going to get me the process ID as well as the process itself. So we've got sunRPC, and that's the RPC bind service. And we've got port 54097, that's rpc.statd. And of course, the SSH port is SSHD. If I wanted to get a list of all of the network communications, all of the ports that were either listening or established or anything happening on any of them, I would use -a. And then I'm going to say P is going to give me the process information. So I could do -ap, and we are going to get the same information basically that we had before. We're going to get all of the process identifiers. So netstat has a lot of different command line switches. If I didn't want it to look up the information for me about what the name of the service was, I could put an N in there, which just says don't look up. So instead of SSH here, it says 22 as an example. Instead of SMTP, it says 25. So I can use -n. What it really does is it lets netstat run a little bit faster, so it's not doing name resolution. If you actually had programs that had communications open with other systems, the -n is going to help netstat run faster because it's not going to try to look up the remote addresses and do a DNS reverse lookup on them. For just the services, which is really what we're talking about here, the -n really isn't going to speed anything up. It's a quick lookup in the etc services file in order to determine that port 25, for example, is the SMTP port. So netstat is how you can see what ports are open and listening on your system, and you can also figure out what process is associated with that particular port. One mail server that's pretty common on Linux systems is Postfix. Now, Postfix is a mail server that was designed pretty specifically to be far more secure than some of the other options that were out there. It's designed to be considerably simpler to configure with a number of facilities that are really targeted at preventing abuse of the mail server. So let's take a look at the configuration file for Postfix. The first thing that you want to do is give your system a name so that it can identify itself. If I do an install on a Debian-based system like Ubuntu or one of the Ubuntu derivatives, it's going to do some of the configuration for me. And actually, what I want to do here is I want to edit this. There's a couple of changes that I want to make, and one of them is going to be right here. I want to get rid of this. So I don't want to give an attacker any more information than I absolutely have to. So I'm not going to tell him that it's Ubuntu. It's going to give the attacker information about the package. So it's going to say Postfix, but it's not going to say this is on an Ubuntu system. So try to limit the amount of information as much as possible. Now we've got an aliases database, and we can use that to set up a number of mailboxes that are pretty common So you'll need a postmaster mailbox, and an abuse mailbox is something that you are supposed to have as well by way of best practice. So there are a couple of things that we can do here. The first thing that we want to do is prevent relaying through us. So we're going to allow my networks, and my networks here you can see right now is just limited to my local host. So I could also do this, and I could add 172.42.0/24, which is my local network. So basically anybody on my local network is going to be able to use this mail server to communicate with. Permit SASL authenticated. This allows us to do SMTP auth, and there are some additional settings that we need to have here as well. So the first thing that I want to set up is an SMTPD hello restrictions. So SMTPD hello restrictions. This is going to give us a way to cut down on people who are allowed to communicate with us. So any system that tries to send mail to this one has to start with a hello, either HELO or EHLO, depending on whether they're using SMTP or ESMTP. So I'm going to do, again, permit my networks, and then I'm going to say reject non-fully qualified domain name, host name. If you are not using a fully qualified domain name, I'm going to suspect that you are not a properly configured mail server, and I'm just going to reject you. Another thing I can do is reject invalid host name, and that again is going to cut down on bad people trying to communicate through me. And then I got to do a permit, which is basically reject everybody. And then if you don't fall into those categories, you can actually be allowed through. Now, another configuration is SMTPD sender restrictions. And again, I'm going to do permit SASL authenticated. So this is going to allow anybody who has authenticated with us. And again, I'm going to also do permit my networks. Now, the sender restriction is basically anybody who has gotten through the hello now becomes a sender, and now I can do some additional configuration. So I can do reject non-FQDN again. If you were to try to send from root at localhost, for example, well, that's not a fully qualified domain name, so I'm just going to bounce that. I could do unknown sender domain. In this case, I'm just going to do a permit. And then another thing that I can do here is SMTPD recipient restrictions. Another set of permissions that I would need to do here. So I could do, for example, permit my networks again, permit SASL authenticated, reject on-auth destination. I can do a reject RBL client. This is a black hole list that is maintained by a couple of different organizations. So here's one, for example. And then I could do another reject RBL client again. I can have a bunch of these. And this is a different black hole list, dsbl.org. And then again, I'm going to do a permit here. You can see that we've got a handful of settings here that we can use to try to limit the people who are communicating with our mail server, so we can stop spam and we can stop unauthorized use of our mail server. Now, there are a number of other things that we can do, for example, gray listing and using a sender policy framework, and we're going to cover those in an upcoming lesson. While there are certainly other web servers that you can make use of on a Linux system, the most predominant one, probably by far, is Apache. So let's take a look at the Apache configuration setup. Now, Apache configuration has changed over the years. It used to be much more straightforward than it is now. And the reason for that is because Apache simply has become more feature-rich, and it allows more in the way of plugins and virtual sites, virtual servers, and it's much more configurable in a broader sense than it used to be. As a result, what you end up with is a much more complicated directory structure than we had previously. Now, typically where you will find the configuration settings is in etc Apache 2. In etc Apache 2, you will see there are some files and there are some directories. Now, the first thing that we want to pay attention to is the apache2.conf file. I'm going to take a quick look at this. This is the first place that you're going to start for configuration settings. The thing about this is there's not going to be an awful lot here, but it does provide you some documentation. So you can see that the configuration is actually split into several files. This is the main configuration file, and what it really does is it has some global configuration, and it also pulls all of the other configuration files together. So you can see that we can set the server root. That tells Apache where the server is actually located. And we've got a number of other settings that you may or may not want to change. So let's just skim through some of these, and we'll get into more details around specific configurations that you may want to change coming up later on. One thing to note here is it says include ports.conf. That is the list of ports to listen on. As I said, Apache has become a much larger server entity than it used to be. So I could actually have it listening on a number of different ports, and each port may actually point to a different virtual server or offer a different service up. So I've got a configuration file specifically for the ports that I want to listen to. Now we've got some directory settings here. And then we've got the log format. And this tells us how we are actually going to log. So we are using a custom log directive, which uses an extended log format rather than the simpler NCSA common log format. With the extended log format, you end up with a custom log, meaning that you can actually specify what you want your log entries to look like. So you can see we've got log formats there, and that's going to tell us how we are actually going to generate log files. So this is really the apache2.conf, and as I said, there are other ones. For example, the ports.conf you want to take a look at. This tells us we're going to listen on port 80. If we've got the SSL module installed, we're going to listen on port 443. So the other thing to look at here is the sites available and sites enabled. So let's take a look at sites available. And you can see we've got a default configuration file here. And this is going to be really the primary server here. So we've got a virtual host that says basically every IP address on this system that's listening on port 80 is going to use this configuration. So we've got a server admin tells us where the document root is. The document root is where all of your HTML pages, all of your PHP, anything that is actually going to be served up by your web server is going to be located somewhere underneath your document root. We've got error log, custom log. Really, that's kind of about it. Now, if you wanted to use SSL, we could look at the default SSL configuration file. If we've actually enabled SSL, here are some settings that we're going to use. And this sets up the certificate file, the key file, and turns the SSL engine on, as well as sets a number of other SSL parameters. Now, this is under sites available. What you can have is a number of sites available that may not actually be turned on. In order to make use of a configuration, you need to go into sites enabled. What we have here is just the one configuration file, and this is going to be the same one that we looked at before. It's been moved into the sites enabled, and honestly, it hasn't even been moved here. I can tell by the light blue that this is actually a pointer to the configuration file that's in sites available. So what I do is I maintain the site configuration in sites available, and then I generate a link to it in my sites enabled. it's only the sites enabled that the configuration will be read into. So you want to turn on a site that is available on your system, you can either copy it into sites enabled, or better, you can just link to it from sites enabled into sites available. And then anytime you do an update, it's going to update the sites available configuration, and then that will automatically get picked up because of the link that you have set up in sites enabled. So as you can see, there is a lot of configuration that you can be doing here. We've got mods that are enabled and mods that are available. If we were to look into mods that were enabled, you would see these are all of the module files, and the light blue actually tells me that these are links to the configurations and modules that are actually in mods available. So we've got our Apache configuration where everything is located. You could see in our configuration file that var www HTML is going to be the place where our document root is. All of the other configuration files are in etc Apache 2. If you install modules, then those configuration files and modules are typically going to be under etc Apache 2 as well. We're going to talk about some additional steps that you can take in order to harden your Apache installation. So we're going to go back into the Apache directory here. Now we're going to talk about some configuration directives, and they're going to be in specific locations on this particular system. However, no matter where they are, these directives will actually work. So I'm going to go into the config enabled directory, or conf-enabled. Again, this is where they happen to be on this particular system. Other systems may use different configuration files. They're broken out this way so they're a little bit more modular and easier to deal with. So we've got a security.conf file, and let's just take a look at that, because there are, not surprisingly, some configuration settings that are related to security. One of them is server tokens. This is where you determine how much you want to tell somebody connecting to your system. So right here, it's set to server tokens OS. Now, commonly, that's actually not considered to be a good idea from a security perspective. We don't want to give attackers any more information than we absolutely can. So instead, what we say is server tokens prod, and that means product only. Rather than giving information about the operating system, which is what OS would do, this is simply going to say Apache, and it's not even going to give a version number. And here's another case where we can talk about the version number. Server signature is on here, and what I want to do is turn it off. With the server signature, what it gives is information about the server version, what modules may be installed, far more information than we want to give out. We don't want to give attackers information about the versions, because then that may give information about what we may potentially be vulnerable to. So it gives them opportunities to attack us with very specific targeted attacks, rather than just potentially blasting everything at us, which would be more time consuming and potentially less lucrative on their part. So here's another one, trace method enabled. This is not something that you should have turned on a production system, so we turn trace off. You could forbid access to version control directories. So that would be a directory match, and then you could say require all denied. And then what I want to do next is, there are some other ones here that you could turn on or off depending on what it is that you're doing. What I'm going to do now is jump into a different directory here, and we're going to go into sites-enabled in this case here. And I'm going to edit 000-default.conf. Now, we've got server name, server admin, document root, so on and so forth. We could also do a directory here. So for example, I could say directory, and here's where I could specify some particular settings that I wanted to. So HTML is going to be my directory, and now here's where I could turn on some options. What I could do would be to say indexes. That would say if there was not an index file in the directory, that would turn on a directory listing. And I don't want to do that. So what I want to do here is actually say minus indexes. And in order to make sure that my Apache installation picks up the correct directory indices or index pages, what I need to do is specify a directory index. So I want to say index.html. I could say main.html. I could say basically anything I wanted to add as a potential index page here, I could certainly do that. So I would add a directory index, make sure that I include all of the index pages that I might possibly have, so that I would have an index page when I go to a particular website that I don't specify a specific page for. For example, let me just show you what this looks like. If I open up a web browser and I just go to google.com, since I didn't specify an actual page that I wanted to go to, the web server at Google actually defaulted to the default directory index for the primary directory at their website. So I could go to Microsoft.com and get the same sort of thing, and Microsoft may actually redirect me to something different here. So what you can see here is we actually got default.aspx. That's the default index page for Microsoft. I didn't specify a specific page, and so the server took care of that for me. That's really what I'm doing here with the directory index. I'm having the server determine what page should be used if there is no specific page that is actually requested, and it's just really a directory that somebody goes to. So one other place that you want to look at here when you're talking about hardening Apache is you want to look at your modules. So you want to go to your mods-enabled. For example, if you had PHP installed and you weren't using PHP, you'd want to make sure that you had removed that. If you weren't using whatever other module here may be installed, if you're not using it, it's best to actually remove it from your configuration so it doesn't have the potential to hurt you by being exploitable by an adversary. So there are a number of ways that you could go about hardening. There are a number of configuration directives, whether it's preventing information leakage in terms of operating system version or the version of the Apache server you're using. You want to talk about directory indices. You want to talk about removing the index option from your directories, and certainly the modules are always going to be some sort of concern for you when they are installed and actually loaded up inside Apache. One feature the Apache web server supports is this concept of virtual hosts. So if we were to go into the Apache configuration directory, and let's just go into the sites enabled, and we'll take a look at the configuration file. I'm going to use VI to edit the configuration file. Now you can see here, we've got this virtual host directive. So if I wanted to create a new virtual host, what I could do would be to say virtual host. And then if I wanted to bind it to a particular IP address, what I could do would be to say 172.30.42. Let's say 19 is one of the IP addresses on my system. I could do something like this. I could also specify, let's say www. And we'll just use foo.com. So when you connect to a web server, one of the headers that actually gets sent is this host header. And the host header will tell the server which host that you want to connect to, which is part of what enables this particular functionality. So if I were to say, this is the host that I'm actually looking for, because what you can have is multiple host names running on a particular web server instance. So I could have a lot of different domain names that were bound to a particular IP address, and then I could have my Apache configuration file here, say my virtual host, and then I've got a set of directives here. So I could say server admin, and then I could give it a different document root, because I probably don't want to use the same document root across multiple virtual hosts, because probably I want different content for each virtual host. So let's say var/www/www.foo.com/docs, for example. And now I could set log directives here, or I could set some other variables or other options within this virtual host. And then when I'm all done, I just close out this set of directives and I have a new virtual host. So virtual hosts allow me to have a number of different hosts or domain names that are bound to a particular server, which would have maybe a single IP address. And then I could have a number of different security settings for each of my domains. So I could have different document routes, different settings. For example, I might have, would probably be unwise to do this, but I might have directory listings enabled on one where I wouldn't on another. Or I might allow script execution on one where I might not on another. So I can have a lot of different settings for each virtual host entry that I have. And of course, virtual hosting is one of the things that we can do with Apache. It's very easy to do. I could have actually created a whole separate configuration file here, and I could have done something like 001-foo.com.conf. And then when Apache loaded up, it would read all of the configuration files that were in my site's enabled directory. And then I would get the configuration for that particular file that would include maybe just the configuration for that one virtual host. One way to protect your DNS server is actually to enable DNSSec. And that's going to enable you to sign your zone using an encryption key, so that you now have an encryption key so that you can exchange your keys with other DNS servers, and you can actually have a more secure DNS setup. So we're going to enable DNSSec. The first thing I want to do is I'm going to hop over to root temporarily, and then I need to go into my bind directory for my configuration files. So I'm going to edit named.conf.options, and we're going to take a look at the DNSSec settings here. The first thing you need to do is enable DNSSec. So DNSSec-enable, yes. And then we're going to turn on validation. So DNSSec-validation, yes. DNSSec look-aside, we are going to set to auto. So we need to turn all of those on in order to enable DNSSec. Now, the other thing that we need to do here is to create some keys. So I'm going to go into my zones directory here where my one zone file is. And those are some spare keys from some playing I was doing earlier. So let's just start over here with some fresh keys. So we're going to say DNSSec-keygen, and then we need to use NSEC3, and RSA is going to be our algorithm. SHA-1 is going to be our hashing algorithm for validation. We're going to use 2048 as our number of bits. This is going to be a zone file. And then we're going to say mydomain.com because that's our domain. So I actually installed HaveGED, which enables us to generate these keys much faster. Otherwise, it would be a very, very slow process. So now that I've got my zone signing key, I need to create a key signing key. So we're going to say DNSSec-keygen again. And I need to do, first of all, -f is going to be a key signing key. And then we're going to again use nsec3 RSA SHA-1. In this case, we're going to do 4096 is the number of bits that we are using. And then what we need to do is say, again, -n zone mydomain.com. Now we've created another set of keys. So now we need to include these keys into our zone file. So we're going to say for k in ls k mydomain.com *.key. What this is going to do is it's going to populate the variable k with the output from ls and then kmydomain.com *.key. So we're going to get a couple of keys here. And then with that, we are going to echo, and we're going to say $include. So we're escaping the $sign here because we want it to say $include. And then we're going to say $k, that's going to be our variable. So what it's going to do is it's going to say $include and then the file name that we get out of the ls. So now I want to dump that into db.mydomain.com. And then we're done. So now I can cat db.mydomain.com, and you can see the two lines at the bottom, $include, and then we've got the key. So now we're going to sign the zone. So I'm going to say DNSSec-sign zone. Now I need to include a salt. Now normally you would use a random number here. In this case, just for simplicity, I'm going to use these numbers. So I need 16 characters here. There are a number of ways you could generate random numbers and get 16 characters out of it. As I said, just for simplicity's sake, I am using just these 16 numbers. So -o is going to be my zone name, which is mydomain.com. And then my zone file name is going to be db.mydomain.com. So now we've got our signed zone here. We need to go into another configuration file and say named.conf.local. This is where we have created the zone mydomain.com, and I've got my file, and what I need to do is append .signed onto the end of this because I now have a signed file in my zone directory. So you can see I've got db.mydomain.com and then db.mydomain.com.sign. I'm going to restart the bind service. So now all I have to do is say dig at 127.0.0.1, which is my local host. So I'm going to be talking to my DNS server here. And then I'm going to say DNS key and then mydomain.com. We'll do plus multi-line here. So now you can see these are the keys that are associated with the domain mydomain.com. So I've got my DNS keys associated here, and I can use those keys to offer better security to my DNS server and its communication with other systems. Now, you may end up with a database server on your system. One of the common database servers is MySQL. There are a handful of things that you can do to protect your MySQL server. One of the things is making sure that you've got a good password. So I want to change the password here. So for demonstration purposes, I'm going to set it to this. It's going to ask me for the existing password of the root user so that we can get access to the database and we can update the appropriate tables. So now I've just changed the password. Let's get into the database here. I'm going to use the root user and then I'm going to have it prompt me for the password that I just set. We can actually change the username for the root user, because root is a pretty common username for the primary system administrator on a MySQL system, particularly ones that are running on Linux. So what I want to change is the mysql.user table. I'm going to set user equals new root, where user equals root. So anywhere we find the user is equal to the word root, I'm going to change it to the word new root. And I need quotes around that. And now I'm just going to say flush privileges. And we've just changed the user. So the other thing is you want to make sure that you are not listening on any network interfaces, particularly if you don't have to be. So let's take a look at the configuration files here. We've got my.cnf, and we can take a quick look at that. Most of these you're not going to change. The client is going to be trying to connect on port 3306, and then the server, we're telling it the port is 3306. In this case, what we are doing is only listening on the local system. So that's 127.0.0.1. That's generally considered safe. You can't get to it remotely. So if this were to say bind-address equals asterisk or have an external IP address, that would be considered something that wouldn't be a great idea. Most of the rest of these are going to be okay. Of course, you can make logging changes if you want to get more log entries so that you can do auditing, for example, or if you want to be looking at things like doing log watch, or maybe having a longer historical view of what's going on your MySQL system. So, of course, you can use SSL in order to protect your network. You could also use a shroot if you wanted to lock your MySQL server instance down to a particular interface. That's not always necessary, particularly if you're only listening on your local host network. So right here, we've actually set a password, and this is going to override the other configuration file here. So we're going to use debian.cnf for our configuration. Host is localhost. Client is going to specify a different user, and it's going to have that for our password. Of course, the password is in clear text. That's not always a great idea, but it is a strong password. And as you can see, you've got to be root in order to get access to that particular configuration file. So we finally have the configuration directory. And in this case, we've got a safe syslog configuration. And right here, all it says is it's got a syslog configuration setting. So for the safe MySQLD, we're going to do syslog. And for others, we're going to use MySQL as its own log entity. So you can see we've got some configuration settings. Again, one thing that you want to do is you want to change your root user to something that somebody's not going to be doing brute force password attacks against. If I've already got a username, all I've got to do is continue to try passwords against it, and eventually I may be able to guess your password. Of course, listening on only the local host, or preferably only doing a socket listener, is a good idea. If you're listening on any external interface, of course, you are exposing yourself to the wider network where things like brute force attacks or any type of known vulnerability or exploit could potentially bite you. We're going to take a look at what we can do with PostgreSQL in terms of helping to lock it down a little bit better, although I should say PostgreSQL actually comes pretty well locked down as it is, and there are some good capabilities that we can make use of that are already built into it. So the first thing that we want to do is log into the PostgreSQL database, and we're going to take a look at something that we can do there. I'm going to run PSQL, which is going to get me into the console, basically, or directly into the database where I can do some manipulation. So what I want to do is I'm going to create role, and say my user with login, password, and I'm just going to give it just a password here. Now, what I'm going to do next is the important part. So I'm going to say valid until, and let's say 2016 12-31. One of the nice things about PostgreSQL actually is that I can create a user with a specific time period in mind. So I can make this particular user valid for, let's say, a month, a year and a half, 2 months, whatever it turns out to be. I can make it valid to a specific point in time so that it's no longer useful after that point in time. That can help protect me in the case where I've got a lot of users sitting around that I have created and then just kind of forgotten about. What I may end up doing is having to go through my database and all of my users and calling those users from time to time. This can help save me from doing that by making sure that I am setting expiration dates on the users that I create. Now we're going to hop into the configuration files here for Postgres, and I'm going to edit one of these, and I'm going to show you some settings that we can make use of here. hba.conf, and I'm going to scroll down. What this does is it gives me the ability to have access controls. With access controls, what I can do is make sure that only specific IP addresses or networks get access to particular databases. I've got a number of fields here I can use. First is the database, and then we've got user and address. And then we've got methods. So we can say trust, reject. So this is not only a whitelist access control list. In other words, here's the list of people that I can allow, but I can also specifically say, here's a specific address or a network of addresses that I can block. So we're going to scroll down here and you can see some of these. So this is the type of access here. This is local access. We're saying all databases can log in with the user Postgres. This is the primary sysadmin account for Postgres. So now we've got some others. We can say this host. We're going to allow all databases, all users getting access from our local host if we are using MD5 as our authentication method. So you can see we've got a lot of capability here to have some very finely grained access control lists when it comes to the users that we allow, the databases we allow them to, where they can come in from, and then the authentication method that we can require that they use when they do come in. All of these capabilities here give us some really powerful tools to lock down our PostgreSQL database server so that we're ensuring that only the right users get access to the right databases from the right systems. We're going to talk about a few ways that you can protect a Tomcat installation. Now, Tomcat is a web application server that uses Java. By web application server, I mean that this is an application itself, a program that sits and listens to network connections. And then what it does is it passes messages into an application that sits inside it. So sometimes you'll hear it referred to as an application container, because it actually contains another application that has been written to actually respond to web messages, HTTP messages, and requests that are going into this particular web application. I'm going to go into my Tomcat directory. I've got Tomcat 7 installed here, and we're going to take a look at a couple of the configuration files that are here. Now, these are written in XML. That makes them somewhat self-documenting, and it should make them fairly easy to understand. Now, there are a couple of things going on here. First of all, there is a listener port that is configured with Tomcat. Now, this is called a shutdown port right here on port 8005. And what this does is it gives you a way to connect to the server and send a clean shutdown message. And that's going to allow you to remotely control this particular server. Now, this isn't necessarily a great thing to have. You can theoretically disable it, although if you need to cleanly shut it down remotely, having the port open isn't bad, but what you really want to do is you want to make sure you have a really challenging passphrase installed here. You don't want it to just be shut down as the password, because what we're doing here is this is actually what you send to the server. If what you send into this particular server port matches this shutdown message here, it will actually shut the server down. You don't want to have that open to just everyone. Now, we can just skim through this listing here. There are a number of connectors that give you the port that we're listening on and the protocol you can see right here, HTTP/1.1. There are some other connectors that are listening with different protocols in use. So, for example, this is AJP. If you've got different ways that you want to communicate to Tomcat, you would set those up based on whatever your needs were. I don't actually want to save that, so I'm going to quit out of there. Now let's take a look at web.xml. And there's a couple of things that I want to do with web.xml. The first thing is I want to look for a listing parameter. And the listing parameter determines whether we display basically directory listings, and that's a really bad idea. I want to make sure that that parameter is false. Now, something else that I want to do is look for an error page that doesn't actually exist. So what I want to do is insert a set of parameters here. So we've got exception type, and that's going to be java.lang.throwable. And what I'm doing here is I'm replacing the default error page. The reason for that is because when Tomcat gets an exception, by default, it will throw up a stack trace, which means it will give all of the methods that have been called within the application. That's not a great thing. So I want to set up an error page here, and this is something that I would actually have to create, would be this error JSP that would do something other than provide that stack trace, because that's not a great thing to provide to an attacker. You would set that error page in there, and we've looked at web.xml, we've checked our listings, we've created an error page. You can see there are a number of other parameters here. I'm not going to worry so much about those. And the last thing I want to show you is the Tomcat users XML file. So we're going to look at tomcat-users, and this is a place where you can configure users if you want to use the manager application within Tomcat. So I would specify a role with a role name and then provide a username, make sure that I've got a password, and then provide the roles as well. You can see there are some that are set up here. These are in comments. This right here is a comment, and this is a closed comment, so this won't actually take effect here because all of this is commented out. But if you wanted to implement this manager component of Tomcat, you would need to have a user installed, and this is where you would install users within Tomcat. A lot of what you would do from a security standpoint with Tomcat is make sure that your web application is written in a secure fashion, making sure that you're doing input validation, error checking, all of those good things. But there are a couple of things you can do with the configuration as well. And on an Ubuntu system, we are looking in etc Tomcat 7 for the various XML configuration files where you would make some of those changes. We're going to take a look at some ways that you can harden your JBoss installation. I'm actually on a CentOS system, and the CentOS system has JBoss Application Server 7 installed. And we're going to take a look at one of the configuration files here. So we're going to go into configuration. And then I'm going to edit the XML file so we can make some changes to the XML so that we can actually have a slightly better configuration in terms of security. I want to look for connector, and I'm looking for this particular connector here. What I want to do after this is add some additional configuration. And we're going to add a JSP configuration. So what we are doing here is we are disabling the source fragment. meaning that when an error comes up, what happens sometimes is you will get a chunk of stack trace code, various other information that could be useful or interesting to an attacker. So we're going to shut that off. And then we are going to turn off the X powered by. So we're not giving up any information about what application server and version we are actually running. That's going to close that off. Now we could also enable SSL here. So we could turn on a connector for HTTPS and then set the scheme and turn on SSL and so forth. I'm not going to go through that process here, but there is one other thing that I do want to do. Under virtual server, I want to make this disabled. I'm going to say false here. And what that's going to do is disable the welcome content that is installed by default on a JBoss system. If I disable the welcome content, it means that an attacker won't be able to go to this site while it's under construction or while anything else is going on and be able to get information about the fact that we've got JBoss installed and that it's possibly a new installation, which means that we may have some issues that they may want to make use of. Those are a couple of things that we can do. As I said, the other thing that we can do that's quite a bit more detailed is we could enable SSL. That really is just turning on an additional connector and providing information about where the key store and key files, as well as the CA certificate file, where all of that is turned on. Now, we've talked about installing an Apache server. And when you've got an Apache web server, you need to open up ports in whatever firewall you've got. And those holes in the firewall are going to allow your traffic to come through. So the problem with that is that allows application attacks to come into your web server and whatever web application that you've got running on that web server. So how do we protect against that? Well, we use a web application firewall. One web application firewall that you can use is one called Mod Security. So we've got Mod Security, and you want to choose probably this one if you're installing on an Ubuntu system. If you're running on a RedHat system or some other variation of Linux, you'll find a similar package. And then, of course, you need the core rule set. The core rule set is a set of rules that determines whether messages coming into your web server are actually malicious, and then you can determine how you want to handle those. So let's take a look at the configuration for Mod Security. First of all, we're going to go into the Apache configuration directory, and then we're going to go into mods enabled, and you'll see we've got security2.conf. So let's just take a look at security2. And what this says is we're specifying a data directory of var cache mod security. This is where any persistent data associated with mod security is going to be located. Now, the other thing that we've got here is it's going to read a configuration file in etc mod security. So let's go take a look at that. So we're going to go into etc mod security. When you install mod security, it installs modsecurity.conf-recommended. In order to make changes to these configurations, you need to move it over to modsecurity.conf. As you can see in the configuration that we looked at from the module itself, it's only looking for files that are named with a .conf ending. So this -recommended won't be read at all. So let's take a look at modsecurity.conf. There are a couple of ways to run a web application firewall. When you first install it, the best thing to do is run it in detection-only mode. Detection-only is going to parse the rules, and it's going to check all of your traffic against those rules, but the only thing it's going to do is generate log messages. It won't actually touch the messages that are going into your web application. It's only going to log them, meaning it's only going to be doing detection. when you are ready and you are sure that these rules aren't going to break your web application, you can turn the sec rule engine on. So there are a number of other configuration settings. Most of these aren't really all that interesting for the most part, unless you really want to go digging deep into the configuration and doing a lot of tweaks. The other one that you want to be aware of is when you actually find problems with your web traffic, it's going to log those into this log file here. So you're going to get a modsec_audit.log. So now let's take a look at where all of the rules are. These are located in user share modsecurity-crs. You can see there are some directories here. We're going to pop into activated rules, and I'm going to show you that there's actually nothing here. This is because you need to determine what you want to actually activate yourself. So here are a number of rules in base rules, and let's just take a quick look at one of them. We'll take a look at mod security, and let's just take a look at the generic attacks. Now, this is just a set of data that we could be looking for with any number of attacks, and let's take a look at one of the configuration files that would be associated with that data. So we're going to look at base rules, mod security 40, generic attacks.conf. So now this is the configuration file that goes with that data file that we were just looking at. So this is one of the rules here. You can see they can be really difficult to understand. It does take a little bit of experience to know what it is you're looking at here. So what this is looking for is a set of data here. This is actually a regular expression that tells the rule engine how to actually determine whether this rule gets triggered. If any of this data is found, then we trigger the second part of the rule, and then some of this has to do with what gets logged and also what the disposition of the HTTP request coming through should be. So for example, we may just drop it, we may also log it. There are a handful of things that we can do with the HTTP messages that are coming through and get identified by mod security. So if I wanted to activate any of these rules, I could go into activated rules, and then I could say, let's say we're going to activate all of the base rules into this directory here. So now I've got symlinks from the original rules. If I just show you here, -LA, you can see the files that are in here are actually linked to all of the rules in base rules. So now all of my base rules are actually activated, and all of these attacks are going to be noticed by my mod security installation. So mod security, again, is a web application firewall. You can install it and then do configurations. Once you've actually configured it, you can see the different rules that are in place. So we've got base rules, we've got experimental rules, and then there are optional rules as well. And you can enable any ones that you choose to enable based on your specific web application and what you want to protect against. Anytime that you need to do communication to a web server where you're passing information back and forth, you really need to make sure that you are encrypting that. So the way to encrypt it is to use something like SSL or preferably TLS to perform that encryption for you. TLS is Transport Layer Security. It is the more recent version of SSL. Does the same thing in a different way. It's considered to be stronger than SSL and, as a general rule, more secure. So the first thing that I need to do is create a certificate. Normally, I would go to a certificate vendor and create that certificate. There are plenty of vendors that will do that for you. Your company may even have the ability to perform that task for you and generate a server certificate. Server certificates are generally a fair bit of money unless you have your own certificate authority and your company is capable of doing that for you. In this case, for the purposes of demonstration, I'm creating my own self-signed certificate. So I am going to create a new request. It's going to be for an X.509 certificate. It's going to be valid for 365 days. We are going to use SHA-1 as our hashing algorithm for verification. We're going to get a new key, and the key is going to use RSA as its algorithm with 2048 bits. We're going to write the key out to the file server.key and then the certificate out to server.crt. And then I just created a bogus subject line. Doesn't really mean anything. Again, this is for the purposes of demonstration. My organization, I'm saying, is my company. My organizational unit is my department. And the common name is www.company.com. That's the server name in this case. Of course, that's not really my server name, but for what we're doing here, that's going to work just fine. The first thing I need to do is copy server.key into SSL private. So the key is going to go into private, and then I'm going to copy my server.crt into etc SSL certs. So now I've got my key and my certificate in place. I need to go into my Apache configuration, and there's two things I need to do here. First of all, I'm going to go into mods-available, and we'll just take a quick look at the SSL configuration here. So this is the configuration for the SSL module. So we've got a number of parameters that we're not going to touch at all, and then I want to show you a couple that you may want to touch at some point. The SSL cipher suite. This is only going to enable medium and high ciphers. You may potentially want to remove medium from this list. And then the other place that you may want to take a look at is the SSL cipher suite. You may want to specify some particularly so that you guarantee that what you're getting is a very high degree of confidence that you're using the best algorithm that's available. The other thing that you may want to do is SSL protocol is currently set to all. You can force TLS v1.2 or some combination of TLS and potentially get rid of SSL v3 because SSL v3 is considered to be weaker than the other. So you can force the use of TLS over SSL here. I'm going to go up into mods enabled, and I'm going to say ln-s mods-available, and then I'm going to create a symlink here to this directory. So now we've got the load file and the configuration file in place so that we'll actually load up the SSL configuration and make sure that we are loading the modules. So now I need to go into sites-available, and you can see there's a default SSL config there, and we'll take a quick look at that. There's one thing that I need to do here, and I need to, first of all, you can see the SSL engine is on. In this case, what I'm going to do is replace these files here, which would be perfectly fine, except that what I've got here is server.crt. These are ones that just come with the standard Apache configuration. These are keys that are already in place. I'm going to use the ones that I actually created here. And then the rest of this, I'm just going to leave alone. So you can see that we've got a number of other parameters. Some of this is common for just an Apache configuration. You can see we're setting up directory parameters. So this is what you would do for any virtual host site. In this case, we're just adding some SSL parameters on top of it. All right, let me clear the screen here. I can see exactly what I'm doing where I'm moving files around. I want to make sure that I'm in exactly the right place. So I'm currently in sites-available. I'm going to move up into sites-enabled. And you can see I don't have an SSL configuration here. So I'm going to say ls-la. That shows me that I'm symlinking here. So I'm going to do the same thing here. I'm going to say sites-available. and then default ssl.conf, and I'm going to symlink it into this directory here. So now I've got an SSL configuration. I've got everything in place. All I need to do is say restart the Apache service. So now that we've restarted Apache, we should be good to just connect to our local host over SSL, and we should get an SSL connection. And of course, we're going to get certificate warnings, but let's just see what we've got here. So I've got an understanding the risks. I'm going to add an exception. And sure enough, we've got an SSL configured Apache on our local Apache server. One way of limiting the amount of spam that you get at your mail server is using a technique called gray listing. What gray listing does is it delays mail from somebody that it doesn't know about. So if you get an email message in, what the gray listing software will do will be to send a completely legitimate SMTP response saying, hold on. If it's a legitimate sender, that legitimate sender will go, oh, okay, I'll wait some period of time and then I'll try to resend. What the message that they get indicates is this is how long you should wait. Now, some software is good about waiting that period of time. Some isn't so good, but really gray listing works pretty well. There's a piece of software that you can install on Linux systems called PostGray that works with the Postfix mail server that is actually really good at doing this gray listing and limiting the amount of mail you are getting from illegitimate senders. So let's take a look at PostGray. And the first thing I'm going to do is I'm just going to show you where all of the different configuration files are stored. So we've got etc PostGray, there's whitelist clients and whitelist recipients. If you want to make sure that some mail servers or some people who you are getting mail for always get through the gray listing, then you can put them onto these white lists. So the next thing that we need to do is figure out what port that PostGray is actually listening on. Now I can tell you, but I'm going to just do this so that we can just double check. I'm going to send this off to Les here. Now, in this case, I happen to know that it's 10.0.23, so we can see that that's actually listening there. So the next thing that we need to do is go into our postfix directory. I'm going to edit main.cf, and I need to find the recipient restrictions line. And in this case, I don't actually have a recipient restrictions line. So what I can do here is I can use a program called postconf to actually add that line in for me. So I'm going to add SMTPD recipient restrictions, permit my networks, that's going to be okay, permit SASL authenticated. So if anybody has authenticated, that's okay. We're going to reject unauthorized destination. And then finally, we're going to use a policy service. And I'm going to check my local host on port 10.0.23, and that's where our graylist software is actually stored. So now I can take a look at main.cf again. And I ought to have that line at the very bottom. Sure enough, I do. So let's dump that. Now all I have to do is reload my postfix server here. And now I have my gray listing software configured. And so I should be able to send messages in from somewhere, and I would see something in my mail log indicating that the message had actually been delayed. So one other place that I want to show you here while we are looking at the configuration for this is in the default directory. This is where defaults for a lot of different services and programs are stored. And I want to look at the PostGray defaults here. So we've got options that tells us which port we're actually listening on. The other thing I can do is say delay is equal to some period of time. The default is going to be 300 seconds, which is 5 minutes, and I could say 30 seconds, I could say 60 seconds, maybe I could say 180 seconds here, and that would be okay. I would have to restart my PostGray server for that to take effect, but gray listing is a really good way of making sure that some of these bogus senders aren't actually getting through to your mail server and getting spam into you. Syslog is the system logging facility, and Syslog is where most applications actually communicate in order to generate log files. Log files are incredibly important for system administrators, developers, lots of different people who need to figure out what's going on with the system. Most Linux systems are going to store their logs in the directory varlog /var/log. And you will see that there's actually several log files in this directory. What determines what log file gets used is a configuration file. So we're going to go into the directory where the configuration files are stored. This is rsyslog.d in this case. Many Linux distributions at the moment are using rsyslog for their syslog server. Over the years, there have been a lot of different syslog servers. This is one that's popular currently. There used to be one called syslog-ng for next generation. There's the original syslog. BSD has a syslog. There's a lot of different syslogs that are available. As I said, this one is fairly common. On many systems, this is the directory where all of the configuration files for rsyslog are stored. If you've got multiple configuration files, like a system-specific one, and there may be some others, it's fairly common these days to break up configuration files into multiple files. In this case, this system doesn't have multiple files. It's just got one. So we will take a look at that. And that is going to be called rsyslog.conf. So you can see we've got modules. It supports loading different modules that give different support. And then we've got our global directives down here. Down at the bottom, this is the one that I'm really most interested in at the moment. On the left-hand side, you can see the facilities. Auth and authpriv, cron, daemon, kern, LPR, mail, user, those are all facilities. A facility is a way of grouping different logs into a single category. So all of the mail transfer programs will use the mail facility, for example. Any service that is just running in the background would be called a daemon. They may log to the daemon facility. Authorization is probably going to log to the auth facility. So we've got our facilities on the left-hand side. There are about 14 or 15 facilities in all that are specified by the syslog standard. In this case, we're only referencing a handful of those. You can certainly add the other ones in if you want. These are the ones that are most common that you're going to run into. You will also notice here there is an asterisk after the facility. The asterisk is there to indicate the severity. So there are a small number of severities that you can specify, from informational all the way up to critical. You can indicate that you only want to log some of them, and different severities you may want to log to different files. In this case, basically, any severity at all in these particular facilities are going to get logged to these files. These are the files that we are going to log to. So you can see all of them are in varlog, and then each of them has a separate log file based on the facility. You could, of course, dump everything into the same log file, but that sort of defeats the purpose of creating facilities to begin with. As I said, log files are incredibly useful. When you have a problem with your system, one of the first places you're probably going to want to go is the log file. Just go into varlog and see if you can find an error message or a warning or something in the relevant log file to indicate to you what's going on. This is really handy when you've got services that are running that are going to be logging using syslog rather than dumping something out to the terminal or console that you can actually see. So programs that are maybe services that are running in the background that are daemons, or maybe user interface programs, GUI-based programs, they may also be logging because they may not have a good way of dumping error messages out somewhere that you can actually see them. So the log facility on any Linux system is probably going to be some form of syslog. You're going to be looking for a syslog configuration file to tell you what facilities log to what files, or of course you can also just look in var log, and in most cases it's going to be fairly easy to determine what log file goes to which facility. For example, kern.log is obviously the kern facility, daemon.log is the daemon facility, mail.log is going to be the mail facility, and so on. So syslog is a really important service that's running, and we will be talking about how to actually read these log files coming up. A pretty common activity when it comes to syslog is to send the syslog messages off the system. So what I want to do is show you how you would configure your syslog server to send your log messages off to another system that's actually listening for those syslog messages. So let's just take a look here at the default configuration. We've looked at this, and this is where all of the log files are stored. If I want to log to another system, what I can do here is just add in a line, and I'm going to say basically everything here. I want to send off to, let's say, 172.30.42.5 is going to be my remote syslog server. And then I'm going to specify the port number. If I want to add another system, all I would have to do would be to create an additional line, and I could say my log server dot, let's just say remote.com. Now, that's sending everything off to those. For example, say mail.asterisk. So all of my mail messages send to a mail log server. And then my user messages, maybe, I wanted to send to a local server. And I forgot the port number here, so let's add that in. So now I have configured my rsyslog server. Again, we're using an implementation here of syslog called rsyslog. Similar sorts of statements will work with different syslog implementations. rsyslog is a pretty common implementation on Linux distributions. So this would be how you would configure your Linux system to send your syslog messages off to a remote server. There are some good reasons for doing that. If an adversary or an attacker were to gain access to your system, they may be able to corrupt or remove your log messages. If your syslog server is sending the messages immediately off to another system, doesn't much matter what your local system says, your log messages are protected on a syslog server that is somewhere other than where your log files or your local system actually is. So now you've got two places where your log files are, assuming you keep all of the entries below here in place. So you've got logging locally as well as remotely. If there is some sort of discrepancy between the two of them, you have to figure out which one you trust. I'm going to assume probably that your syslog server is well hardened, and probably the only service listening on it is going to be the syslog service. So assuming that that's not vulnerable to any exploit, probably the logs on there are going to be the reliable ones, and you might assume that the local logs on this particular server, for example, maybe are not so trustworthy because potentially your system has been infiltrated and the log messages have been corrupted or potentially removed. So that's a good reason to log to a remote syslog server, and this would be how you would configure rsyslog in order to do that. Now that we've talked about configuring the syslog server, let's talk about how to read the log files. So we've got the log files. Typically, they're going to be in var log. All of your log files are going to be here. There is a log rotator that typically runs on Linux systems that will rotate the logs out, meaning it's going to store old ones and then create new log files. That's why you'll see some of these log files have been gzipped, which you'll see here. So we'll talk about log rotation a little bit later on, but right now let's just talk about how to read a log file. We're going to take a look at the syslog file here, and I'm going to use less, which is a pager, which means it's only going to show a page at a time. So if I just do this, we've got one page, and of course I can hit space, and then I can back up. Now we're looking at a syslog message file here. So the first part of the message file, each message is going to be tagged with a timestamp. So you can see this is the particular timestamp for this message. This timestamp is based on the local time of the system. So in order to figure out what time this really is, if you're talking about multiple time zones, you need to figure out what time zone you're actually in. The next column here, or the next set of messages, is the name of the system. This is the name of this particular system, so all of the messages in this file are going to have this for the system name. Now, if you're doing remote logging and all of your log messages from multiple systems end up in a single log file, of course, this particular entry here is going to be different for everyone. That's how you can figure out which message corresponds with which system. So we've got our system name here. This is going to be followed by the name of the process that actually generated the log file. In this case, it's Anacron, and we've got the process ID. The process ID in this particular case is 19715. That is associated with the Anacron process. Anacron will actually run processes hourly, daily, weekly, monthly, and so on. In this case, what it has done is probably this has just finished rotating the logs in this case. You can see the very first message is that the daily cron job has terminated, and then we get a normal exit as the message. So having said that, let's move into the last portion here. This is the actual message that the process has generated. All of the rest of this is created by the syslog daemon or service. This is the actual message that is being sent to syslog, and that's what's being written out. So this says job cron.daily terminated. This is pretty simple to understand, not very complicated at all, even though these log files can look really challenging to understand. If you just take them a line at a time, kind of pull out the bits that you know what they are, and then get to the actual message, most messages are fairly simple to understand. We've got another one from the DH client. This is the Dynamic Host Configuration Protocol client, and this is a set of log messages here related to obtaining a particular IP address that has been acquired using the DH client process here. After that, you've got Network Manager, and then dbus, cron, DH client, network manager, and so on and so forth. So you can see all of the different log messages that are associated with each of these processes. So now I could go into, for example, mail.log. There's no mail being sent back and forth with this particular system. So we could look at, for example, the kernel log, nothing from the kernel log. And we've got the auth log. There should be some messages in the auth log. So you can see all of the messages associated with logging in, logging out. Sudo, for example, would be logged into this particular message. So you can see that there as well. Again, same message setup here. We've got the date and time stamp. We've got the system name. And then we've got the process. And then, of course, we've got the message that was generated by that particular process. So reading syslog messages is actually fairly straightforward. Most of the messages are going to be in readable and understandable English. Every once in a while, you'll come across one that may be a little bit more obscure. You may have to have some specific knowledge of a particular application or the application internals in order to really understand what's going on. But for the most part, you're going to be able to read these log messages now that you kind of know what the individual pieces and components of each log message are. Maybe it makes it a little bit less intimidating to see all of that text and these really big log files. When you're looking at log files, there's an awful lot of data that you can accumulate, particularly on a running system. Now, with this particular system, I don't do an awful lot with it. It just kind of sits here. I'm using it as a virtual machine for what we're doing here, and really not an awful lot else, but you can see that I'm accumulating log messages. You can see this column here. We've got the size of the log file. All of these logs really kind of accumulate data as the system is just running. What we can do is we can run the log watch command, and that will help us really parse through some of the important things that are going on in these log files that we may actually want to pay attention to. So let's take a look here inside the log watch directory. If I go into user share log watch, we've got the default configuration, and we're going to hop in there for just a second here. We'll take a look at the logwatch.conf file. So this is the configuration file, and you can see we've got yes equals true, equals on, equals 1. All of those things are the same. No equals false, equals off, equals 0. Our log directory is in var log. That's going to be pretty standard. This is going to output to std out. Of course, we could also do a text format and an HTML format. We could output to a file. We could output to mail. We could do a base64 encode. There's a lot of options here around output in format. If we were going to mail, who are we going to mail to? I could mail to root. So the root user on this particular system is going to get the output of log watch. I could mail to a particular user at another domain or on another system using a different command format here. And that's all of the configurations around mail. So now we want to get into what we are going to be looking at. Now, by default, logwatch is only going to look at the primary log file. So for example, if we had a varlog messages file, it's only going to look at varlog messages. It's not going to look at varlog messages.1 or varlog messages.1.gz, which are the rotated logs. So I have turned on archives here because I want to look at everything. So my range in this case is going to be all. I could do range today, range yesterday. If you were to run logwatch every day, you could set it to just today or yesterday, depending on when you're actually running logwatch. So a number of other settings here. The service that we're going to be looking at is all in this case, meaning it's going to look through everything that we actually know about here. So you can disable network services, you can enable network services if you didn't want to look at all of them. I'm actually going to disable this entry here, or not, because I'm not doing this as root. So I'm just going to leave that one alone because it's not actually going to be able to write out because I didn't edit this as an administrative user. So we'll just leave that alone. So let's take a look in our services directory. You can see the different services here. So for example, let's take a look at the Samba config file. It's got a title of Samba. It's telling it which log file to look at. And then we're not really looking for much of anything else in this particular log file, but it does tell us which log file to look at. So let's take a look at secure.conf. Again, we've got a title of connections. Log file is secure. We've got some other things that we are going to look at here. So for example, we've got Pop 3 is going to be connections, and we're only going to output 500 of them. So we're going to ignore SSHD, STunnel, ProFTPD, SASL, AuthD, IMAPD, and so forth. So all of these we're not going to look at. You can see we've got a number of different configuration files here that tell LogWatch how to actually look at the log files and what to do with them once it is done looking at them. So now we can just run it here. And I'm going to run LogWatch, and you can see we've got a lot of output here. So I'm going to scroll back up, and you can see, in this case, this is the sudo log file. So I now have a very short list of the different things that I ran using sudo. And this is a really helpful little summary to have here, so you can see the administrative commands that somebody actually ran, and you can see the user and what user effectively ran at. So this is my user, and I was effectively root, because of course we can use sudo to run as any other user. So now we've got some errors that are showing up here that came from log files. If I scroll up, we've got some new groups that were created. We've got some password expiries that were changed for users. So we've got a fair amount of detail that is coming out of LogWatch. So you can use LogWatch as a great way of summarizing activity on your system by parsing through the log files. And again, you can turn on services, you can turn off services, you can specify exactly which log files to look at, and you'll get this nice little summary. So you can certainly use LogWatch within cron and have this run however often you wanted to, and then you could either specify today or all, depending on what log files you actually wanted to look at historically. Now, previously, what we had done with syslog was to send our syslog messages off to another server. What we need is a server that's actually going to be listening for those syslog messages and will store those locally. Why would you want to do that? Well, let's say that you've got a security information and event management system, which is sometimes called a SIEM. That security information and event management system will look at an aggregated set of log files in order to do correlation, so that you could, for example, have a single alert about an attack or some other incident that may be happening on your network. So let's say, for example, and just kind of jumping to a catastrophic sort of place, that somebody's launching brute force password attacks on all of the systems on your network. You may want to have a rule in your SIEM that's going to notice that, and the SIEM will actually generate a single alert if it knows to pay attention to those sorts of things, rather than, say, 50 or 100 separate alerts on all of the individual systems. So this really makes security management and log monitoring significantly easier if you've got all of your log messages in one place. So let's just take a look at a couple of ways that we could actually do this. We could set up a listener on our local syslog server so that other people can send messages to us. So we've got one of our configuration files, and I just dumped these rules down in the bottom here. So I could say $input TCP server bind rule set remote, $input TCP server run, and then specify a port number. And then I could do the same thing with UDP. UDP is really the common syslog approach. The default for syslog is to run on UDP. TCP is more reliable, of course, so there is some advantage to using TCP over UDP. If you want to make sure that all of your log messages have been received, you really want to use TCP there. Otherwise, there's no guarantee that your log messages that have been sent have actually been received by the server. So the other way that we can do this is we can actually load up a module here, and then we're going to say $UDP server run, and then specify the port number. and then I'm going to load up another module for TCP, and I'm going to specify that I've got a TCP server that's going to be running again on port 514. So now I should be able to just restart the service, and it's going to stop the service, start it back up again, and reread the configuration files. Now, if I just run netstat and specify the listening ports or the services that are listening, and I'm going to pipe that through to less just so that we can see here. Now we've got, I know this says shell, and I'll show you the numeric version of this in a second. That's actually what's been associated with TCP port 514. Down here, though, if we look a little bit further down, you'll see we're listening on the syslog port for UDP. Let me just show you the numeric version here so you can see that we are actually listening on port 514 for TCP. So if I do a -n, you can see that we're listening on port 514. So I've got my syslog server listening there, and then I've got my syslog server listening there as well. So now I have a syslog server that is going to be listening for log messages, and it's going to store them out to where all of my log messages are stored to. We're going to be using the local syslog configuration to determine the log files that I am storing into. I'm using my local configuration for that. The remote configuration doesn't mean a thing because the remote configuration just says send it off to another system. We're going to get the facility and the severity, and then my local syslog server is going to determine based on that where the log messages actually are going to be written out to. There are a couple of log files that we haven't actually talked about yet. So let's go into varlog again. And you'll see here there is a wtemp file. It's about 11K, and this particular log file keeps track of the logins on a system. If you see a utemp file, that is going to be a historical version of wtemp. In this particular case, we have a wtemp.1. Now, you're not going to be able to read this directly, so I could just take a look at this here and I'll show you. This is a binary file. I'm going to say no to this. So how am I actually going to be able to see this particular log file? Well, I'm going to use the last command. The last command is actually going to read that log file, and it's going to give me the output. So you can see I've got a couple of instances that are still logged in, and then I've got some going back a few days at this point. So if I wanted to see the older version, what I could do would be to say -f wtemp.1. And now we've got a more historical record of the logins over some period of time that that particular file covers. Now, as I mentioned, you could see a utemp. You might also see a btemp file, which I don't happen to have here. The btemp file is going to have all of the failed logins. There is another command that I just want to show you here, and that is last log. The last log reports the most recent login for all users. So I could say last log, and then I'm going to pipe that out to less. And you can see root's never logged in. All of these different services have never logged in. That's all of the different services and the users that are on this particular system. So we also looked at last, and we'll just take a quick look at the manual page for last. So as I said, we've got btemp, and that is the failed logins. Utemp is the historical record of wtemp, and wtemp here is the log file that last actually reads through by default. So I've actually got a different command, lastb, which is the same as last, except that it shows the bad login attempts. So if I wanted to look at a different file that has the same data as the binary format in wtemp, I could specify -f. we could just take a quick look at last B. I don't believe there's any failed logins. And it tells me when it began, but we've got nothing there. So that's another set of files that can be really useful. You can see wtemp, and we've got btemp there as well. Let's just see, because it looks like there's a btemp -1. So we'll just take a look at that. And so there's no bad logins there either. Those are another set of files that you want to take a look at. As I said, they're binary versions, so you need to use these programs last and last B in order to be able to see the logins from users that have been on your system. Every operating system needs some antivirus solution. It doesn't matter what operating system you're running. Certainly there are people who believe that only Windows is subject to viruses. That's absolutely not true. Every desktop operating system, even server operating systems, are prone to viruses. This includes Linux. So you need some sort of antivirus solution, particularly if you're running a server where files may be coming into your system. If you've got a website, for example, where people are allowed to upload anything, you absolutely need antivirus. If you're running a mail server, it's really helpful to have an antivirus solution running on your system. So there are a handful of antivirus solutions that will run under Linux. One of them happens to be open source, and it's called ClamAV. So there are a couple of components to ClamAV that I want to talk about here. The first one is called FreshClam. FreshClam is the program that will go and make sure that your signatures are up to date. Now, you'll notice that I used sudo in order to run FreshClam. That's because this is a system-level activity, meaning that the signatures are all stored at the operating system level. So for the entire system, that means I need administrative privileges in order to make these update changes. So once I have got an update, what I can do is I can now run ClamScan. And I'm going to do a recursive ClamScan. And I'm running it here. This is in my home directory. It should just be running against all of the files in my home directory. And then you can see we did a recursive scan that looked through everything. I scanned 465 files and ended up finding nothing there. So in order to scan the entire system, now I need to say ClamScan, and now I've got to run with administrative privileges. So I need sudo, and I'm going to say recursive again, and we're going to run it against /. So now we're going to scan every file on the operating system. Everything in the file system is going to be scanned. There are a number of directories that I'm just not going to be able to scan. The pseudo file systems like sys and proc and probably most of dev aren't going to be able to be scanned. We're going to get a number of errors, but we're going to scan basically everything else. And so we're going to make a complete scan of the entire operating system. And then once it's done, we'll get a report, just as we did when I scanned my home directory. We'll get a report of all of the files that are on the file system. So let me just cut this short here because it's scanning a very large file system, and I just want to stop it short so we can wrap this up and not have it just screaming across the screen like that. So FreshClam gets you signature updates. ClamScan will do the scan for you. ClamAV, as I said, is an open source antivirus solution that runs on Linux. And as I said, Linux is definitely prone to viruses. You should absolutely get an antivirus solution if you are running a desktop. And if you're running a server where files are coming through your system, absolutely get antivirus in place. In addition to antivirus, intrusion detection systems are important. One of the oldest host-based intrusion detection systems is one called Tripwire. So we're going to take a look at Tripwire. By host-based intrusion detection systems, what I'm talking about is a program that makes sure that critical files and binaries or applications on your system don't get modified without your knowledge. Now, Tripwire takes the concept of security pretty seriously. So it's not just a question of we're going to scan your system and we're going to make sure that everything matches up. The thing is, we've got to make sure that when we run a check that we have valid and verifiable results and that they can't be manipulated after the fact by some attacker who's gotten in. If an attacker can modify your Tripwire results so that the next time you run, it shows that a file that actually has been modified hasn't been modified, then that's a problem. So we use encryption keys in order to help solve that problem. We need to create a couple of keys here. So I'm going to run twadmin generate keys, and we need a site key. So site key file is going to be site.key and then site-passphrase. I'm going to give it a passphrase here. Now I can run twadmin here and generate my keys for this. I actually already have a key, so I'm not going to run this because I don't want to clobber the key I already have. The next thing I need to do is create a local key. So I'm going to run twadmin again. I'm going to run generate keys, and then I'm going to say local key file in this case. So I have my site key file and my local key file. And this is just going to be local.key. And then say local passphrase again here. And then give it a good passphrase. These aren't particularly good, but give it a good passphrase so that you can generate a key that actually has some value to it. So now it's going to generate the key. We actually have that complete. I do already have keys in place. This is the local key that I will be using, but I wanted to show you what the generation process actually looks like as well. So now we have a couple of text files, and those are going to be important for us. So the first one is twconfig.txt. This has a number of settings where we can change how Tripwire actually works. I'm going to leave all of these alone. These are just fine. They tell us the root for where Tripwire is, the policy file, the database file, and then we've got the report file, all of those things. So the next one I want to take a look at is actually the policy file. So the policy file is important because it tells us what we're going to be looking at. So first of all, we've got the TW binary location is user sbin. The etc location is etc tripwire, and the var location is varlib tripwire. So now we've got a number of configuration parameters. We've got tripwire binaries. These are the actual tripwire binaries so that Tripwire can know where it is. And then we've got a number of other settings indicating where important system files are located and the password files. And then we've got rule changes around system boot and various log files that we may not want to pay attention to. And then a number of other locations that we want to scan. So this policy is really the places that we want to scan and the things that maybe we don't want to pay so much attention to. So we use twadmin again in order to, and again, I need to be sudo. So twadmin create CFG file, and my CFG file is going to be my twconfig. And the site key file is going to be site.key. And then I need to give it the input file, which is going to be twconfig.txt. This would ask me for my site passphrase, and then it's going to write out my configuration file. So I've already got a configuration file written. I'm not going to do that. I'm also not going to do a policy file because I've already got that created. I do want to jump up to making sure that we have actually created the database and then run a scan. So you would also have to do the same thing for the policy file. So you would do twadmin and then create pol file. And then basically the same parameters. You give it the policy file, and then the configuration file, the site key, and then the text-based version of the policy. Now we need to create the database. So now I'm going to run Tripwire. In it, my CFG file is going to be tw.cfg, and then my policy file is tw.pol, and then site key file is going to be site.key, and then my local key file is going to be the one that was created when I did the installation. So when I did the installation of Tripwire on this Ubuntu system, it actually walked through doing the creation of the keys. And it was really just as simple as you give it a passphrase, you verify the passphrase, and it goes off and creates the keys for you. Now I'm going to do an initialization here. It's looking for my local passphrase. We are going to be generating the database with all of the initial values. So what it's doing is it's going through the entire file system, creating hashes of all of the important files, and then storing it in this protected database. Once we've got the initial file done, all I have to do is run tripwire -- check, and that will run checks against the policy and the configuration, and then check it against the existing database. So that's how you would use Tripwire to help protect your system against any unauthorized or unexpected changes to critical system files or binaries. Tripwire, of course, is not the only host-based intrusion detection system, and I should probably be clear in saying that doing file verification and integrity checking isn't the only way of doing host-based intrusion detection, but it is the classic way, and it's the way that we've been doing host-based intrusion detection for quite a while now. Another way of doing file verification, file integrity checking is through the use of a program called Samhain. So we're going to pop into the Samhain directory here, and you'll see that we've got just a configuration file. So let's take a look at that. So this is the configuration file. We can do basically the same sorts of things that we could do with Tripwire. You can set all of the different directories that you want to look at. You can specify files that you want to see. So for example, these files that you can see listed here, we're only going to be checking for changes in permissions and ownership. We've got log files that we're going to look at. We've got growing log files. We've got a set for ignores, and then we've got read only. So a lot of different sections here in the configuration file that we can use to set up exactly how we want to monitor our system. Once we have got the configuration file set up the way that we want to, the first thing that we need to do is initialize the database. Just as we did with Tripwire, we have to create a baseline. So we're going to go through and generate signatures for all of the files that we are specifying. At this point, we've gone through and we have done the initial creation of the database that it's going to use. Now, you'll notice that one thing that we haven't done here is we haven't signed anything. So there is no signature on anything, not using any sort of cryptographic hash, any sort of signature, nothing like that. Now, what you can do certainly is you can use something like GPG to do the signing by hand if that's what you want to do. Now, once we have done the initialization of the database, all we need to do is run periodic checks against it, and we can do that using -t check. So now we're going to run through, and obviously at this point, we haven't really done anything because we just barely ran the initialization, so we haven't found anything here. So you can use Samhain as another way of doing file integrity checking, similar to what Tripwire does. You're going to configure it with all of the things that you care to be looking at. You need to initialize the database, and once you've got an initialized database, you can just keep running checks against it. Of course, if you want to change your baseline, you need to reinitialize your database, and that same is true with any file integrity checking program. If you want to update your baseline because you have done a system update, for example, you need to reinitialize your database so you can create the new set of all of the hashes that correspond with the files on your system. What I want to do right now is take a look at Prelude. Prelude is a way of sending alerts from a few different types of intrusion detection systems into a single place so that you've got one location to store them. Now, I have installed various Prelude components here, and I can show you which ones are actually installed. I'm on an Ubuntu system here, and if I just search for Prelude, we've got Prelude Correlator, Prelude Log Agent, or Prelude LML, Prelude Manager, and Prelude Notify. We've also got some additional components that would have to be installed with libraries and so forth, but I just want to show you Prelude at the moment and how we would get the Log Manager agent registered to the Prelude server. The first thing I need to do is run as administrator, prelude-admin, register, and we're going to register Prelude LML. So we need to register all of our agents into the Prelude server. Now I need to give permissions for alerts. So I'm going to say write, and then admin is going to get read privileges here, and then that's 127.0.0.1 is going to be my local host here. I'm going to just say yes here, and it's going to generate a key. Now it's looking for a one-shot password. So what I need to do is go to another window here, and I am going to run this command right here. That's going to generate me a one-time password that's going to allow me to complete the registration. If I just run this, and I need to be administrator here, it's asking for the password on the other window. This is the password it's looking for. So we'll go back over here, paste it in, and it should ask me to verify. So I'm going to paste that in again. Now we have succeeded with the authentication, and we're going to connect to the registration server. And over here, we've got to approve the registration. Now we have successfully registered the log manager into our Prelude admin, and you would do the same thing with other agents that you wanted to connect into your Prelude system. You would have to register them and go through the process of key generation and then getting them associated as we did here. There are places that you can go for additional configuration here. For example, if we go into Prelude Manager, there's a configuration file there. If we go up into Prelude-LML, there's configuration files here as well. In addition, there's rule sets. So if we were to look at the rules, there would be rules related to the various services that are on this particular system. So for example, we could take a look at sudo rules here. I'm going to look at the sudo rules. You can see we've got rules that are related to what it's going to look for in the log files. And this is going to tell Prelude LML what it's going to be looking for and how it's going to alert on it. So Prelude is another thing that you can have on your system that's going to help you manage different components like intrusion detection systems like Snort, and again, like this Prelude log manager, Prelude LML. Now, there are a number of different intrusion detection packages that you can install on Linux. They do different things. Mostly, they do this file integrity checking that is really important on systems to make sure that your files aren't being adjusted without you knowing about them, particularly with respect to system files, so you don't have like rootkits installed and that sort of thing. Let's take a look at another one. We're going to take a look at AID in this case, which is the Advanced Intrusion Detection Environment. So we're going to go into etc aid, and you can see we've got aid.conf. So I'm going to just take a look at aid.conf here. Pretty standard configuration, tells us where the database is, and then whether we're going to do gzip. There are a number of other parameters here. I'm not actually going to change any of these, but just kind of skim through here and see what we've got. We can set a number of other rules here. I'm not going to worry about that. I'm going to set my log rules to say owner mode. This is all fine. Now let's pop into aid.conf.d. And you'll see what we've got here are a number of configuration files for different packages. So one example here, let's just take a look at this one. So now this specifies log files for ClamAV. That's good. We've got a set of log files there. We're going to take a look at procsys here. This is another configuration file. So you can see it specifies a number of configuration files. What this says is don't do these directories. It's fine. We've got a number of configuration settings that are specific to different packages that may be on the system. So let's just pop back up and take a look at what we've got in the last directory here. And we've now got some other settings with respect to sources and app. This is all fine, a number of settings. Now I want to run aid init. So now we're running aid-init. What aid init itself does is it's kind of a wrapper. If I were just to run aid-init before I had run aid init, there would be an error message saying it couldn't open a particular file. So this wrapper program here does some additional setup for me. And now we're just doing an initialization on the database. Once we have gone through this initialization, we can run a check on it. Now, there's a couple of different ways to do that. So I'm just going to kill this just to show you because it's going to take a while to run through the entire file system. What I'm going to do is say aid-check is one way of doing it. The other way of doing it is saying aid.wrapper and then do a check. So the aid.wrapper is a wrapper script to make sure that everything is kind of in place. Now, there's something else that we've got going on here, which is going to be our cron script. And our cron script should be set up in cron.daily so that we have a script that is actually going to run through and run the aid check every day for us. And you can see that we've got the aid script set up in our cron. Cron, again, is going to run through everything on an hourly, daily basis. This is our scheduler application, and you can see that aid is scheduled to run once a day. We're going to take a look at a different type of intrusion detection system at this point. Rather than looking at host-based intrusion detection, we're going to take a look at network-based intrusion detection. The common network-based intrusion detection program or application that runs on Linux and frankly runs on other operating systems as well, but the common one that's used is one that's called Snort. Now, there are pretty easy ways to install Snort on most versions of Linux, or most Linux distributions rather. And we can certainly do that here on this Ubuntu system. Let me just do a quick search for Snort, and you'll see that we've got Snort, Snort Common Library, Snort Doc, and Snort Rules default. If I were just to say apt-get install Snort, then it's going to install all of the right pieces for me. And in fact, that's what I've done here. So let's just take a quick skim through the configuration file. And I'm going to edit it in admin mode just so that if I make changes, I can actually write them out. This is a fairly detailed configuration file, very well documented. This is the default configuration file. You want to set your home network and then your external network. This is going to be set actually as this note. There is etsy snort.debian.conf that this particular variable is overridden by. So we should take a look and make sure that that's not actually there. This is an Ubuntu system, but it does inherit from Debian. So we want to make sure that that's not there as well. Now we've got DNS servers, SMTP servers. You can certainly configure all of these variables and ports if you want to. The important parts down here are the rules and the preprocessor rules. And then, of course, there's also whitelist paths and blacklist paths if you want to do that. Now we can configure the various decoders that are going to be used. And you can see most of this is actually enabled by default. Certainly, if you want to look at oversized alerts, if the length is actually greater than the length of the packet, you can turn that on. There's oversized drops. There are ignore ports if you want to ignore some things. And normally, you would also have to configure outputs as well towards the bottom of the file here. But in more recent versions of Snort, what they have done, and let's just hop down to the output section here. What they have done recently is shut off all of the old ways of doing output. So you used to be able to do syslog as well as different databases. Now they just write out to a binary log file called snort.log. So everything gets written out there. There's no separation of anything. Actually, there's not even any other way of doing it with the more recent Snort installations. You've got Unified 2, you've got your snort.log. There is another program that you can use to actually handle the conversion of this binary log file to other formats, and we'll get a look at that a little bit later on. So what I'm going to do here is turn on syslog, and then I'm going to also turn on pcap, because what I want is I want some tcpdump output that I can actually look at in Wireshark. So I'm going to save that, and then what I need to do is restart Snort. So I'm just restarting Snort with these new parameters, and we can take a look here. We do have the snort.debian.conf, and we'll take a quick look at that before moving into the rules directory. So here's the various configurations that are set up on this system. So we've got our home network, our Snort interface, and then we've got a couple of other parameters that we don't really care so much about in terms of things that we might want to consider changing. Now let's hop into the rules directory, and you can see all of these rules are here. These are actually enabled just by virtue of being here for the most part, unless you've disabled some of them in the Snort configuration file. Now, these are updated periodically, and there are a handful of ways that you can actually keep these rules up to date. You can use a program called pulled pork, for example, to pull current rules and make sure that your Snort rules are regularly kept up to date. For our purposes, these are going to be just fine. Again, we've taken a look at Snort here, which is a network-based intrusion detection system. That means that it listens on the network interface for various types of attacks or intrusion attempts. When something like that happens, it matches on a particular rule, and let's just take a look at one of these rules so that you can see what we're actually talking about here. These are going to be written in a form where they are being matched against network packets. So let's just take a look at the webattacks.rules. What we've got here is an alert if it's TCP from an external network to one of our HTTP servers on an HTTP port, then we get a web attacks message. And what we're looking at here is a class type of web application attack. You can see that some of this is actually fairly easy to read. Others, you really need to be looking a little bit more closely at it to be able to determine what's really happening. As an example, what we're looking at here is for the existence of /bin/ps in the URI content. So there are other places where you may just want to be looking in the content of the message itself, and you can see those down here as an example. And some of these you can see no case, meaning we don't really care about what case it actually happens in. You can see the hex encoding here. This is ASCII encoding. The %20 is an indication that this is actually a space, because the %20 says this is actually a hexadecimal value that should be converted to an ASCII character code. 20 converts to 32 in decimal, and 32 in decimal in the ASCII tables is a space. So if we see PS %20 in the URI, that's really a PS space. So that would actually be an attack there. So you can see there's a lot of attack types. This is just the web attacks file here. There are a number of other attacks as well. So Snort is a very powerful intrusion detection system. If you need something for your network where you are looking at all of the traffic that's passing by your network interface, Snort is going to be a really good option for you on a Linux system. Now, once we've got Snort configured, we need to be able to do something to get alerts out of it. Remember, what we've done with Snort is we've created a unified log file that's really in binary format, so that's not going to be very useful in most cases. So we need something that's going to read that output file and generate alerts and maybe put the output into different forms for us. Now, Snort used to support logging out to different formats like databases and Prelude, SIM, But right now, what we've got is really just this one log file. So we've got var log snort, and we've got snort.log. That's a binary file. So we need something that's going to be able to read that log file for us, that binary formatted log file, and then do something useful with it. As it turns out, we have a program called Barnyard 2, and we are going to just take a quick look at the configuration file here. And this is one of those that you would have to build on your local system. In the case of Ubuntu, there is not a package for it. There's not a package for it. For RedHat, you can't just do an easy, quick package install. You've got to go build it by hand. So I've got a Barnyard installation here, and we're going to just take a quick skim through the configuration file. Most of these are going to be okay. This is a pretty standard installation. It's looking for files that Snort is using for configuration and mapping various pieces of information that Snort uses. So Barnyard needs to know about those. And we're going to skim down to the output section so that we've got a way of doing alerts and output. So the very first thing is the input, and I'm going to breeze by that. As it says, it's not very hard. There's only one. Unified 2 is the only way that you can do that. So one output format here is the common event format. If you happen to have a server that handles common event format, you may want to enable that output here. And there are some examples, as you can see. If you've got a Bro IDS, you can configure that as well. I've also got alert fast, and this is saying alert fast is just going to std out, which is fine. That is going to generate alerts to our standard out, which is going to just go to console. You can also, if you've got this built in, you can go to Prelude, which is a SIM or a hybrid IDS if you want to look at it that way. So we could configure the alert to go to our Prelude SIM and then have that plus our log information and other input sources all in a single location. We can also alert out to syslog. We could use syslog full, and then we're talking about log ASCII and log tcpdump. You can see I've got tcpdump configured here so that we can output into tcpdump format that we could then read in using Wireshark. There are a few others. Squeal right here is a UI that you can use for Snort. And then, of course, we've got database output here as well. You can go to MySQL, Postgres, ODBC, MS-SQL, and Oracle. So you can see we've got a number of output formats. Now what I want to do is run Barnyard. So I'm going to say Barnyard 2. I'm going to hand it my configuration file. And then I'm going to say the directory is varlog snort because that's where our snort alerts and our snort output go to. The file we are looking for is snort.log. And then I am going to hand it another configuration setting here. So we're going to write out to another file. So barnyard2-log.waldo. We've started it up, and it has read the configuration file. It should now be running in continuous mode, which is daemon mode. And we should be able to just take a quick check at the syslog to see what happened here. So I'm going to say tail-n20/var/log/syslog, which is where the application would have dumped some output to. It looks like it read the configuration and then started up. Actually, let me back up a little bit so we get some more here. So now you can see that it started it up and it actually has read some information. It doesn't look like it got anything in, but you can see that it dumped some output out to our syslog file. You can, as I said, use Barnyard to read your binary unified to snort log, and you can use Barnyard to take that and then output to various other places so that you can have alerts and log files and do other things with them. When you're dealing with a lot of information about security events, as you would be when you were looking at the Snort IDS, what you really want is a way to see it easily, just having a bunch of text output isn't going to be really helpful. You really want an interface where you can drill into the information if you need, and also be able to get quick overviews. There are a handful of graphical user interfaces. These are primarily web interfaces that you can interface with Snort. There was one long ago called Acid, and that was replaced by Base. Now there's also OS Sim, Placid, Squeal, Snorby, and Squirt. Now there are others as well. These are kind of the primary ones. There is another one called Prelude, which is a hybrid IDS. It's also called SIM, which is a Security Incident Event Management. I want to show you one of these GUIs so you can actually see it. So we're going to go to demo.snorby.org, which will allow us to take a look at what Snorby actually looks like. So I'm going to log in with their demo password. And this is Snorby. What we're looking at right now is the dashboard. So you can see the number of events that have happened in the last 24 hours. We could take a look at what has happened in the last month, this quarter, and this year. It doesn't look like their demo has actually attached to much of anything at the moment, so we're not seeing any events, but you can certainly take a look at the GUI, and we've got the severities, protocols, signatures, and then we've got sources here. Now, the other thing I want to show you is in my queue, we've got some events here. Let's just take a look at one of these events. So you can see the header information, the signature information that's associated with this. You can query the signature database, and apparently it doesn't know anything about that signature ID at the moment, but there have been an awful lot of activities around this particular signature, and it looks like this is a MySQL event based on the destination port because it's 3306. This is one of the events in the queue, and we can take a look at the events that have shown up here. Again, if we click on this, we can drill down into the information that's associated with it. And again, we've got a signature ID with a category here, and then we've got the source and destination IP addresses. So finally here we've got the number of sensors. It looks like there's only one sensor that's configured to this particular console. You can, of course, have multiple that will report back to the same console. Snorby is just another user interface that you can use with Snort. It is also one of those that doesn't have packages for at least some of the Linux distributions. For example, RedHat and Ubuntu don't actually have packages for Snorby, nor do they have packages for the other user interfaces for Snort. So if you're going to run Snort on Linux, and you want to be able to have consoles and something like Barnyard, then you're kind of on your own in terms of building those, which isn't a huge challenge because there are certainly plenty of pages that will walk through all of the creation and configuration of these additional packages, but it's not something that you're just going to be able to go apt-get install Snorby, for example, because the package just doesn't exist on Ubuntu. It also doesn't exist for Red Hat Enterprise Linux as part of the primary repositories. Now, another advantage of Snort is it has the ability to actually capture packets that are taking place around the time that it is noticed an incident. It will dump captured packets out to disk so that you can then look at them using a packet capture utility. Let's take a look at what we've got here. So if I go into varlog snort, what I've got is the unified log, that's the snort.log, and then you can see I've got a tcpdump.log. So if I take a quick look at that, we can see that we've got these two files here, and I should be able to just open up tcpdump.log in Wireshark. So I'm going to run Wireshark and feed it tcpdump.log. It's going to open up. And now I can just take a look at all of the packets that were captured as part of the different events. Now you'll see this is not a linear sort of progression in terms of the time. what it's doing is it's dumping pieces of the network transactions out to this file as it gets them. So there will be big gaps in the time that we see here because, of course, we're not constantly getting one attack after another. So you'll see these fairly large spaces in time here where we're not getting anything at all, and then suddenly there's a handful of them. It's really easy if you've got it configured, of course, to output to tcpdump. Now you've actually got the network capture data that's associated with a particular event so that you can see, rather than just the alert, you can go look at the packet capture and you can really see what happens. So as an example, it looks like there were a number of SNMP GET requests here on a particular system. So we had an SNMP attack, and then we've got some ICMP destination unreachable, port unreachable messages. So that could be something like a port scan, for example. You can see we've got the actual network data, which, as I said, is far better to look at, giving you much more of an idea of what actually happened than just a simple alert message that you may get if you were just using Snort simply for alerting. There's another program that's a little bit similar to an antivirus, except it's more specific. The program that I'm talking about is RKHunter. RKHunter looks for rootkits within a system. RootKitHunter is actually a program, or a shell script specifically, that looks for evidence on your system that there may be a rootkit. So a rootkit is a piece of software that is intended to hide the existence of either a backdoor or a virus or some other piece of malicious activity. We can just run RootKitHunter. It's very simple. So you can see that I can update, I can do a version check, I can just do a check on it, which is, of course, what I want to do here. I'm going to say RKHunter, so let's just get an update first and make sure that we have the very latest, and it looks like there are a couple of updates here. So now I just want to run a check. This is actually going to just generate a lot of output here, so we're going to be looking for different strings within the binaries on the system. Once it gets through each category, it pauses and waits for you to look at what it found and then click enter once you are done looking. So again, we're going to hit the enter key. Apparently nothing in the way of rootkits was found right here. You can see all of the rootkits that it knows, and every one of them says not found. There was a warning up here where it's looking at unhide, and that's a Ruby script, and it does indicate a warning. So we'll see what it says at the end about the summary of what it found. Now it's looking through rootkits and directories, looking for malware, checking for enabled xinetd services, and it did find a warning there. So there's a couple of warnings that are being indicated here. And we can now look at the log file that was generated. So let's just see the log file. This is a lot of detail about what it's looking for and everything that it found. It's looking for different strings in the various binaries. Let's just see if we can find warning. Of course, it says pattern not found. There was no log entry here indicating that there was a warning, but we can certainly look through here, and actually it says the reason it didn't find the capital warning was because of a case mismatch. So this says the command unhide.rb has been replaced by a script. Okay, that's not a problem. So let's look for another warning now. Same thing there. So now looking for the xinetd services, and it looks like it did find an enabled xinetd service. That's okay. We've got FTP enabled through xinetd, which is what we would expect to have here. And now we've got some other warnings. You can see as we look through the logs, there's a lot of detail there. And we can make a determination from that detail whether it's something that we want to look a little bit more into in more depth. And you can see this case on this system, we took just 1 minute and 1 second to run this. So this is definitely something that you probably want to run on a regular basis. And it's actually something that's generally a good idea to put into your cron jobs so that it will run on a daily or weekly basis. While there are a number of different ways to be able to configure your Linux system to handle user authentication, the heart and soul of doing that authentication on most Linux systems actually resides within just a couple of files. Those two files are stored in the etc directory. Of course, you may remember or may know that the etc directory is where configuration files for the system and for system-level applications commonly lie. So what we're going to do is we're going to take a look at the password file. The password file is just stored in etc, and you'll notice the spelling, it's PASSWD. Now, I'm not going to look at the whole password file. We're just going to look at a few lines of it. You can see that there are a number of sections to each line in the password file. So the very first column, and you can see that we're all delimited by colons here. So we've got one column, colon, another column, colon, and so on. So the first column on this line that we're looking at here is daemon, and that's the username. The next column, there's an X there. That X indicates that the password is not stored in the password file. That actually hasn't been the case for quite a while now. The password file is actually stored in a separate file, and we're going to take a look at that one next. After that is a number. That number is the user ID. Now, that's the numeric value for this particular user. That's the one that the system itself knows about. You are going to know this particular user by the username daemon. The system, however, is going to use the number 1 when it is doing things like permissions. So file permissions have a value of 1 for the user rather than the string of characters that says daemon. The next one over, after the first one, is a second one. That is the primary group identifier. The group identifier in this case is 1. If I were to take a look at the group file, and we'll take a quick look at that shortly, you would see that 1 probably relates to the group named daemon. The next column over is going to be the user ID information. And in this case, it just says daemon. That's because we don't really have to say much of anything about that. After that, we get the home directory. In this case, the home directory for this user is user sbin. It's not a home directory. We don't ever expect this user to be logged in. After that, we get the shell that you would use when you are logging in. Commonly, that's going to be something like /bin/bash or /bin/sh. In this case, it's set to user sbin no login. And the reason for that is we don't actually want this user ever to log in. So now let's take a look at the password file itself. And the password file, in this case, I'm talking about is the shadow file. The shadow file is where the passwords are actually stored. Now, you may have noticed that I was able to read the password file without having administrative privileges. The reason for that is, and actually the reason for the shadow file is, there's a lot of information in the password file that everybody on the system needs to be able to get to. So when I do an ls, for example, it's going to read the numeric user ID and the numeric group ID, and it has to look those up from somewhere. So it's going to look those up from the password file and the group file. So we need to store passwords and sensitive information in a different location so that we can lock it down and only have access from an administrative user. Now here we've got the shadow file, and in this case I don't actually have sections with a password in it, for good reason obviously. Even though the password is not stored in clear text, it's actually stored in a hash format using a secure hash algorithm 1 hash or SHA-1 hash. The place where the password is stored is actually this column here. The exclamation mark here suggests that the root user doesn't actually have a password, would not be able to log directly into this system. You'd have to log in through another root user and then switch over to the root user or use something like sudo, which is what we've been doing. Other than that, though, we've got some similar fields here. The first field is the username, and again, we're using a colon as the delimiter. The next one is the password. This should be a hashed version of the password. The next field after that is the last time your password was changed. Following that is the minimum number of days required between password changes, and then the maximum number of days between password changes. So the maximum number of days a password is actually valid. And then after that is the number of days before the password is going to expire when we start warning the user. After that, and in these cases, we don't actually have values for any of these fields. We have the number of days after a password expires that the account is disabled. And then finally, we have the number of days since the Unix epoch, which is January 1st, 1970, that the account is disabled. So this is an absolute date saying when the login is no longer usable. So now we've got the password file and the shadow file. And finally, we're going to take a quick look at the group file. That's the third file that we will be looking at here. And I need to put in the number of lines. So now we've got the group file. The group file is the name of the group, the password for the group. You can set passwords on groups. We have the group ID, and then after that is the users that actually belong to the group. You can see here that we've got 2 users who are members of the ADM group. So anytime we add users, change users, we're actually manipulating these files, and you can do that directly, but better, you'll use the utilities that are installed with the operating system in order to make changes to your users. Well, now that we know where all of the information about the users is stored, let's go about actually creating some users. So typically we would use the command useradd, and that's going to bring up the help for useradd. Very simply, all you have to do is say useradd and give it a username. I don't want to do that. I want to give it some more specific configuration settings. So first of all, let's create a group. Then I've got a group that I can actually add the user to. And again, we've got a set of parameters that I can pass. In this case, I want to just say group add and just say new group. So now I can go back up to user add, and now I'm going to say -G is going to be new group. That is going to be the primary group for this particular user. And then I want to say -D is going to be home, new user. So -D is the directory or the home directory for the user. So you can see -D is the home directory. And I'm going to specify -M at the end, which is going to create the directory for me. Now, the other thing I want to do is I want to set a shell. The shell is going to be the user interface when you log in an interactive fashion using this terminal window, for example. If I were also to use a secure shell to get in remotely, this is the shell that would run that would give me interactive access to this particular system. So we're going to say /bin/bash, and there are a number of other parameters, of course, that I can use. I'm going to let the system create the user ID or the numeric value for this particular user. And now I'm going to say -M, in other words, create the directory for me for the home for this user. And then my login is just new user. So now you should see that we've got a directory called new user in the home directory. So now I need to set a password. I'm going to use the passwd or password command. If I just run this now, though, it's actually going to change the root password because I'm running it sudo, which means I'm running it as administrator. I could change my own password here by just saying password, and it's going to prompt me to change my own password. In this case, though, I want to say password, new user, and that's going to be setting the password for new user. And now I can just type in a password. It's going to ask me to retype it to make sure that I haven't screwed anything up and typoed and then end up with a password that's unusable. So I have now just created a new user, and I have also set the password on that new user, and I've created a group for the user and set that user to also have that group ID that we created. Now we've created users and we've set passwords. We need to think about how we are going to protect our users by enforcing password policy. The first thing that I want to look at is a file called login.defs. This is the default settings for login. So there are a number of settings in here. The ones we are really interested in looking at, though, are the ones related to passwords. So I'm just going to look for pass here. And here you can see we can set the maximum days that a password can be used, the minimum days that a password has to be used before we allow a password to be changed, and then the warning. These are all set on a per user basis based on these defaults in the shadow file, where we looked at these settings that were on each individual line for the particular user. All of those settings are taken from this login.defs file, which are the defaults for login. So now I want to take a look at how we can make sure that the passwords that our users are using have some complexity to them. So we're going to go into pam.d. PAM is pluggable authentication modules. It is how Linux systems do authentication. The PAM modules determine how users are going to log into the system. So we are in the PAM directory where all the configuration files are. I want to look at the common password file here. I'm going to scroll down. Now, each of these lines that say password are a number of modules that are going to be called here. First of all, we're going to say password, and then basically if there's success, then we're going to allow it. This is using the Unix login here, and it's using SHA-512 as the hash value here. Now, I'm going to add another line, and here we're going to say that this library module is required. That's the requisite line. So the first password that the user logs in, which is try first pass, we're going to allow 3 retries. And here is where we are going to specify the password complexity. The D credit is actually the number of numeric values in a password. So we're requiring 2 numbers, 2 lowercase letters, and finally 2 symbols. Now, of course, you can change all of these to be whatever you would like them to be, but this line is the type of line you would put into either your common password or your system auth file, depending on which one you had. On this particular system, there's no system auth file, so I'm putting this particular line into my common password file. So I can set my password complexity policy here in this file, and we're going to use the cracklib module that will be installed as part of PAM in order to check the password complexity requirements before you can actually set a password. One practice that many system administrators use is to periodically attempt to crack passwords on their system. The reason for that isn't because they want to know their users' passwords. It's to make sure that the passwords that are there can't easily be cracked or determined by either another user or some adversary or attacker who's potentially gotten into the system. So there's a pretty good reason for actually doing this periodic password cracking. Fortunately, there's a utility that we can use that will crack the passwords for us. And it uses a couple of different methods. And we're going to, first of all, need some passwords and the users that are associated with them. We're going to use a utility called unshadow. And that's going to take the user and password information out of this shadow suite that is in place. We're going to dump it into a file that we're just going to call password.txt. I can show you password.txt here. You can just see it's really a combination of the password and shadow files. And if there are users that actually have a password in place, that will show up in this file. Now, all we need to do is very simple. We're just going to say John, which is the name of the password cracker. It's called John the Ripper. We're going to just say John password.txt. There are apparently 2 password hashes in this particular file. So we're going to just say that's going to be okay. So we're going to be doing a number of guesses against the 2 passwords that are in this file. Since I haven't actually done any parameters here, it's going to go through a few iterations on this with a couple of different methods. One thing I could do is if I had a word list, so let's just create a word list, and it doesn't much matter what we put in here. We'll just put some random passwords in. Okay, so now we've created a word list here. So now I could say John word list, and I could specify the word list is going to be word list, which is the name of my word list here. And then I'm going to say password.txt. It ran through the word list and didn't, of course, actually find anything because those passwords didn't match up. I can use a word list, and then we can do an incremental mode in order to try to break the passwords and crack the passwords. Of course, if you get all the way through and you weren't able to crack anything, that means you've got some reasonably strong passwords. Of course, somebody with an extensive word list and a lot of time on their hands may still be able to crack the password. But if you can run John against it and have it run all the way through and not get anything out of it, then you've got a pretty good chance that you've got some strong passwords that are going to be resistant to these sorts of attacks. Now, we've done an awful lot of work using the command line. Of course, it's not the only way to do system administration. With the case of users and groups, we actually have a graphical utility that we can use to configure those. So on an Ubuntu system, if I go to System Administration and then Users and Groups, it will launch this particular interface here. This is very simple, not surprisingly. I can go to add, and this would add my user. It's asking me to authenticate myself so that we can be sure that we're not just allowing anybody who happens to walk up to a console that is logged in and start adding users. I can say my name, and it's going to suggest a username. Of course, I don't have to take that if I don't want to. And then once I've created that, it's going to allow me to set a password by hand, or I could generate a random password, and we can just keep clicking generate if that's what we wanted to do. In this particular case, I am going to create a password here for this particular user. I can go to advanced settings here. It will give me the ability to set the office location, work phone, home phone, user privileges. So I could allow this user to configure printers, share files with the local network. Some of this has to do with the groups that this user would be added into. And then, of course, I can disable the account, set the home directory. So all of the other things that we could do with user add, we can do here as well, just in a graphical format. Of course, I can also manage groups. You can see all of the groups that are here. If I were to select one and bring up properties, it would tell me who is actually in the group. And of course, I can add people if I wanted to do that. That would allow me to add users to these groups. I can select one I could delete if that's what I wanted, or I can certainly add a new group to my list of groups. And then, of course, create group numbers at the same time. Now we've got a new group in our list, and I can close this. Here's another way that you can manage your users if you get tired of doing a lot of typing and you'd rather use the mouse, you can certainly use that system utility. So that would be used if you were using users on your local system rather than using something like LDAP or maybe connecting to an Active Directory server that is somewhere else. Also, NIS and NIS Plus would have different user configuration or user management capabilities. But if you are managing local users using the standard password and shadow files, you can either use the command line for that or you can use this graphical utility. If you go to System Administration and then Users and Groups, you can manage your users and groups in that way as well. Right now, we're going to talk about AppArmor, which is a way of implementing mandatory access controls. Mandatory access controls are a way of setting system-wide policies on files and users and the way that the different components and objects of a system interact with one another. This is different from discretionary access controls where, for example, I as a user could actually set my own permissions. So, for example, I could say drop group access to, let's say, password.txt, for example. So this is an example of discretionary access controls, meaning that I as a user have the discretion to be able to change permissions for the different files in my directory. Any owner of an object could change permissions and settings on that object in a discretionary access control system. This is not the case if you are using something like AppArmor, for example. We've got AppArmor, and we're going to drop into the AppArmor directory, and what you've got here is a set of policies. So let's just take a look at one of them. We're going to take a look at FreshClam. Let me just copy this and we'll just take a quick look at this particular configuration file. What we've got is a set of configurations for what this particular file here, user bin FreshClam, which is an executable, can actually do. We've got capabilities, so this can set group ID and it can also set user ID. There are places where it can get access to the file system. We want to give it access to the proc directory, and of course, we certainly want it to be able to read from its own configuration files. And then there are places where you want it to be able to read and write to the configuration databases in the home directory. This is how we give different capabilities and permissions to some of these programs here. You can also see that we have cases where we want to deny access to this particular binary or executable here. We would use these profiles in order to configure mandatory access control settings on various programs within the system. When AppArmor is installed, it uses a set of kernel modules in order to monitor these sorts of behaviors so that AppArmor can make determinations as to what to allow and what not to allow. If you are running into cases where things aren't working quite right, you may want to look and see what you've got in terms of AppArmor profiles that may be blocking access to specific files or specific areas of the file system. Let's talk about Unix permissions. Now, traditional Unix permissions are a set of 3 where we are talking about the user, group, and world scenario. What that means is we've got our permissions here, so let's just take a look at this. We're going to ignore the first one on the far left. So right here, we've got user is these 3 permissions right here, the very first 3 on the left-hand side. Following that are a set of 3 permissions for group, and then finally world is on the right-hand side of this selection here. The way we do that is we have read, write, and execute for each of them. So for the user, we have read, write, execute, and for group, we have read, write, execute, and world, read, write, execute, and so on. Now, these permissions carry numeric values because that's how they are stored. The read permission would be a 4, write would be a 2, and then execute would be a 1. If I wanted to change permissions, let's say I wanted to give read, write, execute to everybody across the board, I would say use the utility chmod, and then I would say 777, which would be 4 plus 2 plus 1 for all of them. And then we could say server.key is the one that we were looking at. So now if I say ls-la server.key, we should see read, write, execute on all of the different ones here. So sure enough, we've got read, write, execute, read, write, execute, read, write, execute. Now, if I wanted to, say, leave read and write for my user and then have nothing for anybody else, I would say chmod 600 server.key. And now if I look at that again, sure enough, I get read write on my user and then nothing anywhere else. And so I can do 622. So that would be read write for me and write for the others. If I wanted to do read write for me and then read for the others, it would be 644. That's what we've got there. I can do a couple of other things. So I could say group plus write here. So I'm going to give write permissions to the group, and I'm going to say server.key, and now we'll get a listing on it. And we have added write permissions to the group there. So if I want to drop write permissions for the group, I can say g-w, and then I have dropped write permissions. Permissions tell me who can do what. So the user in this particular case, which is me, can read and write the file. Anybody who is part of the group that owns this file, and you can see that in the second column right here, the first column being the user, and the second column in terms of user group being that one right there. So anybody who is part of that group would have write permissions. Anybody who was not either the user or part of the group becomes the world or everybody else, and they're going to have read permissions in this particular case. So Unix permissions are fairly simple. It does take a little bit of work to kind of figure out how you're going to manage these permissions given sort of the limited range that you can provide to people. I can either give you read, write, or execute permission, some combination of those, and you can either be the owner of the file or you can be the group, or I have to give everybody that same set of permissions, which means you may have people in lots of different groups just to give them the right permissions so that they can get to files and make changes to them when they need to do that. Another way of using mandatory access controls or applying mandatory access controls to Linux systems is to use SELinux, which was originally developed by the NSA as an enhancement to the Linux operating system and a way of ensuring that there were mandatory access controls installed. So the first thing I want to do here, I'm on a Red Hat Linux system. SELinux is installed by default on Red Hat Enterprise Linux. So I'm just going to check the status of SELinux. I type SE status, I get SELinux status is enabled. The current mode is enforcing. So we've got SELinux is enabled. I could do set enforce, which would determine whether I were enforcing or permissive. Enforcing means that all of the policies are active, and permissive means that while SELinux is on and enabled, none of the policies are actually being enforced. This would allow you to monitor what was actually happening. If I wanted to go into SELinux here, I could make changes to the configuration. So I could take a look at the config file here. And this would be a change that I would make at the time of boot. So if I were to set to permissive, I would get warnings rather than actually enforcing the policy. Currently, this is set to enforcing. Now, I can have the type set to be targeted minimum or MLS, where MLS is multi-level security. Currently, we are targeted, meaning that there are specific processes that are being protected here. One way that SELinux is implemented is by expanding permissions that Unix uses to have a broader range here. We actually have access controls that are set on the different files. So we would have a user, we would have a role, and then we would have a type. And I can actually see that by doing this right here. If I add a capital Z as a parameter to ls, suddenly you see the SELinux permissions that are set on here. So we've got system U, object R, and SELinux config as the type. We're going to get into taking a look at some additional aspects of SELinux coming up, but this is just kind of a basic understanding of what SELinux is, and then we'll talk about context and using labels on files. Let's talk a little bit about labels on files within the file system using SELinux. Now, in order for SELinux to work, there have to be a set of labels that go beyond what Unix permissions offer. So we've got a few different ways of labeling them. We've got users, roles, and types. Let's just take a look at some permissions here. I'm going to look at my directory here. So you can see I've got a couple of files in here, and they actually have a couple of different sets of contexts here. So I've got system user, in this case I've got unconfined user, but then we've got object role, and then both of them are admin home type. Now, just for comparison's sake, let's take a look at the directory where the HTML pages for the Apache server are stored. So we've got a different set of contexts here. The important one is we've got HTTP sys content as the type. So let's just do something here. I'm going to actually copy var www.html/index.html. Let's say I want to make changes to that in my own directory here and then be able to move it back. So when it comes over, you'll notice it immediately changes to admin home type. Now I can change that. I can say change con, and I can say type equals httpd sys content _t, and then index.html. So I should be able to see that show up here now. And sure enough, we have created httpd _sys _content. The thing that I didn't do there was I didn't actually make that change more or less permanent. The next time this file system is relabeled, what will happen is those contexts will actually be restored. So in order to fix that, I can use semanage fcontext, which is file context -a and -t httpd _sys _content _t, and then index.html. So now that the context has actually been changed, let me actually restore that back. So we're going to change the context back here, and I'm going to say admin home _t is going to be the type that we are going to apply to this particular file. And now, if I move this file back into place, we're going to put it back into var www.html. I'm going to overwrite the file that's there, and now we can say -lz var www. And what we get now is, since I did a move, it actually retained the type that was in place where it was. Now I've got a different type here associated with this file than would normally be there. I would change this context back, or I could just do a restore context, and we'll take a look at restoring contexts coming up. Now, what we did previously was we changed the context of a file in the directory where HTML content is stored. So we've got admin home is the type, and let's actually just copy that var www html index to root's home directory, and I'm going to overwrite the index.html there. Now I want to change the context in the home directory, or in the root directory here, from admin home to be the httpd _sys _content type. So we're going to change context, and I'm going to say type equals httpd _sys sys underscore content underscore t, and then index.html. So we're changing that in our current directory here. So now I have an index.html that is set to httpd underscore sys underscore content type in the root home directory. What I can do if I want to restore that to be the correct context is I can actually restore con, and then I can say index.html here. So now what we've got is restored to the correct context and the correct SELinux context and permission settings on that particular file. So I can also do a restore con on var www.html.index.html. And then if I do ls-lz on that directory, what I will get is the correct context set back. What I can do, if I want to make some of these changes permanent, because these file systems will get relabeled periodically, what I can do is say se-manage fcontext, because I'm going to change the file context, and I'm going to add type httpd underscore sys underscore content underscore type, and then I want that to be on the index.html file here in my current directory. I have just changed the context to be that particular context on this particular file right in my home directory. If I were to have the file system relabeled and anything had happened to this particular context, it would just get changed back for me. Now, I want to take a final look here at PAM. Now, we've taken a little bit of a look before, and I just want to skim back over it again because it's such an important piece of software on a Linux system. So you can see the various configuration files that we have. You can set a configuration on different pieces of software because PAM may be in charge of managing authentication on that software. So for example, we can take a look at FTP, and you can see that we are using common auth, common account, and common session. And in this case, it's using a PAM module, PAM FTP. We've also got another PAM module, PAM list file, and we've got a number of parameters that we are setting to that particular module. So those are standard configuration settings for FTP. Of course, we can also take a look at SSHD, where you may want to have different settings for people who are trying to come in remotely. Again, we're using common auth, and then we are disallowing non-root logins when etc no login exists. If we set the file etc no login, we would disallow non-root login. All of these things are managed by the pluggable authentication modules, and there really are a lot of modules that are available. So if we were to do a search on an Ubuntu system, we could look for libpam, and we should see we've got libpam Unix 2, libpam USB, so we could do authentication with removable USB block devices. Blowfish capable PAM module, and Blowfish is a way of doing encryption. And you can see all of the different modules that we could use with PAM. You can also use PAM to allow you to do authentication using LDAP if you wanted to have an LDAP server, for example. You can also use PAM in order to allow you to authenticate to a Windows Active Directory service. So we would use something like WinBind in addition to a PAM LDAP configuration, and that would allow us to authenticate to a Windows Active Directory server. So if you have a Windows network and you wanted to make sure that you are using the same user database and the same password policies on your Linux system, all you'd have to do would be to use PAM to integrate your authentication on your Linux system with your Windows Active Directory database. But you can definitely see that there are a lot of modules that you can make use of when you are using PAM in order to allow different types of authentication on your system to happen. as well as enforce different policies with your authentication when you are making use of certain services. One utility that you'll probably use on a fairly regular basis is netstat. Netstat is used for network statistics. One of the easiest things to use it for is to check for listening services. Now, of course, I can go scrolling back up here and look at them that way, or since there's so much detail, I can just pipe netstat out to less. So I'm going to use the vertical bar there, which is the pipe character, and I can pipe it out to less, which is our pager, meaning it shows us a page at a time. Now I've got all of my listening services here, all of my ports that are actually open. So this is just the listening ports. So I've got MySQL, I've got domain ports, I've got PostgreSQL, SMTP, and so forth. Now you'll notice that it actually gives me the name of the service. If I wanted to just get the port number, all I would have to do would be to say -n, which is numeric. So now I have the numeric equivalent here. 3306 actually happens to be MySQL, 25 is SMTP, and we've got the domain ports, which is 53 here, and so forth. So now I've got a way to check my listening ports. I can also get all of my listeners here. Actually, let's pop open a different web page here. We'll get one that's going to give me some constantly updated pages here. So let's just say msn.com, and I can actually shrink this down because it doesn't much matter. So now I can say netstat -a, and I'm going to get all of my ports now, not just the ones that are listening, but I'm going to get connected ones as well. And I've kind of run out of my buffer to scroll back. So again, I'm going to pipe this out to less. And now you can see not only do I have a listen state, but I've also got an established state as well. So I have a number of other ones that we've got. These are connections that have been established. So this is a communication stream that's actually happening at the moment. So time wait means that we have started to close this particular session down. It hasn't finished yet. So you can see now we've got a number of others. Obviously, I've got a lot of ports open just from that one web page. I've got a lot of communication ports open to a number of different servers where I'm getting portions of that web page. Probably a lot of these are for images and that sort of thing. Again, I did -a. If I were to say -an, the other thing that I would lose here, actually, let me just do this again and show you. You can see that we've got the actual name of the host there. So we've got the host name. If I do -an here, what I'm going to get is just the IP address. Now I've got the numeric value. So not only do I get the numeric value of the service name, where the service is actually looked up in the etc services file. In this case, if I do n, I'm going to get the numeric value of the IP address, meaning I'm not going to look up the IP address into a host name. If I were to do this without the n, it takes a short period of time to actually look up, because I've actually got to do a reverse lookup on all of those IP addresses. If I do -an, it comes up much faster because I'm not doing that reverse lookup there. So you can see netstat is really helpful, gets you listener ports, gets you any open port connections that are on your system. There are a number of other things that it will do as well, but those are a couple of really key functions that netstat can perform for you. There are a couple of tools that you can use for process management. One of those tools is called Top. Top gives you essentially a real-time list of the processes that are consuming CPU. So you can see here that this list is constantly updating. The one at the very top is the one that's consuming the most CPU at that given moment. And you can see that it refreshes on a regular basis. Now, on top of that, in addition to just the process information, we also get the total amount of memory on the system, the amount that's used, the amount that's free, and then we've got also statistics on the amount of swap. So we've got total, used, and free there as well. So we also get a list of the total number of tasks, and we've got, in this case, at this particular moment, there are 2 that are running and 246 that are sleeping. That will get updated on a consistent basis as well, depending on what else is going on the system. We may eventually see more or less running. Now, at the very top, you'll see the load average. The load average is the number of processes that are in queue for the processor at any given moment in time. So this is 3 snapshots, where the first one is this particular moment in time, and then the other 2 are historical. When I'm done with this, I can just type Q here. Now, the other way of getting process listings here is to say PS. If I just do PS, I've got the processes that I am actually using. Right here, you can see that one of them is PS, because at the moment that we captured the process list, PS was one of the processes that was running. Similarly, if we go back to top, for example, often you will see top as one of the processes running, and sometimes you'll actually see it at the very top of the list, which of course is not what we are doing here at the moment, other than we did just see it pop up for a second there. Top does take process cycles while it's doing this update and giving you this list. So periodically you'll see top, and there's top again, partway down the list there. Because these processes are running, they do show up in the process list. So again, we've got just the list of processes. If I want to get more information than this, first of all, let's just take a look at the manual pages. If you want to see every process on the system here, there's a couple of ways of doing it. There's standard syntax, and then there's BSD syntax. One way of getting every process on the system is PS-E. So this gives us a list of all of the processes that are on the system at this particular moment in time. I can also do PS-EA, PS-EAF, which is going to give us a wider listing and include more detail. So, for example, we've got the owner of the process ID. So this is the owner of the process. This is the process ID. You've got date and time, and then, of course, the actual process there. So another way of doing the same thing is I sometimes do PSAUXWW. I've got kind of a history with both AT&T Unix and BSD Unix, and I have acquired some personal quirks myself on how I run commands. There are different ways of passing parameters to some of these common utilities that differ between the BSD style and what ends up being implemented under Linux commonly. In this case, I just sometimes default to PSAUXWW. Gives me a wide listing. I get all of the processes on the system, and I get all of the detail, including the owner and the process ID, as well as, actually, let's just pipe this out to less here, and you should see the columns that we've got. So we've got %CPU, %memory, and then we've got the terminal that we are running on. We've got the status of the process. S means it's sleeping. R means it's actually running. And I don't see anything that's significantly different from there. You can see that we've got a couple of different ways of getting process lists. You can do top, and it will refresh automatically for you. You can use PS. And if I use PS, there's a couple of things I can do, actually. Pipe it out to grep, and then search for specific processes. So, for example, let's see how many bash processes we've got. These are the bash processes. There's actually 2 of them that are running at the moment. One of them happens to be grep for bash. If I wanted to not include that, what I could do is say grep -v, meaning leave this out, grep -v grep. And now I've just got that one single process. I've got a couple of different ways of getting information about the processes that are currently running on the system at any given moment in time. Once you've got a handle on looking at the list of processes, there's a couple of things that you may want to be able to do with them. One of them is be able to kill them. Now, there's something that's interesting about processes. They sometimes get hung or otherwise in a state where you can't do much of anything with them. So I've actually got Firefox running here. Now, let's say Firefox had just become simply unresponsive and I wasn't able to do much of anything with it. What I can do is I can get my process list here and then I can grep for Firefox. So now I've got the two processes here, one of which is grep, so I can just ignore that, and the other one is Firefox. What I can do is I can say kill 13596, which is my process ID. It's my second column here is the process ID. If I feed the process ID to kill, you ought to see this minimized window down here just disappear. And sure enough, that's exactly what happened. So that's kind of what I expect to happen. If I get something that's really, really stubborn though, and let me just run Firefox again, and then once it comes up, I'll just minimize it out of the way. So now again, I need to get my Firefox process ID. So let's just say it was being really stubborn. I typed kill the process ID, nothing happened. What I can do is say kill -9, which is actually a specific signal that is going to terminate the process. You might even say terminate with prejudice. It would be really, really difficult to send this particular signal to a process and not have it die. Something really bad would have to happen for that to be the case. So let's say 17340. There are a number of other signals that I can send using kill. Because what kill does is it actually just sends a signal to the process. In this case, it's signal number 9, which just terminates the process. So the other signal that you might send is just an interrupt signal. We can actually send other signals as well. Now this is kind of a pain here, and let me just start up Firefox again so that we've got something to play with and minimize it out of the way. So I've got to look up the process ID. Well, that's kind of a pain, and then I got to dig the process ID out, and sure, I can select it and copy and then paste it, but it would just be so much easier if all I had to do would be to say kill Firefox, right? If all I had to do was give it the name of the process, that would be so much better. Well, that doesn't work. What does work, however, is kill all. Kill all Firefox can look it up by the name of the process and then kill it. Similarly, and again, let me just get Firefox running here, I can send the same signals with kill all that I can with kill. Kill all -9 terminates the process. Now I've got a way to not only kill a process by process ID, certainly there are ways you can craft a number of statements together in order to cut that second column out and get the process ID for Firefox. So much easier to just give it the name Firefox and say kill all Firefox. When you do that though, if there were a number of processes running with the name Firefox, and let's just start up a few of these here. Now, if I were to, let's just look up the process IDs here. In this case, there's actually just one process ID. Some processes actually may spawn several processes. This looks like it's forked out a few from a single process, but I could still do the same thing. If I kill all Firefox, all of those windows go away. Even if I've got multiple process IDs, if I give it the name, I'm going to kill every single process with that particular name. One thing that you may want to be able to do as you are working on securing your Linux installations is be able to figure out what ports are open on remote systems. This is something called port scanning, and the best tool that is widely used for this particular activity is actually something called Nmap. We're just going to do a couple of fairly basic ones, and I'll walk you through the settings here. So first of all, I need to have administrative privileges, and then I'm going to run Nmap. What I'm going to do here is a SYN scan. This is sometimes called a half open scan because I'm going to send a TCP SYN message. I'll get a SYN ACK back, and then I'm just going to send a reset back. I'm not going to actually fully open the connection. I'm just going to send a SYN and then see what I get back for a response. Now, I can do -v for verbose. And let me just say 172.30.42.1 here. And this is going to tell me what it's doing as it goes. That's the -v. If I were to do it without -v, it would just give me the results, which would be this right here when it was actually done. So the other thing I can do, and I'm going to drop the -V at this point, is I can crank the throttle up. If I go T5, it's going to go as fast as it possibly can, and then we should just get really quick results back as a general rule. What we're doing here is we're testing about 1,000 ports. That 1,000 ports are really the commonly used ports. If I wanted to test a specific port, for example, I could do -P80. You can see that's up. If I wanted to test a couple of ports, I could say 443 and then 1089 and 8080, for example. So I'm only going to check those ports. The other thing I can do is actually scan all ports, and I can say -P0 through 65535, which is every single port, or the quicker way of doing that is just -P- or -P-. That's going to scan every single port. Now, the other thing that I can do while I'm doing my SYN scan is I can do an operating system scan and actually try to figure out what operating system is running on the remote end. So this is going to do my port scan for me, and then it's going to do some checks as it goes to see what kind of responses it gets, and then it will check a fingerprint database that it actually has and be able to determine what the operating system on the remote end actually is. This actually is pretty accurate. It says it's a Motorola surfboard, and that's what it is. This is my router on my local network, or my cable modem / access point / router. That's actually pretty accurate. The fingerprints on Nmap are pretty good. As a general rule, they will hit most of your systems pretty well here. So what I did was just a single IP address. I could scan the entire network. So I could do a /24. That's my entire network here that I've got. And that's going to scan all of my hosts to figure out which ones are up. And the ones that are up, it will actually do a port scan. Again, I didn't feed it the -P, so it's just going to do that roughly 1,000 well-known ports. This could actually take a while. I'm going to kill this, and we're going to hop over to a different kind of scan here. And I'm going to go back to my .1. Let me get rid of the OS scan. Let's do a UDP scan. So -SU is UDP. That's also going to hit about 1,000 ports, and those are well-known ports. Now, UDP is different than TCP. With TCP, I do a handshake. So there's a well-defined pattern that we go through when we are making a connection to a system. With UDP, that's just not the case. On a closed port, I am going to get an ICMP port unreachable message. On an open port, I don't know what I'm going to get. It will depend on the application that's running. I may get no response. On the other hand, if the request message from Nmap has been dropped, I may similarly get no response. If for whatever reason the network just loses it, or there's a firewall in the way, it may just get lost, which would mean no response. If there's no response, I got to retransmit because I can't guarantee what that actually means. UDP scans often take quite a bit longer than TCP scans, again, depending on what's in the way. If obviously we're getting just a lot of closed ports, we're going to get these ICMP port unreachable messages back, and it's going to go pretty quickly. If I've got a lot of open ports, not getting a response back, as I said, isn't really meaningful. So we got to keep sending messages. So that constant retransmit can actually be time consuming. So Nmap is a great port scanner. You can use it for TCP, UDP. There are a number of different types of scans. These are probably the two most common. It's a SYN scan and a UDP scan. As I said, you can do an IP address, you can do an entire network range and figure out what's on your network. We're going to take a look at a new class of security utilities called vulnerability assessment tools. We're going to first start with OpenVAS. I'm running this on Kali Linux, and Kali Linux actually has OpenVAS installed by default. You can see that if we go to the menu Kali Linux Vulnerability Analysis, there's a menu for OpenVAS. It actually has multiple components to it. You need to get all of the components installed and then make sure that they are started up in the proper order. When you get OpenVAS, you would need to do an initial setup, and then if you're ever unsure whether things are correct or not, you can run OpenVAS check setup. I've got OpenVAS started here, so I don't have to start anything. I am going to go to the web interface, though. So I'm going to go to HTTPS, and then we're going to go to port 9392, and admin is going to be my username. And now I have logged in here. So there's a couple of things. I can just do a very quick start here by plugging in an IP address. I can also go to the menus up top here, and I can check on my port lists. I can check on my scan configs, and I can do scans based on different scan configurations. In this case, what I'm going to do, though, is I'm just going to go back to this page here, and I'm just going to do a very quick scan here. So I'm going to do a system on my local host, and we're going to do an immediate scan. It has been requested at this point, and this is part of where I say it's a multi-component system. It's actually multi-tier. So I've got my user interface that has sent a request to a different component to launch the scan against my local system here. Now, there are a couple of different ways of doing this vulnerability analysis. Of course, we're going to do a network scan. We're going to check for the open ports that are on the system, and we're also going to check for things like banners on the applications behind those open ports and see whether the version numbers that may come back in those banners map to any known vulnerability. It's important to note that vulnerability scan tools do not exploit vulnerabilities. They use static information like, for instance, open ports or version numbers in banners against a database of information that they have where they know about specific vulnerabilities. They are going to poke and prod at the system. They are not going to exploit anything. That's not to say that you don't run the risk of potentially knocking a system over or causing issues with a vulnerability scanner. You just never know when you may run against a fragile service or a fragile system, and you may inadvertently knock it over by running a vulnerability scanner. So we've got our names here of the scans that we're running. I can click on this, and it's going to bring me to a task details page. Currently, we are 94% complete. I could click on reports here, and that's going to bring me to a list of the reports that I've got. And we're going to just click on this current report here, and then we'll get a list of what we've got. Here's a vulnerability. I can click on this and get details. I've got a solution here. It actually tells me how to go about fixing the vulnerability, and it actually gives me some detection results. So this is how they happen to know this particular vulnerability exists. When they sent the verify message to the mail server, they actually got a response that wasn't an error response indicating that that particular message wasn't supported. So we've got this vulnerability scanner. Now we've got a number of potential vulnerabilities that it has found. Now, just because it flags a vulnerability here doesn't necessarily mean that that vulnerability exists. As I said, in some cases, it's making educated guesses as to whether a vulnerability is there based on information that it has received, which is why the results here are so important. In this case, it actually checked it. We got a result from the vulnerability scanner actually checking to see whether this works. Now, this isn't an exploit itself. It's just seeing whether this particular request is available. And you can see why this particular request is a potential vulnerability, because it allows you to possibly enumerate users on the system. We've got this vulnerability scan utility here, OpenVAS. This is free and open source, and you can certainly download it and install it on most any Linux distribution. You can also put it on Windows systems. As I said, if you've got Kali Linux, it comes automatically installed. All you need to do is just finish the configuration and get it started up, and then you can start your scanning. Another vulnerability scanner that I want to take a look at is actually a community-based version of a commercial offering. So the company Rapid7 has this vulnerability scan offering called Nexpose, and there is a community-based version of it. And we've got the community-based version of it here. The difference, or one of the differences with the community-based version, is that with the community-based version, you can only scan up to 32 hosts. You could certainly scan more than that, but you have to dump your database and remove all evidence of those 32 that you had previously scanned before adding more. Nexpose is a really good vulnerability scanner. And what we're going to do here is start off a scan. So we're going to go to sites first of all, and I'm going to add a site. And I'm just going to say new scan site. Not particularly exciting, perhaps. And if I wanted to, I could give organization name, the URL, primary contact, job title, etc. Has nothing to do with the scan. It's more about the administrative stuff that you need to keep track of if you are doing penetration testing. Now, I don't need to do anything with access. I don't have any other users on this system. It's just me and my admin user, so I don't need to provide access there. I do, though, need to provide at least one asset, which is a system I'm going to scan. So I'm going to scan a system on my local host. I could, of course, add multiple addresses or host names or a range of addresses if I wanted to. And you can see that I've got the ability to exclude as well. I'm not going to exclude anything because I'm just going to scan one thing here. I could, though, provide credentials. If I wanted to, I could say local creds, for example, and then my account, I'm going to say this is an SSH account, and then we'll just say my username here, and then I have to plug in a password. This is going to give me the ability to have the vulnerability scanner log on, and then once it's logged on, it can run local checks, which it wouldn't be able to do unless I gave it local access. So now we've got the templates that are available. I'm going to do a full audit here rather than a full audit without WebSpider. That means this is going to go check web pages as well. You can see there are a number of templates. There are some that are compliance related, Sarbanes-Oxley and HIPAA as an example. We've also got PCI. So we can do any one of these, and there are specific features that are turned on and off based on which template that you use. So we're going to choose that template. The engines, I'm not going to worry about. It's only a local engine. I could use the Rapid7 hosted scan engine, but it wouldn't be able to get to my local network. And I don't have any other scan engines that I need or could use, so we're just going to use the local one, which means the one that's on this system. So I'm not going to worry about alerts or schedules. I just want to run it now. I'm just going to say save and scan. We are doing the asset discovery. You can see that it's a fairly well laid out web interface here. If I want to go to reports, I can create my report here and just say new report. That's fine. The template that they are using here is fine. I do need to select a scan though, and we'll just pick this one just to do one. And then we're going to say, yes, that's okay. That's the scan that we want. We're going to generate a PDF file. And so we're going to save and run the report. Now it has created a new report for us, and we can open that up. And this is the report that you would get. You can see this is actually a stopped scan, so it's not going to be complete necessarily, but we do have some ports that are open. Apparently it found the NTP service and DNS, and then it didn't find any databases or users, no file names, because of course it didn't log in locally. So this would be what a report, or a partial report anyway, would look like. When it found a vulnerability, it would actually give you details about it, and I can go to the vulnerabilities tab and click on this, for example, and this is going to give me more specifics about it. No exploits, there are no malware kits. It does say solution. There are a couple of solutions for this particular vulnerability. If I go back to my vulnerabilities page, and then of course, as I said, the list of vulnerabilities. Now, one feature that this has, because Rapid7 also happens to own Metasploit, is it gives you an indication as to whether a particular vulnerability is exploitable using Metasploit or not. So it looks like this has an exploit that has been published, and this one happens to be from the exploit database. So it gives you more detail as to whether these vulnerabilities can be exploited or not, and where you may be able to locate exploits. So Nexpose is just another vulnerability scanner. There are certainly plenty of vulnerability scanners. This one does happen to work on Linux, not all of them do. And it's a pretty nice, pretty complete web interface. It's the community version of the commercial product that Rapid7 offers. One thing that's really frustrating sometimes is knowing that there's a file somewhere on the file system and you just can't remember where it is. There's actually a utility that you can use, not surprisingly, it's called Find, where you can locate files. You can locate them by name, you can locate them by type. There are a lot of different parameters that you can pass into Find. Let's just take a look here, and I'm going to say find-name pass.mysql, and I'm just going to run that. It says there that we located it, and that's where it was found. So /pass.mysql. Now, this just sort of assumes that I'm going to start in my local directory. I can say start from root. And of course, I'm getting a lot of permission denied because we're looking at files and directories that are only available to the root user. I didn't run it as root. There are a number of other things I can do. If I were to say something a little bit different here, where if I put it in quotes, I can feed regex to it. So if I say pass asterisk, I should get 2 files back. And I'm going to change this. I'm just going to put the dot in here just to be very explicit about where I'm looking. And sure enough, I get pass.mysql and passwords.txt because that matches this pattern right here. So if I put it in quotes, I can actually pattern match as well. So one other thing that I can do is, let's just try this. I'm going to say -not, and what I should get is everything that doesn't match that. And sure enough, that's exactly what I get. I get all of the files that are under this directory, and it is recursive, so it looks through all of the directories for me. I get everything that isn't that. So that was the -not, and then I provide a name here. So there are ways that we can search for files and directories by type. So I can say find-type, and let's just look for all of the directories. I've got a number of directories here. And actually, let's pipe it out to less so that we can see all of them. And these are all, again, in my local directory here. And again, we're going very recursively. Let's say we wanted to do everything that wasn't a directory then. Now I'm getting all of the files. And of course, there are directory paths here, but what we're looking at specifically is a file. So I can also look for symbolic links. If I do type L, and again, let's explicitly say we're looking in dot, I am getting symbolic links. This right here is the one I created specifically for this. This is a symbolic link. The others, they happen to be there as symbolic links. I wasn't really expecting those. I wanted to make sure I had one, so I created it. Those others also happen to be symbolic links. So I can look for regular files, which would be F. I can look for directories, which is D, symbolic links, which is L. So I can do a couple of different things here. So I can say type -L, and then name is, let's say, *pass**. So now I only get this one. So I can actually chain a couple of these things together. I can say I'm looking for a specific type as well as a name that matches a specific pattern. Find is a really helpful utility where you can locate files, directories on your Linux file system. You can do it very quickly and very easily, and you can really narrow your search down. Now, I'm going to grant you up front that it's quite a bit easier to do packet capturing using a graphical interface so you can really see what's going on. However, there are instances where the only thing you're going to have is a console interface. And so being able to capture packets and maybe write them out to a file so you can analyze them somewhere else is really important to have. So what am I talking about with packet capturing? Well, networks transmit packets. And these packets can be acquired at really any stage along the path of the network transmission. And the utility that we use in order to capture packets is tcpdump. Now, tcpdump is a command line utility. As I said, there are cases where you're only going to have a console interface. There are certainly cases where you may be trying to do this on a server where you just don't have a graphical interface. So you really need to be able to capture these packets using this command line utility tcpdump. So certainly I can do tcpdump and I can just let it run now. So what you're seeing is the header information from the packets that are coming by. I'm not actually capturing anything here. All I'm doing is getting a display of the header information. In some cases, that's enough. I want to see whether specific hosts are communicating or not. Let's just say, because this is one of them that's coming up, let's just say we're going to pick this one. I can filter based on a host name. So now I'm only getting packets that are actually either to or from that particular host. That's good. I can use a host. Of course, I can use an IP address there just as easily as I can use a host name, but being able to filter is really good. The other thing that I can do is if I had multiple interfaces, I can say ETH0, which is my primary interface, and I can capture on that interface as well. Now, you'll notice as I'm starting these up, it's saying you can use -v to get more information than we did. And sure enough, that's breaking out a little bit more information than we had. And I can also do -vv and get even a little bit more information than that. But again, we're still only doing just the header information here. What if I actually want to save this to a file so that I can maybe look at it later in a graphical utility where I can really do a lot of searching and popping things out so that I can really see the information better. So I can say tcp.pcap, for example, here. Now I'm writing all of this information out to a file. The thing about this, though, is I need to make sure that what I'm doing is getting the entire packet. So I'm going to set the snap length to 0, which really says as much data as each packet holds, just write it out. I could specify a size, but if I say 0, it's really effectively infinity, which is capped at the maximum transmission unit. And in this particular case, we're talking about Ethernet, which would be 1500 bytes. Now I'm not getting the output here because it's being written out to a file. Once I'm done, Control C, you can see I captured 2,554 packets. And if I were to say tcp.pcap, you can see that it's got some size to it. It looks like it's about 2 meg, give or take there. tcpdump, as I said, really useful utility. Command line, if you've got a server where you don't have a graphical interface, or if you've only got a console, or if you just want to let this run maybe without cluttering up a screen with a graphical interface, you can just kind of let it sit and run. You can write it out to a file. You can do filtering on port, on host, on protocol, lots of different filters you can use. But tcpdump is definitely a utility you should have in your toolbox. Now that we've taken a look at the command line version of a packet capture utility, let's look at the graphical version of it, and that's Wireshark. So it's given me an error because I'm running as root. I actually have to run as root because if I'm going to capture packets, I need administrative access, but it's going to complain at me because there are some potential risks in doing this. If there's a vulnerability in your packet capture utility, at Wireshark specifically here, you run the risk of putting your system in a place where it could be compromised. Here we've got Wireshark. We've got a number of panes here, and let's just start off with the capture pane. We're going to look at the interface list. There's only one interface on this system. If I click the checkbox here and click Start, I will immediately do a packet capture on that particular interface. I can also select any one of these and then just click Start here, same sort of thing. Immediately, I am getting my list of packets. So you can see all of the packets. Now, the nice thing about Wireshark, what I've got here is a very nice organization. I've got the frame number. I've got the time that it came in on the source and destination IP address. I've got the protocol. I've got the length of the frame. And then I've got some basic information about the frame. This may be all that you need. So you can see that we've got the port information here. It originated on port 50,236 and is going to the rsync port. And this happens to be an ACK message, and I've got the ACK number and the sequence number as well as the window size here. I may actually want more information than that, though. So if I go down to this lower frame here, I've got my frame information. And then I've got my Ethernet 2 information, which is the source and destination MAC address. And it tells me that this is actually an IP packet. And so I can look at the IP header. If I open that up, I've got the version, I've got all of the IP header information, and then finally, I've got the TCP header, and then any data that's associated would be at the very bottom. Now, you'll notice at the bottom, what we've got is the raw hexadecimal dump of everything. And if I were to select some header field up here, it would immediately highlight the actual hexadecimal value down at the bottom. In this case, the 4 is actually the version, and then the 5 is actually the header length. So you'll see if I select both of these, it's pointing to the same byte value. As I start clicking through here, you'll see the selection starting to change. This total length is 2 bytes. It's these 2 bytes down here. I've got the ability to do filters. I can do ip.addr equals, let's say 172.30.42.13, for instance. I hit enter. It filters based on that IP address. All I'm seeing now is something to or from that IP address. So I can now clear that filter out. I could say, for example, IP, and that's only going to show me IP packets. I can say UDP. That should only show me UDP messages. So you'll see now I've just got UDP messages here. I can do a number of filters, and you can do filter builders. You could use expression here. It'll give you field names. You can start selecting the field names and the relation and then give values. So you can build your own filters there as well. So when I'm done capturing, I just click the stop there. Now I could save it, or I could just close it, which is what I'm going to do. And the reason I'm going to do that is because I want to go to open. And I want to open the one that we had done previously. So I need to go to the home directory here and find my home so that I can find the PCAP that we had stored here. So this is the PCAP that we had created using tcpdump. You'll see it can be easily opened here in Wireshark because it's all just packet capture stuff. We've got a packet capture that we had created here, and now we've got, looks like there was a filter that was being applied. So this is the entire packet capture. We've got our list of all of our frames that looks exactly the same as the one that we were doing live here. And we can look at information in exactly the same way. You'll see there were 2,476 packets. That a displayed value is the same. If I were to do a filter, it would show you the number of packets that were displayed as a result of the filter. tcpdump is great for storing on disk if you've got a console. Wireshark is fabulous if you want to actually do some analysis, and you can do captures with it as well, but really being able to look into each of the frames here and start digging into the information to see what's really going on as you are sending information across the wire. Very, very powerful. A couple of other utilities to take a look at here are maybe ones that you don't see used very often. Maybe you're not familiar at all with them, but they are really helpful in seeing actually what's on your system. And by that, I mean, let's take a look at one of them here. If I say LSPCI, it shows me all of the devices that are connected to the PCI bus. So you can see the host bridge, the PCI bridge, If I had a number of devices that were attached here, you would see all of them. In this case, we're looking at the USB controller. We've got a VGA compatible controller, so you also get details about all of the hardware here. This VGA compatible controller is a Parallels accelerated virtual video adapter. That's because I happen to be running this inside of a Parallels virtual machine. You can see that the SATA controller is an Intel Corporation SATA controller. Looks like it's 6 ports here, and we've got USB controllers as well. You can see all of the hardware that's associated with the PCI bus. Similarly, I can say ls USB, and I'm going to get a list of all of the devices that are associated with the USB bus here. And in this particular case, I don't have anything installed that's attached to this particular machine. But if I actually had something associated with the USB, then I would get that showing up here. You can see a couple of these utilities here, LSPCI and LSUSB, can be really helpful in doing system-level troubleshooting and that sort of thing. If I plug in a USB device, then rather than just the root hubs that you can see, I should get a whole nother device. Sure enough, I get my SanDisk Cruiser. That comes from just doing a plug-in here on the fly, and all of a sudden, I get this new USB device. So I can see all of the USB devices that have shown up on my system here. In this case, it's really just one plus the root hubs that are associated with just the USB controller itself. And if I were to do LSPCI, as mentioned earlier, we get a list of all of the devices that are associated with your PCI bus as well. These are a couple of good utilities to see what you've got for hardware that's actually attached to your system. Well, let's talk about the Linux kernel. The kernel is actually one of the most important components when we're talking about security. It offers a lot of features. It also offers potential ways into the operating system. Actually, the kernel is the operating system, so it's probably more accurate to say that vulnerabilities in the kernel or a poorly configured kernel could allow an attacker to get into your system. So get access to your files, be able to corrupt services, do all sorts of really bad things. So it's helpful to talk about the kernel. A couple of things here. First of all, let's take a look at var log, and we can take a look at the kernel log, for example. Now, in this case, what we've got is a whole bunch of firewall messages. This is actually a set of messages that are generated by the kernel because the firewall is inside the kernel. So we can also take a look at some of the older log files and see some actual kernel messages. So let's take a look at this one right here and go back past all of the firewall logs. Now, this is the type of message that the kernel spits out when it's actually booting up. So the kernel is the software component that interfaces with the hardware and the user space. It's that layer that sits in between those two. So when your system is booting up, it's actually the kernel that's loading into memory and getting all of the device drivers working and all of that. So what we're looking at here is output from the kernel. So we can see the different pieces of hardware that the kernel actually found as it was loading and getting everything functional. Another thing that I want to take a look at here is the number of packages that are available, and this happens to be an Ubuntu system. So I'm going to search for Linux-image. I'm going to pipe this out to less as well because there's going to be a bunch of them. So you can see we've got a lot of different possibilities when it comes to getting a Linux kernel installed here. All of these packages that say Linux image are a binary version of the kernel. So we've got a number of different versions here. So you can see 3.13 is one of them. There's a 3.4 there as well. And then there's a lot of patched versions that are based on 3.13. So you can see 32, 33, 34. These are specifically patched versions that are based on the 3.13 version of the Linux kernel. You can see all of the Linux kernels we've got. I could install any one of those, and then I could boot to that specific kernel. Now, in addition to all of these binary images of the kernel, there is also a source package, and I should be able to search for that by just looking for Linux-source. So you can see Linux-source, and that's just kind of a generic package. In this particular case, it should point to Linux-source-3.13.0. And once you've got the source, of course, you can build your own specific kernel, and we'll take a look at that a little bit later on. But Ubuntu and any of the other Linux distributions have a number of binary images, meaning they're pre-built kernels, so it's not just the source, and you don't have to go build it and configure it and all of that stuff. What you're working with is a kernel that has been pre-built for you with all of the features that the maintainer, in this case Canonical, believes you would need in order to have a functioning Linux system. So we're going to take a few lessons here, and we're going to dig into the kernel a little bit and see what it's made of and how to actually build your own kernel and do some other cool things in order to help you get to a place where you can have a machine that's more hardened than what you would get with just a pre-built kernel that one of these Linux distributions provides you with. There are actually a couple of types of Linux kernel, and this is a way of categorizing them that we haven't talked about so far, in spite of that long list of kernel images that we looked at previously. The couple of different ways of looking at the Linux kernel are we might have a monolithic kernel, or we might have a modular kernel. With a monolithic kernel, what you have is one large kernel image. And so what you've got here is a kernel image. Now, I'm not saying that this is a monolithic kernel. In fact, it's actually not. But when I say the kernel image, I'm talking about this file right here. This is actually the kernel itself that gets loaded into memory. This one happens to be a compressed image. I can tell that by the Z that's right there. That's a zipped image, meaning that it's compressed. It actually has to be expanded before it can be loaded into memory. So this is not actually a monolithic kernel, meaning that all of the features and the drivers are not built directly into this one single file. Instead, what we've got is a number of modules that can be loaded up as necessary in memory. And I can take a look at the modules that have been loaded by running lsmod. And you can see these are all of the modules that have been loaded into the kernel space as either features or as drivers for specific pieces of hardware that may actually be in place on this particular system. I've got kernel modules that can be loaded up. And as I said, they may take the form of a particular feature. They may actually be a device driver. And we can take a look at the modules in lib modules. And then we've got a couple of choices here based on the specific kernel that we are looking for. Let's just hop into one of these. So I'm going to jump into 3.16.0-34-generic. So here are all of the modules that may be in place here. So I'm going to hop into the kernel directory, and you can see these are the categories. So I've got crypto, drivers, file system, kernel, lib, and then we've got sound and network drivers. These are all the different categories that the kernel modules would actually reside in. Let's just take a look into one of these. And then you can see under this, we've actually got directories. Now, here's actually one of the kernel modules. So KO is kernel object, and this is the high performance file system. So HFS. Now, that's a kernel module. If I wanted to actually load that one, What I would do would be to say insmod, and then I could give it the full path here. I'm going to copy this part, and then I will add in the actual kernel object. So what may end up happening is this may refuse to load because there may not be a need for it, but we can check to see whether it loaded by typing lsmod. And we didn't actually get an error that was associated with it, but I also don't see it listed. So it did get loaded. But as I said earlier, if there's a particular driver that I want to load up, but there's no hardware that's associated with it, it may not load into the kernel space because there's nothing for it to do. In the case of HFS, the kernel loader has no idea what I have in mind when I'm loading it. There's certainly no hardware that's directly associated with it, so we can load that up. You can do insmod to insert modules, and then you can rmmod to drop them out. We've got lsmod, insmod, rmmod. These are all different ways of handling the kernel modules that you may have installed on your system. And we'll talk later on about how to build kernel modules for your kernel. Now, it's possible this goes without saying, although I'm going to say it anyway, just to make a particular point. The kernel is actually a piece of software. Now, it's a pretty complex piece of software, and what it does is really important, but at the end of the day, it's really just a piece of software. So we've got this software, and like most pieces of software, it has variables inside of it that get changed, altered, set, all of those things. One of the nice things here is that we can go look at some of these variables or parameters, if you want to think of them that way, and we can pull them out of the running kernel. So I can say, for example, sysctl net.ipv4.ip_forward, and this tells me whether this particular system is set up to forward packets from one interface to another interface if there happen to be multiple interfaces on this system. Right now, we've got this particular system set to IP forward. If I wanted to change that, I would again run sysctl. In this case, I'm going to say -w for write, and then net.ipv4.ip forward equals 0. Now we have set that to 0. So that's a change that's made on the fly. What if I actually want this to be persistent? Well, what I need to do then is I need to edit this sysctl.conf file, and that is where we can set these parameters. What I'm doing here is I am making changes in a file that gets read when the system is booted up so that all of these parameters get set when the system boots. So for example, I could say net.ipv4.ip_forward equals 1. The default is 0, but if I wanted to change that so that it did allow forwarding every time the system loaded up, I could uncomment this particular line. So there are a lot of different settings in the sysctl.conf file. We could spend a pretty fair amount of time going through and what they all mean. But if you want to go look at the different parameters that you can set within the kernel, you can certainly take a look at sysctl.conf. Now, if I want to look at these on the file system, where would I go for that? Well, that's actually fairly easy. So I'm going to go to a sudo file system. I'm going to go into proc and then sys, and then we're going to say net. And now here I can jump into IPv4. And now here are the various parameters. So all I have to do at this point is say cat IP forward, and this says 0. Now, if I were to go back and do my sysctl.conf thing again, and then if I were to say net.ipv4 IP_forward equals 1, now if I cat that file, now it actually says 1. So if you go into the proc file system under the sys directory, you will find what appear to be files indicating the settings for these various kernel parameters. So you can use sysctl, the utility, to change things on the fly. You can go into the proc file system, pseudo file system. You can actually make changes there. I could echo a value into that file or what appears to be a file, and it would have changed. But of course, if I want these parameters to remain persistent across reboots, I have to go into sysctl.conf. Those are a number of different ways you can look at and manipulate the various kernel parameters that will adjust the way that the kernel behaves. We're going to talk a little bit about how you would build and configure kernels, or maybe more accurately, configure and build kernels, since before you build it, you've got to configure it. Before we get to the point where we're actually building it, there's a few things that I want to take a look at here. So the first thing is, let's see how we would figure out what kernel we are running at this particular moment in time. If I run uname-a, it gives me a lot of information about the specific system that I'm on, the kernel that is in place, and then the build time for that particular kernel. We've got kernel build version 3.16.0-38-generic, and then the kernel build time is right here. So you can also see that it's a 64-bit kernel because it's x86_64. That's really kind of the information that we need right here. We've got a 64-bit kernel that is 3.16 with some patches that have been applied, so we get to -38. Now, the other thing that I want to do is go into the boot directory, and you can see there are a number of files here. If you look closely, you will see that there are 4 different numbers for each of these files here. That suggests that there are actually 4 different kernels that have been installed on this system. So the first thing that I want to take a look at here is the config file. Now, we're going to take a look at configs in more detail later on. So I just want to mention that the kernel configuration is stored right here. The other thing I want to do is talk about the initial RAM disk, or initrd. This is a set of data that has to be there when the kernel boots up. Primarily, this is a set of modules. We had talked previously about modular versus monolithic kernels. If you don't use a monolithic kernel and you use a slimmer, more scaled down modular kernel, if you are trying to gain access to a piece of hardware that is not built directly into the kernel image itself, that module has to be available. Let's say that you have built that driver as a module rather than in the kernel itself. That module has to be available when the kernel loads. Without that SATA driver, you are not going to be able to get to the hard drive in order to load up anything else. So that module has to be there. The way we handle that is we put it into an initial RAM disk that gets loaded into memory and expands into what appears to be a drive to the Linux kernel, where it can load the modules that it needs in order to finish booting the operating system. Now, the system map here is actually a list of memory addresses that are important to the kernel. This is the list of addresses where important information relative to the kernel actually is. If you wanted to do a memory dump and you had a program that did memory dump and analysis, it would need this map file in order to figure out where all of the important operating system data structures actually are. VM-Linux finally here. This VM-Linux, this is a compressed kernel. I know that because it's a Z rather than an X at the end there. That suggests it's zipped or compressed. The reason it is compressed is a historical thing. It has to do with the fact that at some point we got to where the kernel image was larger than the memory space that is initially available when your system starts up. Compress the kernel, get it to a small size. When it loads into memory and first starts executing, the very first thing that it does is it extracts itself. So it uncompresses before really loading the main kernel. So we've got 4 of them here, and these are all installed. I couldn't boot to any one of them. The next thing I want to do is go into user source. And you'll see inside here are different source directories. So I've got Linux headers. If I were to build a module for my kernel, I would actually have to have these headers. And then finally, we've got Linux source. So I'm going to go into Linux source. If I wanted to install the Linux source, I could do that just using something like apt-get on an Ubuntu system, install linux-source, and that would install the Linux source for me. It would put it into this directory structure for me. So now I've got a tarball here and a couple of directories. What I want to do is untar that Linux source tarball here, meaning I need to say tar, and I also need to be admin. I'm going to untar the Linux source. It's going to extract all of the source code into a directory structure here. Once we have that in place, we can go configure our kernel and build it, and we will take a look at that coming up. So far, we've talked about where the kernel actually lives once it's been built and where it is when it boots up. We've talked about how to get the version number from the running kernel. Now let's actually talk about creating a kernel of our own based on our own configuration. So the thing that you need in place in order to do that is a set of build tools. So you would need a C compiler, you need make, you need a number of other components. You basically need a whole build system on here because, of course, we're building from source. So the first thing is I've untarred my source tree here, and I'm going to go into the directory, and now I can make menu config. So now we've got the menu, and we can go through all of the configuration features. So first of all, you want to do a 64-bit kernel, or do you want to do a 32-bit kernel? If I uncheck this by just hitting the space bar here, I would be building a 32-bit kernel. So there are a lot of features in here, and I'm certainly not going to go through all of them, but you would walk through all of these and determine whether you wanted to build them as a module, as you can see here, which would be M, and I can just toggle through these by hitting the space bar. So M is module, the asterisk is build it into the kernel, and if I were just to hit the space bar and get a blank there, that means don't build it at all. So I can use the tab or arrow keys to move around, and every time I hit exit, I pop back up. Once I'm done and I hit exit, it's going to ask me if I want to save my new configuration. And of course I do. Once I have saved it, what I get is a file that is a .config file. And that .config file is just a text file and indicates whether we're going to build features, whether we're not going to build features. Once we have the config file, of course, we can just run make. And that's actually going to go build the entire kernel for us, as well as building the various modules. Once we have gone through that, we can do an installation. And then, of course, you would need to change your GRUB entries or whatever else you needed to do in order to make sure that you were booting to the kernel that you just built. This actually can take some period of time, but that's the process that you would go through in order to create a configuration file that is the .config file. And then once that config file is in place, you can actually build the kernel that you want, and then you can go about installing it and making use of it. Now, let's say you want to actually get the configuration from one particular system, and maybe you want to use that configuration for the kernel on multiple systems, except that you don't have the kernel source installed on that system. You want to pull the configuration from the running kernel. Well, there's a couple of different ways to do that depending on what you may have on that particular system. So the first way to do it is to actually pull it from the proc sudo file system. The problem with that is that you need to have a particular configuration set on your kernel to begin with. So let's take a look at that for just a second here. Now, in order to have that configuration available from the running system, you need to, when you build it, go to a setting here where it's for kernel config mode. The setting is actually for kernel config support, and you can see it's turned off here. And so what we can do is turn it on there so that if this were enabled on this particular kernel, you would find it at this file right here, the /proc/config.gz. Now, that's not always available on many systems. So the other place is if we go to the boot directory, you'll see that there are a number of config files there. So let's just take a look at one of these. So this actually happens to be the kernel that's running at the moment. And you can see what a configuration file looks like. It's got the configuration settings, and you either say Y or N, or in the case where you wanted something to be modular, you would set the value to be M. Now, you'll also notice here that anything that doesn't have a setting, it just simply is commented out and it says not set. So what that means is this particular configuration just isn't built. So it's effectively like having it set to N rather than Y. So we just don't set it. It doesn't get built. The ones that are configured, and you can skim through this, it's a fairly long file, but you can see all of the configuration settings. Now, what I can do here, I could actually copy that particular configuration file into my source directory where I've got my Linux source. And then I would be able to build straight out of this running configuration. So if I were to do this, and then we go into our Linux source directory, and then we do a make menu config again, what you'll see is all of the configuration options on the kernel that is currently running in memory will be enabled on this. Now, of course, I could tweak it from here if I wanted to and just use the running configuration as a starting point. But again, if I want to use the configuration from a particular system, there are a couple of places I can do it. Maybe it's available as a text file in the boot directory, or it's possible that if the particular option in the kernel has been set, you could find it in the proc sudo file system as a configuration file there. We're going to take a quick look at iptables. iptables is the firewall that comes on Linux distributions. So iptables is actually a set of kernel modules. If we do an ls mod, we should be able to see the different modules that get loaded as part of iptables. Now, the first one that we can see is iptables here, and then there are others like iptable filter, and we've got nfnat, nfnat ftp. So there are a number of kernel modules that actually get loaded up, depending again on how you've configured your kernel and what you've allowed to be built in versus modules versus what you're just simply not building in at all. So I can run the iptables command to get a listing of all of the iptables rules, and we're going to do verbose output. So these are all of the rules that are loaded in the iptables rule set. These are all loaded in the kernel at the moment. You can see there's an awful lot of them, and we'll take a look at the different things that you can do with these rules and how you can manage them more effectively and more efficiently. And we'll do that coming up over the next few lessons. One thing that people want to do with an iptables firewall is network address translation, or NAT. What NAT does is it takes the IP address from the sending side and replaces it with a different address, so that when the return packet comes back from the server you're communicating with, then it's going to come back to the firewall first, and then the firewall is going to do that replace again to be able to get it back to its original sender. So there's a couple of things that we need to do in order to make this a reality. So the very first thing is we need to make a change to the system. So we're going to say sysctl -w. So we need to make a kernel change here, net.ipv4.ip_forward. And the reason for doing this is because we actually need to be able to send packets that are coming in on one interface and to be able to send them out on another interface, and that's called forwarding. So now I'm just going to edit a rule here. So I'm going to say fw.rules. Now I can certainly do this in memory, and that will actually take, but let me just show these to you very simply here. So When I create a rule in iptables, what I'm doing is really just calling the program iptables with a number of parameters. So I'm saying my table is going to be nat, and the chain that I'm using here is post routing. So we're going to append to our post routing chain. And then my output interface is going to be ETH0, and then I'm going to say masquerade, and that's going to turn on NAT for me. So now I need a couple of other rules here. I need to say on my forward chain, I need to say my input ETH0 and my output ETH1, and I'm going to match on state, where the state is going to be related and established, meaning this is only going to work for messages that have already gone outbound for us. This isn't going to work the other way around. Any new connection is not going to be accepted in this direction. So now we're going to say sbin iptables minus a forward again here, minus I ETH1. So basically we're going in the other direction, and we're just going to accept these. So basically anything that is coming in from my internal interface is going to be okay, and it's going to be forwarded out to the external interface, where ETH1 is my internal interface and ETH0 is my external interface. But anything that is coming in the other direction is only going to be allowed if we first send something out. So this one is going to be my outbound rule, and this one is going to be my inbound rule here, and that's only going to be acceptable if we've actually sent something out first. If we have sent something out, anything coming back is going to be either related or established. So we're going to allow the things coming back in without allowing anything new. And let's just save this. So we talked about the IP forward. Now I changed that on the fly. If you actually want to use this on a persistent basis, and we have talked about this previously, but let's just take a look at sysctl.conf. And then if we find IP forward, now what I would want to do here is uncomment this in order to allow forwarding to take place as soon as I did a reboot. And that would allow this particular setting to be persistent across multiple reboots. Once that was the case, the rest of the rules in the iptables firewall would take effect, and then we would have network address translation across the two interfaces on our system. This assumes, of course, that you've got two interfaces. Otherwise, network address translation doesn't work as well. So you really need the two network interfaces. You set those rules and then set the kernel parameter IP forward, and you've got network address translation. Let's talk a little bit about the way iptables organizes itself in memory and how it puts all of the rules together. At the very top, you've got a number of tables, and with iptables, there are actually 4 built-in tables. The first table is the filter table, and then there is the NAT table, the mangle table, the raw table, and underneath each of the tables is a set of chains, and that specifies where the rules actually get applied. So for example, in the filter table, you get an input chain, an output chain, and a forward chain. With the NAT table, you'll get a pre-routing chain, a post-routing chain, and an output chain. We can see the different tables by doing iptables, and then I can specify for example, the mangle table, and then I just want to get a list of what's in there. So at the moment, there is nothing in the mangle table, and we can take a look at the NAT table as well in the same way. So nothing in the mangle table. Now, the default table for iptables is the filter table. This is where you're going to see all of the rules on this particular system. If I had multiple interfaces on here, then what I might do would be to have more in the NAT table so that there would be pre-routing, post-routing based on the interface that we were coming in or out of. Again, we've got a number of built-in tables with iptables. Of course, you can create your own tables as well. Most installations aren't going to have much of a need to do something like that because the filter table, nat table, mangle table, and raw table are really going to suit their needs. Again, you want to think about how iptables is actually organized. At the very top is the table. Underneath that, there are chains that the rules would then be applied to. So you can have a lot of different rules, and some of those rules are going to be part of one chain inside one table, and then others are going to be part of a different chain inside a completely different table. In order to have an iptables rule, you need to have something that you are going to apply that rule to. So commonly, you're going to do some sort of matching because you need to have kind of a bucket to put the packet into so that you can figure out what you're going to do with that particular packet. Let's take a look at some different things that you can do with matching in iptables. So let's say we're going to do iptables and we're going to use the input chain. Of course, this is going to go into the filter table, which is the default. I could specify -t filter here. It's not necessary in this case because iptables assumes we're putting it into the filter table since we didn't specify a specific table to put it into. Now, I'm going to say -p is going to be protocol. TCP is the protocol that we're going to match on. And I can do a source port of, for example, 4567. Now, similarly, I can do D for destination port. And then I could say, for example, 22, or I could say 80. So that's how you would match on ports associated with a particular protocol. Now, I can also match with flags associated with TCP. So what I can do is match again on TCP, and then I can say TCP-flags, and then specify the flags that I actually want to match on. So I could say SYN, FIN, push, and urge. If a packet came in with all of those flags turned on, first of all, it would be really bizarre. And secondly, if those were matched, then I could do something with it. Probably what I would want to do with it would be to simply drop it, because clearly that's not a well-formed packet. It can't possibly be doing anything good. So similarly, I can also just look for SYN messages. So if I just do --SYN, that would work as well. And then I can also look for TCP options. So if I were to be looking for a particular TCP option, I could specify that there as well. So TCP is not the only thing we can do. We can also say UDP, and then again, I can do S port, and I can do D port. Since there aren't really a lot of options with UDP, that's really about the only thing that we're going to be able to do is just source port and destination port. That's really kind of about the only thing in a UDP header that you're going to have much of any interest in looking at. There's not really much else in a UDP header. We're going to look for source port, and we're going to look for destination port. Now, when it comes to ICMP, we can match on ICMP. So we can specify the ICMP type, or we could say ICMP type 8. And then once you have matched on that, you could make a determination as to what you want to do with the packet. The other thing we can do is match on destination IP address. So I could say 192.168.1.7. We could say the destination there, and then we could, of course, also match on protocol is TCP, and then D port is, let's say, the destination port is 80. So similarly, I can also specify a source address. So let's say my source address is 172.16.42.42, and then I might say P is TCP, and then my source port, I might match on something like this. Although I could just match on source address. I don't have to match on ports as well. I could just use the address. So you can see there's a lot of different ways we can write matching rules using iptables, and we've just looked at some small number of these rules, and these are fairly common ones that you would actually use. I want to take a look at some additional matching rules. There are more complicated ways to match, and you may or may not use some of these, but it's worth taking a look at them anyway. We're going to again run iptables, and then we're going to say this is going to be on my input chain. So minus p TCP, and then we're looking for SYN messages, and then we're going to match on limit. So we're going to say that we have 1 packet per second, and then we can say minus j accept. So we're only going to allow 1 packet per second that has a SYN flag. So we're only going to really allow 1 connection per second to be established with our server. We can do rate limiting with iptables. So there are some other things that we can do, for example, minus p TCP, and we're going to look at TCP flags. So the flags that we are going to look at are SYN, ACK, FIN, and reset. And out of those, only reset is set. And again, we're going to do a limit rule here. And again, we can do limit is 1 per second. And again, we could do minus j accept. So this is really the important part here. What it says is iptables needs to look at SYN, ACK, FIN, and reset. Out of those flags, only reset can be set as a flag. If any of the others are set, it won't match this rule. So this isn't just a question of is reset set. What this says is reset exclusively out of SYN, ACK, FIN, and reset. So what this says is it's a way of slowing down a port scanner, for example. The other thing that we can do is we can protect ourselves with some rules that would protect against ICMP flood. We could say ICMP type is echo request, and then we're going to do a limit match again, and we're going to say limit 1 per second. And again, we're only going to accept that 1 per second. So we're rate limiting echo request messages. There's really no great reason to have echo request messages coming in any faster than that anyway. We're going to rate limit our ICMP echo requests here. We can do all of those things with just this matching capability that we've got in iptable. We can match based on flags, making sure that specific flags are exclusively set. And of course, we can rate limit using iptables as well. We're going to take a look at another way of doing matching, and this is very specifically related to the stateful nature of iptables. When I talk about stateful nature, what I'm talking about is the fact that iptables actually keeps track of every connection flow that is going through it. Every protocol, every connection has a state when it goes through iptables. When a message goes through the firewall for the first time related to a specific source port and destination port, that is a new connection. So the state for that is new. When we've got one where we've already seen the initial packet, then we've got an established state. Once we get the SYN ACK back, now we've got an established connection because we've already sent the new one through, even though the three-way handshake is not yet complete. From the perspective of the firewall, we are still talking about an established connection. The reason for that is because from the firewall's perspective, we've already seen a message go through. So the next message coming through in the reverse direction is established because we already know about it. What we can do here is we can say minus M state. So we're going to match on the state, and that is not the state of the individual packet. That's actually referring to the state table that iptables keeps track of. I can say state now, and I can say new. And with that, I can say accept. So new messages, I'm going to accept. With established states, we might also say minus J accept. Now, the other state that's a little bit harder to explain is the related state. This is a little bit easier to understand when you think about FTP, and maybe you don't know how FTP actually works at a protocol level. What happens with FTP is your client establishes a connection with the server. when you are connecting to the server and asking for a file to be sent to you, in some cases, specifically cases where you are using active FTP rather than passive FTP. In most cases, this is handled by the client and it's not something you're even aware of necessarily. But if you are using an active FTP server, what happens is a connection comes back to you from the server. This is a brand new connection. But from the perspective of iptables, we already knew about this because it's FTP, it's a different port, yes, but since we already knew about the control channel connection, we kind of expected a data channel connection as well. So that related means that it's associated with an established connection. So we already know about the established connection. The related says, yeah, this is one that's going to be attached to one that's already established. So we're going to allow that one as well. Now, there is another state. We can say invalid. Those are ones that you may want to discard. Eventually, you may see just an invalid state. And certainly those are ones you probably want to dump, if not maybe log. When we're talking about matching state, we are talking about new, we're talking about established, and we are talking about related primarily. Although an invalid state is possible, that just means that the packet for some reason couldn't be identified, and so we just don't know what it is. Now that we've figured out how to do all of this matching, we need to figure out what we are going to do with the packets once we have matched them. Let's say that, again, we are working on the input chain, although we could just be working on the output chain as well. Let's talk about using the output chain. Just for example, it doesn't much matter what we're talking about. The rest of it is still going to apply. So let's say that we are matching on a destination IP address. Let's say we are talking about 172.19.34.42. What I'm going to do here is add a -J, and this is saying jump. So we are going to jump to a particular target, and there are a couple of targets that you're going to see a lot. One of them is going to be accept. What this says is if this matches, we just automatically accept it, and the packet is allowed to pass through the firewall. By contrast, of course, you can do drop. Now, drop just means just discard the packet, don't do anything further with it. There is another target that you probably want to know about, and that's log. Log says write a log message out. This isn't really very surprising. Write a log message out. It's going to go to the system log utility or syslog, and it's going to write a message indicating what was found from the packet. The thing about this is if you want to do something like drop and log so that you know whether something was dropped, it has to be two separate rules. A drop doesn't automatically generate a log message, so you can just drop it without necessarily logging it as well. I could do a -J drop and then a log message indicating that the packet actually came in. We're going to be using targets. No matter which table or which chain you are talking about, you're going to be using the jump rule or -J in order to jump to a target, whether it's allow or whether it's drop or whether it's just log. At this point, I want to take a look at the logs that iptables will actually generate. Typically, these are kernel logs, and so just like the startup messages that a kernel will generate, if I were to, say, type dmessage, which would spit out the kernel messages, I'm going to get the most recent kernel messages, and all of these have overwritten all of the startup messages, so what I'm getting now is just these iptables logs. So the other place that I can get these is, and I need to have administrative privileges to get them. So I'm just going to say var log syslog. On this particular system, it's going out to the syslog file. It may go out to the file messages. On other systems, this Ubuntu system happens to write it out to the file syslog. So what I've got is a set of kernel messages that show up in the syslog file. you can see that what we've got here is a message saying that it was blocked. We've got the input interface. The output interface is left blank here because there isn't one. It wasn't forwarded anywhere. It just came in on ETH0. ETH0 is the only interface on this particular system. Then we've got the MAC address that is associated. We've got a source IP address and then a destination IP address. In this case, this happens to be a multicast address. So what we're doing is we are blocking multicast messages from coming in. So we've got a length, and then we've got type of service, we've got TTL, we've got an ID, and then we've got the protocol number, which in this case happens to be 0. These are the messages that we get when iptables actually logs out. They look exactly like this. Of course, they're going to be variant depending on the type of messages that you're getting. You may have an out interface specified, but typically this is what it's going to look like. You're going to get a line that looks exactly like this, and this is what an iptables log message actually looks like. Once you've gotten used to seeing them, they aren't really that difficult to understand. You're not going to get a ton of information about it. You're going to have to figure out what happened based on what you are seeing. So you're getting a source address and a destination address. You should also get a source port and a destination port. If we were doing something other than blocking multicast messages, you would get a little bit more information. In this case, they're just multicast messages, so there's not much else to actually say here. When we're talking about multiple interfaces, there's a couple of things to be concerned with. First of all, I need to be concerned with the interface. Let me just put this into the input chain for a start here. What I need to be worried about is which interface that I'm talking about. -I specifies the interface, so I could be ETH0, ETH1, ETH2, and so on. The other thing that I need to be worried about is forwarding. So if I've got an input interface, so that's going to be ETH0, for example, and then I've got an output interface. If I'm doing forwarding, I'm sending messages from one interface to another. So now I've got to have both an input interface and an output interface, and then I can specify match rules, as we've talked about previously, to determine what I'm going to do with that. So let's say TCP and then S-port or D-port rather, and 80, and we'll just accept all of those. Now I've got an accept rule where I'm forwarding from ETH0 to ETH1 TCP with a destination port of 80. I'm going to allow all of those. Of course, the input interface isn't always going to be the same. I may have an input interface of ETH1. This has to do with the direction of traffic. So let's say my ETH interface is going to be my internet-facing interface, and my inside interface is going to be ETH0. Well, now I'm talking about messages that are coming in from the internet and being forwarded onto my local network. So now we're talking about a whole different ballpark here where I may have different sets of rules that I would want to apply. So I'm going to forward from the outside to the inside, and then I'm going to specify -p TCP, and then we'll say source port, for example, is 80 and J accepts. If the source port is 80, that means it was something that was communicated with on the outside as a web server, probably. So the destination port on the outbound is going to be 80, which means on the inbound, the source port is going to be 80. If that's the case, we'll just accept that. If I've got multiple interfaces, I need to be concerned about directionality. I need to be concerned about whether it's the input interface or the output interface, if we're talking about forwarding rules. And if we're just talking about input-output rules, you still need to be worried about what interface you're actually talking about, whether it's ETH0, ETH1, or the name of some other interface. Firewalld is a different type of firewall. It's really an enhancement, or I guess maybe you can think of it as the next generation firewall for iptables. What we have with Firewalld is perhaps a simpler way of administering your firewall, but it also provides the ability to better handle mobile systems. Now, when iptables was first developed, we didn't have the kind of roaming that we have now. So you've got laptops that are all over the place that are connecting to multiple networks. iptables isn't really designed to be able to easily handle lots of different rules. And so what we end up with is a lot of different rules that may only apply in certain cases, or you may have a number of different rule sets that you have to constantly load and reload. That's fixed with Firewalld. What Firewalld gives us is the ability to have multiple zones. And we will look at the different zones a little bit later on. But what we get with zones is really the ability to cluster a group of firewall rules so that those rules apply to specific situations. So you would have a public zone, for example, or a private zone, or you may have a home zone. Using this firewall command tool, I can check the state of the firewall, which tells me that it's running. I can get a list of the zones. So here I've got block, DMZ, drop, external home, internal public, trusted, and work. Now, there are a lot of other capabilities that we get with Firewalld. Let's just talk about what Firewalld gets us is the ability to have collections of rules that are more easily applied and make more sense because I can name them in ways with these zones that apply very easily to the situation that I'm in. So the home zone makes perfect sense to me, right? Public zone, well, that's if we're down at your neighborhood coffee shop or at an airport where there's shared Wi-Fi. Firewalld is the default firewall on RedHat servers, but it's also something you can put on Ubuntu servers and other Linux distributions as well. So I happen to be running it here on an Ubuntu system. It doesn't come installed by default. You actually have to go install it, and you can uninstall the uncomplicated firewall in order to install Firewalld on an Ubuntu system. But we'll talk more about zones and services coming up in subsequent lessons. Now, previously, we had used the firewall command line program. This time around, we're going to take a look at the graphical interface here. What I want to do is edit firewall settings. So what I've got is the firewall applet installed and turned on my Ubuntu system. You can see what we've got is a list of the zones. And the different zones have different services that are enabled in them. So you can see the list of services that we've got. And if I were to click on one of them, you could see the ports and protocols that were in use. We'd also get modules if there were any, and then any destination rules if we needed any of those. And just kind of click through and see that I've got the ability to specify really rich services here. I can have multiple ports and protocols associated with any particular service. This is different, of course, from iptables, where I would have to have a different rule based on each specific port. What I can do is go to any of the zones here and specify the services that I actually want to allow through. I can also add specific ports if that's what I want to do. I can turn on port forwarding, and I could do masquerading, which would be NAT. I've also got the interfaces that I want to include in the zone. And you can see we've got a lot of capabilities just from this really simple firewall tool here. Now, one of the things that we had a problem with iptables was I could make changes in memory, and we never really talked about this before, but I want to talk about it now. If I were to make changes in memory, then they were not permanent. In order to make them permanent, I had to write them out to a file out of memory, and then I had to make sure that I was loading in from that file when I loaded up my firewall. We can specify a runtime configuration, meaning any change that I make is going to be made in memory. I can specify a permanent configuration change, which means it's actually going to be written out to disk. Here's a place where they've really kind of addressed very nicely, I think, the difference between in-memory changes and on-disk changes. With iptables, as I said, if I changed one, I didn't necessarily change the other. And of course, that's true here as well. It's just more apparent which one you're actually doing. One other thing that I can do with Firewalld, and I'm going to go back into editing my firewall settings here, is let's just go to my home zone. And again, you can see the tabs across the top here indicating the things that I can do on my home zone. I can add or disable services. I can make changes to ports and add rules based on that, masquerading port forwarding, ICMP filtering. What I want to talk about here, though, is the rich rules. So if you've got a more complicated rule than just services or ports or masquerading, what you can do is go into the rich rules and you can add those. Let's just say I want to do IPv4 only in this case. So the element I want to do is work on a service here. So I'm going to select the service. Let's just say it's IPsec. So what action do I want to do? I want to reject with type. I could certainly do that. In this case, I want to accept with limit. I could say 5 per minute, or I could say 1 per second, for example. Let's just say 15 per minute. So my source is my IP address that I want to accept as a source IP address. I could do an address. I could do a address with a mask. So for example, I could say 172.30.42.0/24. And then I could do a destination here as well, if I wanted to do that. In this case, I don't want to. But I could certainly do inverted, meaning that everything other than this would be what the source would be. I can do inversion rules there. So now I can log and I can specify the level of the logging that I want to do. And then, of course, I can limit the amount of logging that I want to do as well. I can also set an audit rule. And if you were using auditd, for example, as system auditing, you could enable this and it would send messages out to your audit daemon. So once I specified all of this, now I create my rule, and you can see the rule is right there. We have the capability to do rich rules, but if you're really just doing pretty basic firewalling, you're going to be talking about services and ports, maybe some port forwarding, and certainly you've got the capability to do rich rules if that's what you would want, where it's really a combination of a number of different elements. So you can add those rich rules in and really add as many as you want, of course, realizing that the more rich rules you add and the more firewall rules you add in general, the more complicated your firewall rule set is going to be. And complex rules can sometimes lead to less secure firewall installations. We've been talking about iptables, and really at the heart of older versions of Linux is iptables. But with Ubuntu systems, they've actually got a system that overlays on top of iptables. And that is something called UFW, or uncomplicated firewall. And what it is kind of a wrapper, I guess you could think about it, over the top of iptables. So with UFW, I can do very simple things. I can do something like enable, and I can also disable. Let me just re-enable it here, and then we can get a system status. So if I were to say UFW status verbose, I would get the status of it, including some rules that were in place. Now, I want to talk about how to actually create rules. So I can say UFW, and this is much easier than iptables. I just want to allow port 80 TCP. Now we can go back to status, and suddenly we've got a rule there, both for IPv4 and IPv6, as a matter of fact. The other thing that I can do is I can say UFW, and we're going to deny, let's say 8080 on TCP. So now we've got our rule. Again, I've got my status, and I can show that. The other thing that I can do is reverse the rule and I can re-enable 8080. Perhaps it's just easier to say UFW delete, deny 8080 TCP. Now, if I check my status, the rule is entirely gone. So as a matter of fact, I want to, at this point, remove that rule as well, and I can check that. The other thing that I can do is say, allow SSH. Now, if I check the status, we have allowed port 22 because, of course, that's the SSH port. What happens here is it actually looks up the name of the service from the etc services file and then just puts the correct port in place for us. So you don't even have to know the port necessarily. You just enable the service name and UFW figures out the port for you and puts it into the rule set automatically. UFW makes it so much easier to be administering your firewall that iptables almost becomes obsolete just by using UFW on an Ubuntu system. You don't have to worry about the complicated rules that you are using with iptables. If you're just doing simple things like enabling and disabling services, you can do it with UFW really, really easily. Now we've done UFW with the command line. There actually is a graphical interface for it. Just so you're not sweating too much, I can show you the graphical interface, and it's just GUFW. Here, we've got a handful of different profiles. We've got home, public, and office. I can set the status on or off. All I have to do is click one side or the other, and it either turns it on or turns it off. Now we've got a default policy. Incoming, the default is going to be deny, and outgoing is going to be allow. So I could set my default policy to be allow, which is going to allow everything in. Typically, you would want deny to be your incoming policy. So here we've got the rules. These are the ones that we had set before, and I don't have an awful lot of screen real estate here. This top part takes up an awful lot. We do have 3 sections here. We've got listeners down here, so you can look at the services that are actually listening. And what I can do here is to create a rule based on one of these lines. We'll just pick one of them here. So let's just pick named and then click plus. Now it's going to just automatically create a rule for me. In order to add this rule, so I can specify allow, deny, reject, or limit, what I can do is click add, and then I can close it. So now we've got the rule in up top here. If I want to get rid of the rule, all I have to do is click the minus. Rule is now gone. GUFW, very, very simple user interface that will allow you to manage your UFW rules. You can create new rules, you can drop the rules that are there, you can take a look at all of your listeners, and then of course we've got the status log here in terms of what you are doing. So you can see the actual UFW commands that are being executed when we make changes using this graphical user interface. Well, let's wrap up. What did we cover? Well, we covered a fair amount of ground, I think. We covered what a distribution is, the different distributions that are available. We made use of a couple of different distributions. We looked at CentOS, which is binary identical to Red Hat Enterprise Linux. And we looked at Ubuntu, as well as taking a look at a specialized distribution of Linux called Kali Linux. We looked at the boot process, the 2 bootloaders, GRUB and LILO, as well as protecting the boot process and how you can edit boot menus. We looked at services, the different types of services you might see on a system, like Apache or a Java application server. We also looked at Postfix and how to make use of gray listing to keep spam away from your mail service. We looked at hardening the various services and the different configuration changes you might make to make your services more robust and protect them against attack. We looked at logging, syslog, log management, remote logging, so sending logs off to remote systems so that you've got an extra copy somewhere in case something happens to the system where the log was generated. We talked about intrusion detection. We talked about network-based like Snort. We talked about host-based like using Samhain or Aid. And we also talked about using other utilities like Prelude, for example, to manage your IDSs and have some consoles available so that you can actually see the different alerts and messages you're getting from your intrusion detection systems. We talked about users and permissions. We talked about AppArmor and SELinux, which are both implementations of mandatory access controls. Talked about adding users, setting password policies, and using the pluggable authentication modules, which is also known as PAM. Looked at different utilities, networking. So we looked at Nmap, for example. We looked at security-related tools. We looked at vulnerability scanning. We also took a look at the Linux kernel. So the kernel source, we looked at modules, configuring the kernel, building the kernel. Then we looked at firewalls. We took a look at iptables, Firewalld, and then the uncomplicated firewall, which is called UFW. So we did cover a fair amount of ground here. It's an awful lot to digest. So in the next lesson, we'll be talking about what you can do next. So what comes next? Well, I would really recommend doing a lot of hands-on work. Download some distributions. CentOS.org will give you a free distribution of CentOS. CentOS is binary compatible with Red Hat Enterprise Linux, so it's just like you're using Red Hat Enterprise Linux without paying for it. Ubuntu.com will give you distributions of Ubuntu, of course. If you're looking for something else, you can go to distrowatch.com. There are a large number of Linux distributions that are available if you feel like playing. I happen to be looking at one here that's apparently based on Ubuntu called Peppermint OS. Sounds like it might be a little bit of fun to play with. If you need systems, get virtual machines. VMware Player is free. VirtualBox is free. This is virtualization software that will allow you to run Linux inside of Windows. If you've got a Mac, you can use Parallels. VirtualBox will also run on a Mac. Mostly play. Just get in and start working with the utilities and the tools and things that we've talked about. You can certainly set up a network. You can do this inside of virtual machines. You can have multiple virtual machines running at once. I will recommend you get an awful lot of memory if you want to run multiple virtual machines. Implement yourself a firewall with Linux. Install a web server. Make use of it. Do some of the things that we've been talking about. I can't stress enough getting your hands dirty and just playing with it. As I said, hands-on. Get some copies of Linux. Try Kali Linux, for example. With some versions of Linux, you can actually boot directly to a live running instance of it without even having to do an installation. So try some of those, but really hands-on work, install Linux and start making use of it and start installing things like Snort and trying to throw attacks at it so that you can see the various alerts that it will show. So again, I'm going to say it again, and I've said it several times by now. Get some copies of Linux. Get your hands dirty. Play with it. Make use of it. That's the best way to really get a handle on what all of this looks like and how you can best make use of it. So just to wrap up, really want to thank you for taking the time to watch these videos. It has been my pleasure to walk through the different aspects of Linux security in order to help you better understand it and get to the point where you can actually make use of and implement some of these things for yourself in your personal life, in your work life, wherever it is you end up using this knowledge and information. I hope it has been valuable to you. Thank you.